Welcome to Quiet Law YouTube channel. You've arrived at a place of rest, a threshold between waking and sleep. For the next few hours, we will journey together through the forgotten wonders of our natural world. Not the famous landmarks, not the crowded destinations, but the quiet marvels that exist in the margins of human attention. Places and phenomena that unfold without audience, without fanfare, simply because they must. This is not a journey that demands your focus. There is no test at the end, no need to remember names or facts. Instead, let these words wash over you like waves on a distant shore. Let the descriptions blur at their edges. If you drift away mid-sentence, that is precisely as it should be. These wonders have existed for millennia without your awareness. They will continue long after this night has passed. We begin where perhaps all wonder begins, in the sky above us, in the envelope of atmosphere that separates Earth from the infinite dark of space. The air around our planet is not empty. It is a theater of light, a canvas upon which invisible forces paint in colors that seem impossible, in shapes that defy expectation. These are the ephemeral wonders, the ones that appear and vanish, that cannot be held or preserved, only witnessed in their fleeting moment of existence. So settle in, adjust your pillow, let your breathing slow. The wonders await, patient as stone, luminous as starlight, asking nothing of you but your presence in this moment, and then, eventually, your gentle surrender to sleep. We begin our exploration in the far reaches of the southern hemisphere, at the bottom of the world, where the continent of Antarctica sits encased in ice that has accumulated over millions of years. Above this frozen wasteland, on nights when the darkness is complete and the air is clear, the sky itself comes alive with curtains of light that ripple and dance across the heavens. This is the aurora australis, the southern lights, a phenomenon that mirrors its more famous northern counterpart, but occurs in a place where few human eyes can witness it. The aurora australis is born from the relationship between our sun and our planet. The sun, that massive ball of fusing hydrogen some 93 million miles away, continuously throws off streams of charged particles into space. This solar wind, as it is called, travels through the void at speeds exceeding 1 million miles per hour. When these particles reach Earth, they encounter our planet's magnetic field, that invisible shield generated by the churning of molten iron in Earth's outer core, deep beneath our feet. The magnetic field lines converge at the poles, creating pathways that funnel these solar particles down toward the surface. As the particles, primarily electrons and protons, descend through the upper atmosphere, they collide with oxygen and nitrogen molecules in the air. These collisions transfer energy to the atmospheric gases, exciting their electrons to higher energy states. When those electrons return to their normal state, they release that energy as photons of light. Oxygen produces the greens and reds we see in auroras. Nitrogen creates the blues and purples. The aurora australis typically occurs between 40 and 400 miles above the Earth's surface, in a region of the atmosphere called the thermosphere. The displays are most intense during periods of high solar activity, when the sun releases particularly powerful bursts of particles in events called coronal mass ejections. But even during quieter periods, the aurora persists, a constant shimmer above the Antarctic ice, visible to the penguins and seals and the occasional research scientists stationed at one of the scattered bases on the continent. The colors shift and flow like fabric caught in a celestial breeze. Sometimes the aurora appears as a diffuse glow on the horizon. Other times it forms distinct arcs that stretch from one end of the sky to the other. In the most active displays, the light organizes itself into rays that seem to radiate from a central point, creating what is called a corona effect. The entire display can pulse and flicker, can intensify and fade, following rhythms dictated by the continuous interaction between solar wind and magnetic field. Indigenous peoples of the southern hemisphere had their own explanations for these lights. Some Aboriginal Australian groups believed the aurora was a dance of spirits. In New Zealand, the Maori saw the lights as fires lit by ancestors who had travelled to the frozen south. These interpretations, while not scientifically accurate, captured something essential about the aurora's character. It does seem alive, does seem purposeful in its movement, even though it is simply physics playing out on an atmospheric stage. From the southern lights, we travel north and west, across the Indian Ocean to the northern coast of Australia, to a place where the morning sky sometimes births clouds unlike any other on Earth. These are the morning glory clouds, a meteorological phenomenon so rare and so geographically specific that pilots and cloud enthusiasts travel from around the world for a chance to see them. The morning glory cloud is what meteorologists call a roll cloud, a low, horizontal, tube-shaped formation that can stretch for hundreds of miles across the sky. But calling it simply a roll cloud does not capture its majesty. Imagine a cloud shaped like a massive cylinder, lying on its side, rolling slowly through the air like a wave frozen in time. The cloud can be up to 1 mile high and 1 to 2 miles wide. Its length is extraordinary, sometimes extending more than 600 miles from end to end. Multiple morning glory clouds can appear in succession, wave after wave of them, marching across the sky in parallel formation. These clouds appear most reliably in the Gulf of Carpentaria region of northern Australia, particularly near the small town of Bucktown, during the months of September and October, which is late dry season in this part of the world. The formation of morning glory clouds requires a very specific set of atmospheric conditions, which is why they occur so rarely elsewhere on the planet. The process begins with the geography of the region. The Cape York Peninsula juts northward, separating the Gulf of Carpentaria from the Coral Sea. During the day, sea breezes develop on both coasts of this peninsula. The eastern sea breeze, from the Coral Sea, is typically stronger. As night falls and the land cools, these sea breezes collide over the peninsula. The collision creates a wave in the atmosphere, similar to the wake created by a boat moving through water. This atmospheric wave travels westward, out over the Gulf of Carpentaria. As it moves, it creates an area of rising air at its leading edge and sinking air behind it. The rising air cools as it ascends, and if it contains enough moisture, that moisture condenses into cloud droplets. This creates the visible tube of the morning glory cloud. The sinking air behind the cloud evaporates the cloud droplets, which is why the back edge of the cloud is so sharply defined. The cloud moves at a speed of about 20 to 30 miles per hour. As it travels, it maintains its shape, rolling forward through the air in a motion that is both continuous and stable. Glider pilots particularly prize the morning glory because the updraft at its leading edge can be used to stay aloft for extended periods, surfing the atmospheric wave like surfers ride ocean swells. The Aboriginal people of the region, the Garawa and other groups, have known about these clouds for thousands of years. They incorporated the morning glory into their seasonal calendars and their understanding of when to expect certain weather patterns and wildlife behaviors. The clouds were a sign, a message written in condensed water vapor across the morning sky. We remain in the sky, but shift our focus now to a different type of cloud formation, one that appears not over tropical coasts, but over mountains, where terrain forces air into shapes that seem to defy the normal rules of cloud behavior. These are lenticular clouds, and some of the most spectacular examples form over Mount Rainier in Washington state, in the northwestern United States. Mount Rainier is a massive stratovolcano, standing more than 14,000 feet above sea level. Its peak is covered year-round with glaciers, more glacier coverage than any other mountain in the contiguous United States. The mountain's bulk interrupts the flow of air moving across the region, particularly when strong winds blow perpendicular to its ridgeline. When stable, moist air encounters the mountain, it is forced upward. As it rises, it cools. If the cooling brings the air to its dew point, the moisture condenses into cloud droplets. But then, as the air descends on the other side of the mountain, it warms again, and the cloud evaporates. This creates a standing wave in the atmosphere, a stationary ripple of rising and falling air that remains fixed in position even as the wind continues to flow through it. If the atmospheric conditions are right, multiple waves can form downwind of the mountain, stacked one behind the other. And if the air is sufficiently moist, a lenticular cloud forms at the crest of each wave. These clouds appear lens-shaped, or sometimes like flying saucers, smooth and rounded with sharply defined edges. They seem to hover in place, not moving despite strong winds, because the cloud is not a fixed collection of water droplets, but a continuously refreshing formation. Individual droplets form on the upwind side, move through the cloud, and evaporate on the downwind side, but the cloud itself remains stationary. The clouds can stack in layers, creating formations that look like a pile of plates or pancakes suspended in the sky. When this happens over Mount Rainier, with the snow-covered volcanic peak in the foreground and these strange, smooth clouds floating above it, the scene takes on an otherworldly quality. It is not surprising that lenticular clouds are sometimes mistaken for unidentified flying objects. Their shape, their stillness, their crisp boundaries all seem technological rather than natural. Lenticular clouds are indicators of strong winds aloft and turbulent conditions. Pilots of small aircraft avoid flying near them because the atmospheric waves that create the clouds can also create severe turbulence. But for observers on the ground, they are simply beautiful, a visible manifestation of the invisible rivers of air that flow continuously around our planet, shaped by the terrain they encounter. From clouds that appear over mountains, we turn now to a phenomenon of light that appears in the coldest regions of the planet, where ice crystals in the air create pillars of light that stretch from earth to sky. These are light pillars, vertical columns of light that seem to connect ground-based light sources with the heavens above. Light pillars appear most commonly in places like Canada, Alaska, Scandinavia, and other high-latitude regions during winter months. They require very specific atmospheric conditions. The air must be cold, typically well below freezing, and calm. Ice crystals must be forming in the lower atmosphere, and these crystals must be of a particular type. They need to be flat, plate-shaped crystals, hexagonal in structure, like tiny mirrors suspended in the air. When the air is calm, these ice crystal plates settle through the atmosphere with their flat surfaces oriented horizontally, like leaves falling in still air. They drift slowly downward, maintaining this horizontal orientation. When light from the sun, or from artificial sources like streetlights, strikes these horizontally oriented crystals, it reflects off them. Because the crystals are spread vertically through the air column above and below the light source, the reflected light creates a vertical pillar of illumination. The effect is purely optical. The pillar of light contains no substance. It is not a beam shooting upward into the sky. It is simply the collective reflection of light from millions of ice crystals arranged at different heights. If you were to move to a different position, the pillar would appear to move as well, because you would be seeing reflections from a different set of crystals. Light pillars from the sun appear around sunrise or sunset, when the sun is at or below the horizon. The pillar extends vertically from the sun's position, sometimes reaching high into the sky. It can be white or, if the sunlight is colored by atmospheric scattering during dawn or dusk, it can take on orange or red hues. But some of the most striking light pillars appear at night, created by artificial lights. Streetlights, car headlights, the lights of buildings, all can create pillars that stretch upward. In a city during the right conditions, dozens or hundreds of light pillars can appear simultaneously, creating a forest of vertical light beams rising into the dark sky. Each pillar is perfectly vertical, each one anchored to its light source, each one flickering slightly as the ice crystals shift and tumble in the nearly still air. The phenomenon is silent. The pillars make no sound. They simply exist, transforming ordinary lights into something that seems mystical, connecting the human world of artificial illumination with the natural world of ice and atmosphere. We shift our attention now from vertical pillars of light to a horizontal flash of color that appears for only a second or two, visible only under very specific circumstances. This is the green flash, a phenomenon that occurs at sunset or sunrise, when the very last or very first glimpse of the sun appears not as the expected yellow or orange, but as a brief flash of vivid green. The green flash is best observed over a clear, distant horizon, which is why it is particularly well known in places like Hawaii, where observers can watch the sun set over the vast, flat expanse of the Pacific Ocean. The phenomenon requires a clear atmosphere and a view unobstructed by clouds or haze at the horizon. To understand the green flash, we must understand how our atmosphere bends light. Light travels in straight lines through empty space, but when it enters a medium like air, it slows slightly and changes direction. This bending, called refraction, depends on the wavelength of the light. Shorter wavelengths, like blue and green, are bent more than longer wavelengths, like red and orange. When we look at the sun at the horizon, we are looking at it through the thickest possible layer of atmosphere. The sun's light must travel through more air to reach our eyes than it would if the sun were overhead. As the light passes through this atmosphere, it is refracted, bent slightly. The different colors that make up white sunlight are bent by different amounts. The red light is bent the least, so the red image of the sun appears lowest. The green light is bent more, so the green image appears higher. The blue light is bent even more, but blue light is also scattered more by the atmosphere, which is why the sky appears blue. This scattering removes most of the blue light before it reaches our eyes when we look at the setting sun. What remains at the very top of the sun's image, after the red and orange have already disappeared below the horizon, is green. For a brief moment, perhaps 1 or 2 seconds, before the sun completely vanishes, we see a flash of green light. It is not actually a flash in the sense of a sudden burst of light. It is simply the final visible color before the sun disappears. The green flash is elusive. Even in ideal conditions, it is subtle. Many people spend years watching sunsets before they finally see it. The human eye is not particularly sensitive to changes at the green wavelength, which makes the flash easy to miss. But when conditions align, when the atmosphere is clear and stable, when the horizon is sharp and distant, the green flash appears, a small gift from the physics of light and air. From this fleeting green flash, we turn to a phenomenon of much longer duration and much greater intensity. We travel to Lake Maracaibo in Venezuela, to a place where lightning strikes with such frequency and such regularity that it has been called the lightning capital of the world. This is the Catatumbo lightning, named for the river that feeds into the lake. Lake Maracaibo is actually a large brackish bay, connected to the Gulf of Venezuela and the Caribbean Sea. It is surrounded by mountains, the Andes to the south and west, the Parija Mountains to the west. The region's topography and climate create conditions that are extraordinarily favorable for thunderstorm development. During the afternoon and evening, warm, moist air from the lake surface rises. As it rises, it encounters cooler air descending from the surrounding mountains. This collision of air masses, combined with the lifting effect of the terrain, creates powerful convection. Thunderstorms develop, and they develop with remarkable consistency. The Catatumbo lightning occurs, on average, about 160 nights per year. During the peak season, from April to November, the lightning can continue for up to 10 hours per night. At its most intense, the lightning can flash as often as 280 times per hour, nearly 5 times per minute, a continuous strobing that illuminates the clouds and the landscape below. The lightning is both cloud to cloud and cloud to ground. The flashes are brilliant, vivid, white and blue-white in color. Because the storms occur over the same area night after night, the lightning has been visible from far out at sea. Sailors used it as a navigational aid, a beacon marking the entrance to Lake Maracaibo. It has been called the Maracaibo Beacon, the lighthouse of Catatumbo. The specific reasons for the extraordinary frequency of lightning in this location are still being studied, but several factors contribute. The lake provides abundant moisture. The surrounding mountains force air upward, enhancing convection. The meeting of Caribbean winds from the north with Andean winds creates wind shear, which helps organize and intensify thunderstorms. The region also sits near the equator, where solar heating is intense year-round, providing energy for storm development. The local people, the indigenous groups who have lived in this region for thousands of years, incorporated the lightning into their cosmology and their practical life. The nearly continuous lightning on some nights made it difficult for surprise attacks, as the landscape would be periodically illuminated. The lightning was a protector, a warning system provided by nature itself. There are occasional breaks in the Catatumbo lightning. In 2010, the lightning ceased for several weeks, likely due to a drought that reduced moisture availability. The absence of the nightly light show alarmed locals, who saw it as an omen. When the lightning returned with the rains, it was celebrated. The phenomenon had become part of the region's identity, a natural wonder that defined the place. While the Catatumbo lightning is predictable and localized, another form of lightning is so rare and so poorly understood that many scientists questioned whether it truly existed. This is ball lightning, a phenomenon reported by witnesses for centuries, but only recently accepted as a real, physical occurrence. Ball lightning is described as a luminous sphere, typically the size of a grapefruit or basketball, though reports vary. It appears during thunderstorms, usually near the ground. The sphere glows, often with a yellow, orange, or red color, though white and blue have also been reported. It moves through the air, sometimes horizontally, sometimes rising or falling. It can pass through windows, walls, or other barriers, or it can simply hover in place. It persists for several seconds, occasionally for more than a minute, before disappearing. Sometimes it fades away quietly. Sometimes it explodes. For a long time, ball lightning was dismissed as an optical illusion, a retinal afterimage caused by bright lightning flashes, or a case of witnesses misinterpreting what they had seen. But there are too many reports, from too many credible observers, often describing similar characteristics, for the phenomenon to be entirely subjective. The problem with studying ball lightning is its rarity and unpredictability. It cannot be summoned. It appears without warning and vanishes quickly. Few photographs or videos exist, and those that do are often inconclusive. Laboratory attempts to recreate ball lightning have had limited success. Some experiments have produced glowing spheres by discharging electricity through certain materials, but whether these laboratory creations are truly analogous to natural ball lightning remains uncertain. Various theories have been proposed to explain ball lightning. Some suggest it is a plasma, an ionized gas that maintains its energy through some unknown mechanism. Others propose it involves chemical reactions, perhaps burning particles of silicon vaporized from soil by a lightning strike. Still others suggest it might be a quantum phenomenon, or involve electromagnetic fields in unusual configurations. None of these explanations has been definitively proven. What we know is that people continue to report seeing ball lightning. Pilots have reported it entering airplane cockpits. People have seen it in their homes during storms. It has been described as moving intelligently, following walls or corridors, though this likely reflects the paths of air currents rather than any true intelligence. It remains one of nature's genuine mysteries, a phenomenon at the edge of our understanding. From mysterious spheres of light, we turn to a more explicable, but no less enchanting luminescence. We travel to Japan, to the town of Toyooka, where on certain summer nights, the fields and forests come alive with the flashing of thousands upon thousands of fireflies. Fireflies, which are actually beetles, not flies, belong to the family Lampyridae. They produce light through a chemical reaction in specialized organs in their abdomens. The reaction involves a molecule called luciferin, an enzyme called luciferase, oxygen, and a compound called ATP, which is the energy currency of all living cells. When these ingredients combine, they produce light with very little waste heat. This process, called bioluminescence, is one of the most efficient light-producing reactions known. Fireflies use their light primarily for mating. Male fireflies fly through the air, flashing their lights in species-specific patterns. Females, typically on the ground or on vegetation, watch these displays. When a female sees a flash pattern that indicates a male of her species, she responds with her own flash. The male flies toward her, they exchange more signals, and if all goes well, they mate. In Toyooka, the species Luciola cruciata is particularly abundant. These fireflies emerge in late June and early July. On warm, humid, still nights, when conditions are optimal, the males take flight in enormous numbers. The fields near rivers and streams become filled with flashing lights, thousands of tiny bioluminescent beacons pulsing in the darkness. What makes the Toyooka fireflies particularly remarkable is their tendency toward synchronization. While each male is flashing to attract females and not to coordinate with other males, the sheer density of fireflies and their proximity to one another can create situations where their flashing begins to align. One firefly sees another flash nearby and adjusts its own timing slightly. This subtle influence, multiplied across thousands of individuals, can lead to waves of synchronized flashing moving through the swarm, or periods where large groups flash in near unison. This synchronization is not perfect or continuous, but when it occurs, the effect is magical. The forest or field seems to pulse with light, breathing in rhythm, as if the landscape itself has a heartbeat made visible. Japan has a long cultural relationship with fireflies. They appear in poetry, in paintings, in literature. Hatarugari, firefly hunting, is a traditional summer activity, though it involves watching rather than catching. The fireflies are seen as symbols of summer, of fleeting beauty, of the transient nature of life. Their brief adult lives, only about 2 weeks, during which they light up the night, become metaphors for the ephemeral quality of existence. The larvae of fireflies live in water or moist soil and feed on snails and other small creatures. They can spend 1 or 2 years in the larval stage before pupating and emerging as adults. The adults eat very little or nothing at all. Their sole purpose is reproduction. They light up, they find mates, they lay eggs, and then they die. The lights that fill the summer nights are the final acts of these insects, their last bright moments before darkness. From the fields of Japan, we cross the ocean to the Caribbean, to the island of Puerto Rico, where a different type of bioluminescence illuminates not the air but the water. These are the bioluminescent bays, among the most spectacular examples of aquatic bioluminescence on Earth. Bioluminescent bays exist in several locations worldwide, but Puerto Rico is home to some of the brightest. The phenomenon is caused by microscopic organisms called dinoflagellates, specifically a species called Pyridinium bohemense. These single-celled organisms possess bioluminescent capabilities as a defense mechanism. When the water is disturbed, the dinoflagellates emit light. The exact reason for this response is still debated. One theory is that the light startles predators or attracts the predators of predators, creating a distraction that allows the dinoflagellate to escape. Regardless of the evolutionary reason, the result is that any disturbance in the water causes the dinoflagellates to glow. In a typical ocean environment, dinoflagellates are too dispersed to create a noticeable glow. But in certain sheltered bays with the right combination of nutrients, salinity, temperature, and lack of tidal flushing, the dinoflagellate population can explode, reaching concentrations of hundreds of thousands, or even millions of organisms per gallon of water. Puerto Rico's bioluminescent bays are narrow, mangrove-enclosed inlets where fresh water from rain and streams mixes with salt water from the ocean. The mangroves provide nutrients and shelter. The narrow openings to the sea mean that water is exchanged slowly, allowing dinoflagellates to accumulate. The bays are shallow and warm, perfect conditions for these organisms to thrive. When you move through the water in one of these bays at night, every motion creates light. A hand dragged through the water leaves a glowing trail. Fish swimming beneath the surface appear as streaks of blue-green light. Raindrops hitting the surface create expanding rings of luminescence. If you dive under and then surface, the water that runs off your body glows. The entire bay seems enchanted, as if the water itself has absorbed starlight and is releasing it. The light produced is a cold light, blue-green in color, similar to the light produced by fireflies. It lasts only a fraction of a second for each individual organism, but because there are so many dinoflagellates, and they are constantly being disturbed by movements in the water, the glow appears continuous. Mosquito Bay on the island of Vieques, off the eastern coast of Puerto Rico, is often cited as the brightest bioluminescent bay in the world. On moonless nights, the bioluminescence is so intense that you can read by it. Every movement creates explosions of light. Kayaking through the bay feels like paddling through liquid stars. Another bioluminescent bay, Laguna Grande, is located on the northeastern coast of the main island of Puerto Rico, near the town of Fajardo. It is more accessible than Mosquito Bay and offers a slightly different experience. Laguna Grande is surrounded by a thick mangrove forest. To reach the open water of the lagoon, you must paddle through narrow channels enclosed by mangrove roots that arch overhead, creating tunnels of vegetation. The journey through the mangrove channels is dark and quiet, the only sounds being the dip of paddles in water and the rustle of leaves. Then you emerge into the open lagoon, and if the night is dark and the conditions are right, the water around you begins to glow with every stroke of the paddle. Laguna Grande's bioluminescence is affected by several factors. Rain can temporarily dilute the dinoflagellate concentration. Moonlight can make the bioluminescence harder to see, as the eye adjusts to the brighter ambient light and the subtle glow of the organisms becomes less apparent. Pollution, particularly from runoff containing fertilizers or other chemicals, can harm the dinoflagellates and reduce the brightness of the bay. Conservation efforts are ongoing to protect these bays. Tourist activity must be managed to prevent damage to the mangroves and pollution of the water. The bays are fragile ecosystems, and the extraordinary displays of bioluminescence depend on maintaining the delicate balance of conditions that allow the dinoflagellates to flourish. As you float in the dark water, surrounded by living light, there is a sense of being witness to something ancient and fundamental. Bioluminescence evolved hundreds of millions of years ago in the oceans. It represents one of life's earliest solutions to the problem of communication and defense in the dark. The light you see is not fire, not electricity, not any human invention. It is life itself, shining. This brings us to the end of our first segment, our exploration of sky, light, and atmospheric mysteries. We have traveled from the ice of Antarctica to the warm waters of the Caribbean, from the ephemeral green flash of sunset to the continuous lightning of Venezuela, from clouds that defy explanation to insects and microorganisms that turn night into day. Each phenomenon, different as they are, shares a common thread. They are transformations of energy, visible manifestations of invisible forces, reminders that the world is filled with light in unexpected places, in unexpected forms. Let these images settle in your mind. Let them blur and soften. The details are not important. What matters is the sense of wonder, the quiet knowledge that above and around us, the world is continuously performing small miracles of light and atmosphere, asking nothing in return, simply existing in its luminous particularity. Rest now. The next wonders await, but they will wait patiently. Sleep if you need to. The journey continues whether your eyes are open or closed. We descend now from the realm of light and air to the fires that burn beneath our feet. The earth we walk upon is not a solid, stable sphere, but a dynamic, layered structure with a molten heart. The crust on which we live, thin as the skin of an apple in proportion to the whole, floats upon a mantle of rock heated to such temperatures that it flows like thick honey over geological timescales. Deeper still lies the outer core, liquid iron churning, and generating the magnetic field that shields us from solar radiation. And at the very center, the inner core, solid iron under such immense pressure that it cannot melt despite temperatures that rival the surface of the sun. This internal heat, this geological fire, finds its way to the surface in various forms. Sometimes it erupts violently as volcanoes. Sometimes it seeps out gradually as hot springs and geysers. Sometimes it burns for decades in craters of our own accidental making. These are the fire wonders, the places where the division between the cool surface world we inhabit and the infernal depths below becomes thin, where we can stand and feel the heat of planetary forces, where we are reminded that we live on the surface of what is essentially a molten ball that has only partially cooled over 4.5 billion years. We begin in the Karakum Desert of Turkmenistan, in Central Asia, at a place that has come to be known by various names, but most commonly as the Door to Hell or the Gates of Hell. The formal name is the Darvoza gas crater, named for the nearby village of Darvoza, though that village no longer exists, the residents having been relocated decades ago. The crater is approximately 230 feet in diameter and roughly 65 feet deep. It is a collapsed natural gas drilling site that has been burning continuously since 1971, though some accounts place the collapse in 1960 or earlier. The exact details have been obscured by time and the secretive nature of the Soviet government under which the incident occurred. The story, as it is commonly told, goes like this. Soviet geologists were drilling in the Karakum Desert, searching for oil fields. They were operating in an area known to contain substantial natural gas reserves. The drilling equipment broke through into an underground cavern filled with natural gas. The ground beneath the drilling rig collapsed, creating a crater. The rig and equipment fell into the newly formed pit. No one was killed in the collapse, but the crater began releasing natural gas into the atmosphere. Natural gas is primarily methane, and methane is both a potent greenhouse gas and potentially dangerous to nearby populations. The geologists made a decision. They would set the gas on fire, believing that it would burn off in a few weeks, and then the site could be safely abandoned. They ignited the crater. The gas did not burn off in a few weeks. It has been burning now for more than 50 years. The underground gas reservoir feeding the crater is far larger than anyone initially estimated, or perhaps multiple reservoirs are connected through cracks and fissures in the rock, continuously supplying fuel to the fire. The crater burns day and night. During the day, the flames are less visible, though the heat shimmer above the crater is obvious from a distance. At night, the crater becomes a spectacular sight. Flames leap from dozens or hundreds of points across the crater floor and walls. The fire is not uniform. Some areas burn with tall, steady flames. Other areas produce smaller, flickering fires. The flames are orange and yellow, sometimes tinged with blue at their base, where the combustion is hottest and most complete. The heat is intense. You cannot approach the edge of the crater without feeling the waves of thermal radiation. The ground near the rim is hot to the touch. The air above the crater ripples and distorts from the rising heat. At night, the crater illuminates the surrounding desert with an orange glow that can be seen from miles away. The sound is a constant low roar, the sound of burning gas at industrial scale, punctuated by occasional louder whooshes as pockets of gas ignite, or as the wind shifts and feeds more oxygen to particular areas of the fire. There is something primordial about the sound, something that reaches back to humanity's earliest relationship with fire. The crater has become a tourist attraction despite its remote location. Visitors camp near the rim and spend the night watching the flames. The contrast between the cool desert night, the brilliant stars overhead undimmed by light pollution, and the burning pit is stark and surreal. It feels apocalyptic, like a wound in the earth that will never heal. There have been discussions about extinguishing the fire, about capping the crater, about exploiting the gas commercially. In 2022, the president of Turkmenistan ordered studies on how to put out the fire, citing environmental and economic concerns. But as of now, the door to hell continues to burn, a monument to human miscalculation and the vast reservoirs of fossil fuels trapped in the Earth's crust. From a fire that burns by human accident, we turn to a volcano that appeared by natural processes, but in a time and place where its entire life cycle could be documented by human observers. This is Paracutin, a volcano in the state of Michoacán in Mexico, a mountain that did not exist before 1943 and whose formation and growth were witnessed from beginning to end. On February 20th, 1943, a farmer named Dionisio Pulido was working his cornfield near the village of Paracutin. It was late afternoon. He noticed that a section of ground had been forming a small depression and had been releasing sulfurous smoke for several weeks. As he worked, the ground began to swell. It rose up, forming a mound. Cracks appeared. Smoke and ash began pouring out. The farmer and his family fled. By the next morning, the new volcano had grown to a cone 50 feet high. Explosions threw incandescent rock fragments, called tephra, into the air. These fragments fell around the vent, building the cone higher with each eruption. The growth was astonishingly rapid. Within a week, the cone was over 300 feet tall. Within a year, it had reached over 1,000 feet in height. Lava began flowing from vents at the base of the cone. The lava was basaltic andesite, relatively fluid compared to some types of lava, but still viscous enough to move slowly, advancing at speeds measured in feet per hour or per day. The lava flows buried the villages of Paracutin and San Juan Parangaricutiro. The church tower of San Juan Parangaricutiro still protrudes from the hardened lava field, a lone structure emerging from the black rock, a monument to the power of the eruption. The eruption continued for 9 years, finally ceasing in 1952. By then, the volcano had grown to a height of approximately 1,390 feet above the pre-eruption ground level. Over 2 billion tons of lava and ash had been ejected. The surrounding landscape was transformed. Forests were buried. Fields disappeared under rock. New topography was created where once there had been farmland. Paracutin is classified as a cinder cone volcano, a type of volcano built from the accumulation of volcanic debris ejected during eruptions. Cinder cones are typically small compared to stratovolcanoes or shield volcanoes, and they usually erupt only once. Paracutin followed this pattern. After its 9-year eruption, it fell silent and has shown no signs of renewed activity. The volcano provided scientists with an unprecedented opportunity to study the birth and growth of a volcano from the very beginning. Geologists from Mexico and around the world came to observe and document the eruption. They measured growth rates, studied the composition of the lava and ash, monitored seismic activity, and developed models of cinder cone formation. The local indigenous population, primarily Purapeca people, had their own interpretations of the volcano's appearance. Some saw it as a punishment, others as a natural event in a landscape where volcanic activity was not unknown. The region is part of the Trans-Mexican Volcanic Belt, a zone of active and dormant volcanoes stretching across central Mexico. Paricutin was a dramatic addition to this volcanic landscape, but not an anomaly. Today, Paricutin is a dark cone of cinders and ash, vegetated in places where soil has accumulated and plants have taken hold. The lava fields surrounding it are rough and black, with only sparse vegetation. Visitors can hike to the summit. The crater at the top is a simple depression, quiet now, no smoke, no glow, just a bowl-shaped reminder of the forces that built this mountain in less than a decade. We travel now to Tanzania, to the Great Rift Valley, to a mountain sacred to the Maasai people, a volcano unlike almost any other on Earth. This is Ol Doinyo Lengai, which means Mountain of God in the Ma language. It is the only volcano currently erupting nitrocarbonatite lava, a type of lava so unusual that when it was first reported, some scientists refused to believe it existed. Most lava is composed primarily of silicate minerals, rich in silicon and oxygen, with varying amounts of iron, magnesium, calcium, and other elements. This is the lava we are familiar with, the glowing orange-red molten rock that flows from volcanoes like Kilauea or Mount Etna. Nitrocarbonatite lava is completely different. It is composed primarily of sodium carbonate and calcium carbonate, the same types of compounds found in baking soda and chalk. This unusual composition gives nitrocarbonatite lava properties that seem almost alien. When it erupts, it is not orange or red but black or dark brown, more like oil or molasses than typical lava. Its temperature is much lower than silicate lava, around 900 to 1000 degrees Fahrenheit, compared to typical lava temperatures of 2000 degrees Fahrenheit or higher. You could, in theory, stand much closer to flowing nitrocarbonatite lava than you could to basaltic lava, though it would still be dangerously hot. When nitrocarbonatite lava cools and solidifies, it is initially black or dark brown, but it reacts rapidly with moisture in the air. The sodium carbonate in the lava is hygroscopic, meaning it absorbs water. As it does, it begins to break down and turn white, eventually becoming a chalky, crumbly substance. Within days or weeks, fresh black lava flows turn light gray or white, giving the volcano's slopes a distinctive appearance, streaked with white fingers of old lava descending from the summit. Ol Doinyo Lengai is a stratovolcano, a steep-sided cone built from alternating layers of lava and ash. It rises to approximately 9,600 feet above sea level, standing prominently in the Great Rift Valley. The volcano has a summit crater that changes configuration with each eruption. Sometimes the crater contains a cone within it, built from recent lava flows. Other times the crater is a simple pit. The volcano erupts frequently, but usually not violently. The nitrocarbonatite lava has low viscosity, meaning it flows easily. Eruptions often consist of lava fountaining or flowing out from vents in the crater. Occasionally, the volcano produces more explosive eruptions, throwing ash and larger fragments, but these are less common. Climbing Ol Doinyo Lengai is a pilgrimage for volcanologists and adventurous tourists. The climb typically begins at night, so that climbers reach the summit around dawn, avoiding the heat of the day. The ascent is steep and the footing is treacherous. The white carbonatite rock is crumbly and unstable. Reaching the crater rim, climbers look down into an active volcanic vent, often glowing with fresh lava. The Maasai consider the mountain sacred. It is associated with their deity Ngai and is central to their spiritual beliefs. The volcano's eruptions are seen as expressions of divine power. The landscape around Ol Doinyo Lengai is part of the Maasai homeland, a region of dry savanna where they herd cattle and maintain their traditional way of life despite increasing pressures from modernization and land use changes. From the singular eruptions of Ol Doinyo Lengai, we travel a few hundred miles northeast to another volcanic feature in the East African Rift, a place so extreme in its chemistry and appearance that it resembles landscapes imagined for alien worlds. This is Dalal, a volcanic explosion crater in the Danakil Depression of Ethiopia. Dalal sits at approximately 400 feet below sea level, in one of the lowest and hottest places on Earth. The Danakil Depression is a geological wonder in itself, a region where the African continent is splitting apart along the East African Rift. Here, the Earth's crust is being pulled in opposite directions, thinning and cracking, allowing magma to approach close to the surface. The result is a landscape of active volcanoes, boiling springs, vast salt flats, and extreme geothermal activity. Dalal itself was formed by a phreatic eruption in 1926, an explosion caused when groundwater came into contact with hot magma, flashing to steam and blasting out a crater. The crater is about 1,000 feet across, but what makes Dalal remarkable is not its size, but the extraordinary geothermal features surrounding it. The area around Dalal is a fairyland of color and chemical excess. Hot springs bubble up from below, carrying dissolved minerals. As the water reaches the surface and evaporates in the extreme heat, the minerals precipitate out, building elaborate formations. There are terraces of yellow, orange, and red, composed of sulfur and iron compounds. There are pools of brilliant green and turquoise, colored by various salts and acids. There are white crusts of salt crystals. There are structures that look like miniature geysers, cones of mineral deposits with water or steam venting from their tops. The water emerging from these springs is not neutral. It is highly acidic and highly saline, saturated with various minerals. The pH can be less than 1 in some pools, more acidic than battery acid. The water temperature can exceed 200 degrees Fahrenheit. These are among the most extreme aquatic environments on Earth, hostile to almost all life. And yet, life exists even here. Extremophile microorganisms, bacteria and archaea adapted to high temperatures, high acidity, and high salinity, inhabit some of these pools. They represent some of the hardiest forms of life on the planet, metabolizing sulfur and other chemicals for energy. Studying these organisms helps scientists understand the limits of life and informs the search for life on other planets, where conditions might be similarly extreme. The landscape at Dalal shifts and changes constantly. The mineral formations grow and collapse. Pools appear and disappear. The colors vary with the concentration of different minerals and with the angle of the sunlight. In the morning or late afternoon, when the sun is low, the colors are most vivid. The yellows glow, the greens shimmer, the reds deepen. Walking through Dalal is walking on terrain that feels fundamentally unsafe. The ground is often a thin crust of minerals overlying hot water or mud. There are areas where the crust is fragile, where breaking through could plunge you into boiling, acidic water. Guides who bring tourists to the area are cautious, sticking to established paths, aware of the dangers. The heat is oppressive. Dalal is one of the hottest inhabited places on Earth. The average annual temperature exceeds 95 degrees Fahrenheit. Summer temperatures regularly exceed 120 degrees. There is little shade and little relief. The sun beats down on the pale salt flats, reflecting and magnifying the heat. The Danakil Depression itself, of which Dalal is a part, extends beyond this single volcanic feature. It encompasses a vast area of salt flats, lava fields, and geothermal features. Salt has been mined in the Danakil for centuries. Afar people and Tigrayans bring camel caravans down into the depression to cut blocks of salt from the flats and transport them to markets in the highlands. It is brutal work in a brutal environment, but the salt is valuable, and the tradition continues. The Danakil Depression is also home to Erta Ale, a shield volcano with a persistent lava lake, one of only a handful in the world. The lava lake glows day and night, a pool of molten rock exposed to the air, constantly churning and releasing gases. Standing at the edge of Erta Ale's crater at night, watching the lava lake, feeling the heat on your face, is to witness one of the planet's most primal sights, a direct view into the Earth's molten interior. We remain in this region for a moment longer, focusing specifically on the Danakil Depression as a whole, to understand this landscape not as isolated features, but as an interconnected system of geological extremes. The Danakil is a triple junction, a place where 3 tectonic plates meet. The African plate, the Arabian plate, and the Somali plate are all pulling apart from each other here. This creates intense geological activity, compressed into a relatively small area. The depression is part of the Afar Triangle, a region that geologists study to understand continental rifting and the formation of new ocean basins. Millions of years in the future, if the rifting continues, the Horn of Africa will separate completely from the continent, and the sea will flood into the Danakil Depression, creating a new ocean. We are witnessing, in geological slow motion, the birth of an ocean. The landscape of the Danakil is surreal. Salt flats stretch for miles, blinding white under the sun. These flats are not smooth, but broken into polygonal patterns by the expansion and contraction of the salt crust with temperature changes. In some areas, the salt has been heaved up into ridges and pillars by the pressure of salt layers below. Scattered across the depression are cinder cones, black volcanic mounds that stand in stark contrast to the white salt. There are lava fields, rough and sharp, where recent flows have solidified. There are sulfur springs where yellow crystals accumulate around vents releasing hydrogen sulfide gas, the smell of rotten eggs pervading the area. The few people who live permanently in the Danakil are Afar nomads, herding camels and goats in one of the harshest environments humans inhabit. They have adapted to the extreme heat, the lack of fresh water, the isolation. Their knowledge of the landscape, of where to find water, of how to navigate the salt flats and lava fields, is encyclopedic and essential for survival. From the East African Rift, we travel north and west to the North Atlantic, to Iceland, the island nation that sits astride the Mid-Atlantic Ridge, where the North American and Eurasian tectonic plates are pulling apart. Iceland is one of the most geologically active places on Earth, home to numerous volcanoes, geysers, and geothermal features. It is a young island, geologically speaking, less than 20 million years old, still being built by volcanic eruptions. In the summer of 2023, a new eruption began on the Reykjanes Peninsula in southwestern Iceland. The eruption, named Litli Hruta, meaning little ram, opened a fissure, a crack in the Earth's surface, from which lava fountained and flowed. Fissure eruptions are common in Iceland, where the divergent plate boundary creates cracks through which magma can easily reach the surface. The Litli Hruta eruption was relatively small by Icelandic standards, but it provided a spectacular display. The fissure was approximately 600 feet long. Along its length, curtains of lava fountained into the air, sometimes reaching heights of over 100 feet. The lava was basaltic, fluid and fast-moving, glowing orange and yellow. It flowed down the surrounding valleys, creating rivers of molten rock that advanced at speeds of several miles per hour in the initial phases. Icelanders are accustomed to volcanic eruptions. The country has experienced numerous eruptions in recent years. The attitude toward volcanism is pragmatic. Eruptions are monitored carefully, hazards are assessed, and if necessary, evacuations are ordered. But when eruptions occur in uninhabited areas and pose no immediate threat, they become tourist attractions. Thousands of people hiked to view the Litli Hruta eruption, drawn by the opportunity to see active lava flows. Approaching an active fissure eruption is an unforgettable experience. You walk across relatively recent lava fields, black and rough under your feet, still radiating heat in places. As you get closer, you feel the warmth in the air increasing. The sound grows louder, a roar and a hiss as lava erupts and flows. Then you crest a ridge and see it, the fissure line glowing in the landscape, fountains of lava leaping up, the flows spreading out below, bright orange against the black rock. The heat is intense even at a distance. The air shimmers. You can feel the infrared radiation on your face and hands. If the wind shifts and blows toward you, the heat becomes almost unbearable. You must retreat or shield yourself. The smell is distinct, a sharp mineral smell, with sulfurous notes from the volcanic gases being released. At night, the eruption is even more spectacular. The lava glows vividly in the darkness. The fountains are bright enough to illuminate the surrounding landscape. Photographers capture long-exposure images, showing the lava flows as rivers of light cutting through the darkness. The experience is otherworldly, a reminder that the Earth is not static but dynamic, constantly reshaping itself. The Litli Hruta eruption lasted only a few weeks before it ceased. The lava cooled and solidified, adding a new layer of rock to Iceland's surface. The fissure fell silent, but it is only a matter of time before another eruption occurs somewhere on the island. Iceland is growing, expanding at the edges as the tectonic plates pull apart and magma fills the gap. From natural geothermal features in Iceland, we travel to the United States, to the Black Rock Desert of Nevada, to a geothermal anomaly that is entirely human-made but has taken on a life of its own. This is Fly Geyser, also known as Fly Ranch Geyser, a continuously erupting fountain of hot water that has built elaborate travertine formations over the decades. Fly Geyser began in 1916 when a well was drilled to provide water for a ranch. The well tapped into a geothermal aquifer, water heated by hot rock deep underground. The well was not properly capped, and hot water began leaking to the surface. Over time, minerals dissolved in the hot water, primarily calcium carbonate, precipitated out as the water cooled, building up deposits around the leaking well. In 1964, a second well was drilled nearby. This well also encountered geothermal water, and it too was not properly sealed. The new leak increased the flow of hot water, and the travertine formations began to grow more rapidly. Today, Fly Geyser consists of several mounds of travertine, some standing over 12 feet tall, with hot water constantly spraying from multiple vents on the mounds. The travertine formations are multicolored, striped with reds, greens, yellows, and oranges. These colors come from thermophilic algae, microorganisms that thrive in hot water. Different species of algae tolerate different temperature ranges, so the colors form bands corresponding to the temperature gradient from the hottest water near the vents to the cooler water farther away. Water sprays from the vents in steaming jets. The water temperature at the source is approximately 200 degrees Fahrenheit. As it sprays into the air and lands on the mounds, it cools, and more minerals precipitate, gradually building the formations higher and creating new intricate shapes. The travertine develops ridges, terraces, and spiky protrusions. In some places, the formations look like miniature castles or alien architecture. Pools of hot water have formed around the base of the mounds. These pools are vivid green or blue, colored by algae and by the minerals in the water. Steam rises constantly from the pools. The ground around the geyser is warm and soft, mineralized and saturated with water. Fly Geyser sits on private land, and for many years access was restricted. In 2016, the Burning Man project purchased the property with the intention of preserving it and eventually opening it to limited public access. Small guided tours are now available, but the site remains relatively difficult to visit, which has helped protect it from damage. The geyser is not a natural geothermal feature in the way that Old Faithful or other Yellowstone geysers are, but it has become a natural feature through processes that are entirely natural. The human role was limited to drilling wells and failing to seal them. Everything since then, the growth of the mounds, the colors, the shapes, has been nature's work. It is an accidental collaboration between human activity and geological process. From geothermal water features, we turn to lava flows, but not recent ones. We travel to New Mexico, to an area called the Valley of Fires, where a lava flow from approximately 1,500 years ago created a river of black rock 5 miles wide and 40 miles long, one of the youngest lava flows in the continental United States. The Valley of Fires lava flow originated from a volcanic vent on the flank of Little Black Peak, a cinder cone in what is now called the Carrizozo Molpaís. Molpaís is a Spanish term meaning bad land, used to describe rough, sharp lava fields that are difficult to cross. The eruption was relatively small, but the lava was very fluid, allowing it to travel a great distance before solidifying. The lava is basaltic, the most common type of lava on Earth. It flowed down a shallow valley, following the gradient of the land. As it flowed, it cooled from the outside in. The surface solidified first, forming a crust, while molten lava continued to flow beneath. This created various surface textures. Some areas are smooth, called pohoehoe, with a ropey or billowy appearance. Other areas are rough and jagged, called AA, pronounced RR, where the solidifying crust broke apart and formed clinkers and sharp fragments. The lava flow is not uniformly flat. It has ridges and pressure plateaus where lava piled up against obstructions, or where the flow slowed and thickened. It has depressions and channels where the surface collapsed into voids left when lava drained away. Walking across the lava field is challenging. The surface is uneven, with cracks and holes waiting to twist an ankle. Despite the harshness of the terrain, life has colonized the lava flow. Lichens grow on the rock surface, slowly breaking it down chemically. Grasses and shrubs take root in cracks where soil has accumulated. Birds nest in crevices. Lizards and insects scuttle across the black rock, which absorbs heat during the day and radiates it at night. The Valley of Fires recreation area provides access to the lava flow. A paved trail allows visitors to walk out onto the lava, experiencing the texture and the stark beauty of the landscape. Interpretive signs explain the volcanism, the geology, the ecology. Standing on the lava, looking out across the black expanse to the mountains beyond, you can imagine the eruption, the glowing rivers of molten rock spreading across the valley, the heat and the light in the night. From lava flows preserved on the surface, we turn now to lava flows preserved beneath the surface, to underground passages carved by molten rock. These are lava tubes, and they exist in many volcanic regions around the world. We will explore examples from both South Korea and Iceland. Jeju Island, off the southern coast of South Korea, is a volcanic island formed by eruptions over the past 2 million years. The island is built from basaltic lava flows stacked one atop another. Among the island's many geological features are extensive lava tube systems, some of the longest and most complex in the world. Lava tubes form during eruptions when the surface of a lava flow cools and solidifies while the interior remains molten. The solidified crust acts as insulation, keeping the lava beneath hot and fluid. The lava continues to flow through this crust, like water flowing through a pipe. When the eruption ends and the supply of lava stops, the molten interior drains away, leaving a hollow tube. Jeju Island's lava tubes are remarkable for their size and their preservation. Some tubes are large enough to walk through standing upright, with ceilings 20 or 30 feet high and passages hundreds of yards long. The walls and ceilings often retain flow features, ripples and lines showing the direction the lava moved. In some places, stalactites of solidified lava hang from the ceiling, formed when drips of lava cooled and hardened. The most famous lava tube on Jeju Island is Manjangal, part of a larger tube system that extends over 8 miles. About 1 mile of Manjangal is open to the public. Visitors descend into the tube through a collapsed section of the ceiling. Inside, the temperature is cool and constant year-round, insulated from the outside air. The tube floor is relatively smooth where the last lava flows spread out and solidified. Water drips from the ceiling in places, forming small pools. Near the end of the accessible section of Manjangal is a large lava column, called a lava pillar, about 25 feet tall. It formed when lava dripped from the ceiling and accumulated on the floor, building up over time. The column is reddish-brown, colored by oxidized iron in the basalt. It stands as a monument to the dynamic processes that created this underground space. Lava tubes are ecologically significant. They provide stable environments with constant temperature and humidity. Bats roost in some tubes. Insects and other invertebrates inhabit them. In some cases, unique species have evolved in lava tubes, adapted to the dark, isolated conditions. Iceland also has extensive lava tube systems, formed by the same processes as Jeju's, but in a different geological setting. Iceland's tubes are associated with the island's numerous fissure eruptions and volcanic systems. Some of Iceland's lava tubes are accessible and have been developed as tourist attractions. Others are known only to cavers and scientists. Rofaholshella is one of Iceland's longest and most accessible lava tubes, formed by a lava flow from an eruption about 5,000 years ago. The tube is over 4,000 feet long and up to 30 feet wide in places. The entrance is a large collapsed section of the ceiling, a skylight that allows access to the tube. Inside, the passage extends in both directions, dark and cool. The walls of Rofaholshella show layers of different lava flows, evidence that the tube was active over an extended period, with multiple surges of lava passing through. The floor is uneven, with boulders and debris from ceiling collapses. In winter, ice formations develop inside the tube, fed by water seeping through cracks. Icicles hang from the ceiling, and ice stalagmites grow from the floor, creating a frozen underworld. Another notable Icelandic lava tube is Vgelma, which is even larger, with sections up to 50 feet wide and 50 feet tall. Vgelma is one of the largest lava tubes in Iceland and contains spectacular ice formations in its deeper sections. The tube is part of a larger system connected to Surta's Cave, another extensive tube. Exploring these tubes requires proper equipment and caution. The floors are rough, the ceilings can be unstable, and the darkness is absolute without artificial light. Lava tubes serve as reminders that volcanic activity is not just about surface expressions, the dramatic eruptions and flows we can see. Much of the action happens underground, in the plumbing systems of volcanoes, in the chambers and conduits where magma moves and accumulates. Lava tubes are fossils of these hidden processes, passages we can walk through, touching the walls where molten rock once flowed. As we conclude this segment on fire beneath the Earth, we have journeyed from accidental fires in desert craters to the birth of new mountains, from volcanoes with alien chemistry to geothermal features built by mineral-rich water, from fresh lava flows to ancient ones, from the surface of the land down into tubes carved by molten rock. Each feature tells a story of heat and pressure, of the restless energy contained within our planet, of the thin boundary between the cool world we inhabit and the inferno below. Let these images of fire and lava settle into the back of your mind. The heat dissipates. The glow fades. What remains is the knowledge that beneath the apparent solidity of the ground, there is movement, there is heat, there is continuous transformation. But for now, all is quiet. All is still. Rest comes easy when you remember that the earth itself is ancient and patient, that the fires have burned for billions of years and will burn for billions more, and that in this moment, in this breath, there is nothing required of you but to let go. The next wonders await, patient as stone, and speaking of stone, that is where we will turn next. But there is no hurry. Sleep if you need to. The journey continues in its own time. Stone is the archive of deep time. While human memory extends back only a few thousand years through written records, and biological memory, through fossils, extends back hundreds of millions of years, stone remembers even further. The oldest rocks on Earth are over 4 billion years old, formed when our planet was still young and violent, when the surface was repeatedly melted by asteroid impacts, when the atmosphere was poison, and the oceans were just beginning to condense from steam. Stone does not remember the way living things remember. It has no consciousness, no awareness, but it records. It preserves evidence of the conditions under which it formed. Pressure and temperature leave signatures in mineral composition and crystal structure. Time leaves its mark through erosion, through the slow work of water and wind and ice, through the chemical reactions that weather and transform rock over millions of years. We live our lives on the surface of these ancient stones, rarely thinking about what lies beneath our feet, rarely considering that the ground we walk on may be older than multicellular life, older than the continents in their current configuration, older than the mountains we see on the horizon. Stone is patient. Stone endures. Stone outlasts empires and species and entire ecosystems. And occasionally, stone arranges itself or is arranged by natural forces into forms so striking, so geometrically precise, or so seemingly impossible, that we stop and stare and wonder how such things came to be. We begin our journey through stone at the edge of the North Atlantic, on the coast of Northern Ireland, at a place where the meeting of land and sea is not the usual chaos of eroded cliffs and tumbled boulders, but an orderly assembly of geometric columns that look as though they were designed and placed by intelligent hands. This is the Giant's Causeway, a field of approximately 40,000 interlocking basalt columns that form stepping stones stretching from the cliff foot into the sea. The columns are predominantly hexagonal, though some are pentagonal or heptagonal. They fit together with almost no gaps between them, creating a pavement of polygonal shapes. The columns are of varying heights, some only a foot or two tall, others reaching 40 feet or more. They are arranged in 3 distinct groups, the result of 3 separate lava flows, each cooling at a different rate and under different conditions. The Giant's Causeway formed approximately 60 million years ago, during a period of intense volcanic activity associated with the opening of the North Atlantic Ocean. As the continents of North America and Eurasia pulled apart, magma welled up from below, erupting onto the surface. Basaltic lava flows spread across the landscape, covering hundreds of square miles. When lava cools, it contracts. If the cooling happens uniformly, and if the lava is thick enough, the contraction creates tension in the rock. This tension is relieved by the formation of cracks. The cracks propagate perpendicular to the cooling surface, which in the case of a horizontal lava flow is perpendicular to the top and bottom surfaces, creating vertical cracks. The pattern that minimizes the total length of cracks while dividing the surface into roughly equal areas is a hexagonal grid, the same pattern seen in honeycombs. This is why the columns are hexagonal. It is the most efficient way for the cooling lava to fracture. The columns extend deep into the rock, not just visible at the surface. If you were to cut through the causeway vertically, you would see the columns continuing down, sometimes for 100 feet or more. As the lava flow cooled from the top and bottom simultaneously, the columns grew inward from both surfaces, meeting somewhere in the middle. The Giant's Causeway has been known and visited for centuries. Local legend attributes the causeway to the Irish giant Finn McCool, who supposedly built it as a pathway to Scotland so he could fight a Scottish giant. The myth reflects the observable fact that similar columnar basalt formations exist on the Scottish island of Staffa, suggesting a connection between the two locations. The connection is real, not because of giants, but because both sites are part of the same ancient volcanic province, formed by the same geological processes. Walking on the Giant's Causeway is a strange experience. The column tops create an uneven surface, each one a separate stepping stone. Some columns are worn smooth by the sea and by countless footsteps. Others are rough and textured. The geometric precision is striking. It seems too orderly to be natural, and yet it is entirely natural, the inevitable result of physics and cooling basalt. The sea crashes against the causeway constantly, eroding the columns, toppling some, exposing fresh surfaces. The rock is dark grey when dry, almost black when wet. Lichen and algae grow in patches, adding spots of orange and green. Seabirds nest on the cliffs above, their calls echoing off the rock walls. From the coast of Northern Ireland, we cross the sea to Scotland, to the Isle of Staffa in the Inner Hebrides, to a sea cave that shares a geological heritage with the Giant's Causeway. This is Fingal's Cave, a cavern carved by waves into the same columnar basalt, creating a natural cathedral of stone pillars. Fingal's Cave is approximately 270 feet deep and about 40 feet high at the entrance. The cave's walls are formed by basalt columns similar to those at the Giant's Causeway, vertical hexagonal pillars that extend from the cave floor to the roof. The columns are remarkably uniform, creating the appearance of a man-made structure, of architecture rather than geology. The cave was formed by wave erosion. The Atlantic Ocean is relentless, and waves have been pounding this coastline for millions of years. The basalt, while hard, is fractured along the column boundaries. These fractures are weak points. Water forced into the cracks by wave action gradually widened them. Over time, the sea excavated the cave, removing broken rock and carrying it away. The cave is partially flooded at its base, with seawater washing in and out with each wave. There is a narrow walkway along one side, formed by a natural ledge of basalt, where it is possible to walk partway into the cave when the sea is calm. The sound inside the cave is extraordinary. Each wave creates a deep, resonant boom as water is compressed against the back wall and into crevices in the rock. The echoes build and layer, creating tones that change with the size and frequency of the waves. The cave has inspired artists and musicians for centuries. Felix Mendelssohn visited in 1829 and was so moved by the experience that he composed the Hebrides Overture, also known as Fingal's Cave, attempting to capture in music the sound and feeling of the place. The overture conveys the rolling motion of waves, the echoing resonance of the cave, the sense of vast geological time made audible. The name Fingal comes from the same legendary figure as Finn McCool, the Irish giant. In Scottish Gaelic tradition, he is Finn Mac Cumhale, and Fingal is an anglicised version of his name. The cave was named by the naturalist Joseph Banks, who visited in 1772 and popularised the site, bringing it to the attention of the wider world. Staffa itself is a small island, uninhabited, composed entirely of the same Paleogene basalt. The island's cliffs are formed of columnar basalt, creating a dramatic and geometric coastline. Access to Fingal's Cave requires a boat journey, and the landing is only possible in calm weather. The cave remains a pilgrimage site for those drawn to geology, to natural beauty, to places where the power of nature is made tangible in stone and sound. We travel now to the other side of the world, to the coast of New Zealand's South Island, to a beach where large, nearly spherical boulders lie scattered along the shore and half buried in the sand. These are the Moaroki boulders, septarian concretions that have eroded out of the surrounding mudstone cliffs and rolled or been carried down to the beach. The boulders are striking in their roundness. Some are perfectly spherical, up to 7 feet in diameter and weighing several tons. They sit on the beach like giant marbles, smooth and grey, many of them cracked open to reveal intricate patterns inside. The cracks divide the boulders into polygonal segments, and the spaces between segments are often filled with calcite crystals that have precipitated from groundwater. The Moeroki boulders formed approximately 60 million years ago, around the same time as the Giant's Causeway, though through entirely different processes. They are concretions, formed when minerals precipitated from water and cemented sediment particles together into a hard mass. The process began on the ancient sea floor, within soft mud that would eventually become the mudstone cliffs we see today. A concretion forms around a nucleus, some small object or piece of organic matter. Minerals in the surrounding sediment, carried by pore water, are attracted to this nucleus and precipitate out, gradually building a solid mass. The Moeroki boulders grew slowly, over millions of years, layer by layer, cementing mud particles together. The spherical shape results from the concretion growing equally in all directions from the central nucleus. Some of the boulders contain fossilized bones and shells at their centers, remnants of ancient marine life that served as the initial nuclei. As the concretions grew, they incorporated these fossils, preserving them in the center of the stone sphere. The internal cracks, called septaria, formed later. As the concretions were buried under more sediment, they were compressed. As groundwater chemistry changed, the concretions sometimes dried out and contracted, creating internal cracks that radiated from the center. Later, when water flowed through these cracks, it deposited calcite, filling the cracks with crystalline material. When a boulder breaks open, these calcite-filled cracks are visible as light-colored veins radiating through the darker mudstone matrix. The boulders eroded out of the surrounding cliffs relatively recently, geologically speaking. The mudstone is soft and erodes easily, while the concretions are much harder. As the cliff face erodes, the boulders are exposed and eventually fall to the beach. Wave action then breaks them free from any remaining mudstone, and sometimes cracks them open, revealing their interiors. The Moeroki boulders have been known to the Maori people for centuries. They appear in local legends as eel baskets and calabashes washed ashore from the wreck of a legendary canoe. The boulders were part of the landscape, objects of wonder and spiritual significance, incorporated into the mythology of the people who lived here. Today, the boulders are a tourist attraction. Visitors walk among them at low tide, touching the smooth surfaces, peering into the cracked open interiors, marveling at the geometry and the mystery of how such perfect spheres could form naturally. Some boulders remain half buried in the sand. Others sit fully exposed, and the contrast between their rounded forms and the rough, irregular rocks elsewhere on the beach makes them all the more striking. From natural spheres of stone in New Zealand, we turn to spheres that appear less natural but are in fact entirely geological. These are the stone spheres of Costa Rica, also known as the Dequis spheres, hundreds of carved spheres ranging from a few inches to over 6 feet in diameter, found in the Dequis Delta and on Isla del Cono in southern Costa Rica. The spheres are made from gabbro, a coarse-grained igneous rock similar to basalt, but with larger crystals. Gabbro is hard and difficult to work, which makes the precision of the spheres all the more impressive. Many of the spheres are nearly perfect in their roundness, deviating from a true sphere by only a few centimeters. Some weigh as much as 15 tons. The spheres were created by the indigenous people of the region, likely between 600 and 1500 CE, though exact dating is difficult. They were made by a combination of controlled fracturing, pecking with harder stones, and grinding and polishing. The process would have been laborious, taking months or even years for the largest spheres. The purpose of the spheres remains uncertain. They were found in various contexts, sometimes arranged in lines or geometric patterns, sometimes associated with important structures or burial sites. They may have served as markers of territory or status, as astronomical alignments, or as symbolic objects with religious or cosmological significance. The people who created them left no written records, and the oral traditions that might have explained the spheres were disrupted by Spanish colonization. What is clear is that the spheres required significant effort and skill to produce. The precision suggests careful planning and measurement, a deep understanding of geometry and symmetry. The choice of gabbro, a stone that could be shaped but that was hard enough to endure, speaks to practical considerations combined with aesthetic ones. Many of the spheres have been moved from their original locations, taken by collectors or relocated to museums and public spaces. This has made archaeological study more difficult, as the context in which the spheres were placed is often lost. Some remain in situ, and archaeological work continues to try to understand their original arrangement and purpose. The stone spheres of Costa Rica are a reminder that human cultures have long been fascinated by geometric forms, by the challenge of imposing order and symmetry on natural materials, by the creation of objects that seem to transcend the irregularity of the natural world. They stand as testaments to the skill and vision of their creators, puzzles in stone that continue to provoke questions. From human-made spheres, we turn to a circular feature so large and so precise that it was not fully recognized until the era of satellite imagery. This is the Richat structure, more commonly known as the Eye of the Sahara, a 40-kilometer-wide circular formation in the Sahara Desert in Mauritania. The Eye of the Sahara is a deeply eroded geological dome, a type of structure called a geologic dome or dissected dome. From the ground, the feature is difficult to perceive. You might notice that the terrain rises slightly, that certain rock layers form concentric ridges, but you would not grasp the full circular pattern. From space, however, the eye is unmistakable, a perfect bull's eye in the featureless expanse of the desert. The structure consists of multiple concentric rings of rock layers that have been tilted upward and then eroded. The center of the structure is lower than the surrounding rings, creating a bowl shape with raised rims. The rings are made of alternating hard and soft rock layers. The harder layers, more resistant to erosion, form ridges and escarpments. The softer layers have eroded away, creating valleys between the ridges. For many years, scientists debated the origin of the Richat structure. Its circular shape and size initially led some to propose that it was an impact crater formed by a meteorite strike. However, there is no evidence of the shock metamorphism or melted rock that would accompany a large impact. There is no raised rim of ejected material. The rocks within the structure are not deformed in ways consistent with impact. The current consensus is that the Richat structure is a deeply eroded dome formed by uplift from below. The uplift may have been caused by a rising plume of molten rock, magma that pushed upward but did not break through to the surface. The overlying rock layers were pushed up into a dome shape. Over millions of years, erosion removed the top of the dome and carved into the layers, creating the concentric ring pattern we see today. The rings vary in composition. Some are made of sedimentary rocks like sandstone and limestone, formed from ancient seabeds. Others are made of volcanic rocks, evidence of magmatic activity. The different rock types erode at different rates, which is why the ring pattern is so pronounced. The Eye of the Sahara is remote. It lies in the Adra Plateau region of Mauritania, far from major settlements. The area is arid, receiving very little rainfall. Vegetation is sparse. The rock is exposed, carved by wind and the occasional flash flood. Visiting the Eye requires crossing difficult desert terrain, navigating sand and rock, enduring extreme heat. For local nomadic groups, primarily Berber people who have traversed the Sahara for centuries, the Richat structure is simply part of the landscape, a known landmark useful for navigation. It has no particular mystical significance in local tradition, though its striking appearance has led modern visitors to sometimes attribute symbolic or esoteric meanings to it. The Eye of the Sahara is sometimes called the Eye of Africa, and from orbit, it does resemble an eye staring upward into space. It has become an iconic image in satellite photography, easily recognizable, a landmark for astronauts aboard the International Space Station. It is a reminder of the value of perspective, of how seeing the Earth from above reveals patterns and structures invisible from the ground. We travel now to Australia, to Western Australia, to a rock formation that seems to defy gravity and logic. This is Wave Rock, a natural rock formation shaped like a breaking ocean wave, frozen in stone, standing approximately 50 feet high and nearly 400 feet long. Wave Rock is actually the steep face of a much larger granite outcrop called Haydn Rock. The wave shape is formed by a concave cliff face that has been weathered and stained to create the appearance of a wave with a crest and a breaking curl. The rock face curves smoothly, overhanging slightly at the top, creating the impression of water frozen at the moment before it crashes down. The formation is made of granite, formed approximately 2.7 billion years ago during the Archean, making it some of the oldest rock on Earth. The granite formed deep underground as molten rock cooled slowly, allowing large crystals to grow. Over billions of years, the overlying rock eroded away, exposing the granite at the surface. Wave rock's distinctive shape is the result of chemical weathering, specifically a process called chemical weathering along a basal weathering front. Granite weathers when water containing dissolved carbon dioxide, a weak acid, seeps into cracks and reacts with minerals in the rock, particularly feldspar, converting them into clay. This weathering occurs most readily underground, where water can accumulate. At Wave Rock, weathering occurred along a zone where the granite was in contact with overlying rock. Water seeped down to this contact zone and weathered the granite from below, creating a concave hollow. As the overlying rock eroded away, the weathered hollow was exposed, creating the wave shape. The process continued, with water running down the rock face after rains, further eroding the surface and maintaining the smooth curve. The color banding on wave rock enhances the wave illusion. The bands are caused by water running down the rock face, carrying dissolved minerals, particularly iron compounds and carbonates. These minerals precipitate on the rock surface, forming layers of staining. The darker bands are richer in iron oxides. The lighter bands have more carbonate. The pattern resembles the color gradations in a breaking wave, with darker water at the base and lighter foam at the crest. Wave rock is located in a semi-arid region. The surrounding landscape is flat, covered with scrubby vegetation and dry soil. The rock formation rises suddenly from this flatness, a massive granite outcrop that dominates the horizon. The contrast between the smooth, curved rock face and the rough, angular landscape around it is stark. The local Baladong people, an Aboriginal group, have lived in this region for thousands of years. They have stories and knowledge associated with the rock, seeing it as part of the landscape's spiritual geography. The rock is part of their country, connected to songlines and dreaming stories. Wave Rock has become a significant tourist attraction. Visitors walk along the base of the rock, looking up at the overhanging curve. The scale is impressive. The rock face towers overhead, and the smoothness of the curve, the precision of the shape, seems almost artificial. People photograph themselves at the base, trying to capture the illusion of the wave about to break over them. From Australia, we travel to China, to Zhongye Donxia Landform Geological Park in Gansu Province, to a landscape of multicolored rock formations, layered and folded and eroded into fantastic shapes. Among these formations is a feature known as monkey skin rock, where the layers of colored sediment create patterns that resemble the texture and color of monkey skin. The Zhongye Donxia formations are part of a broader category of landscapes called Donxia landforms, characterized by red sandstone and conglomerate rock that has been eroded into dramatic cliffs, towers, and valleys. The name Donxia means rosy cloud, referring to the reddish color of the rock. The formations at Zhongye are particularly notable for their color diversity, displaying not just red but also yellow, orange, green, blue, and white in distinct layers. These colors come from different minerals in the sedimentary rock. The red and orange layers are colored by iron oxides, rust formed when iron in the sediment was exposed to oxygen. Yellow layers contain sulfur compounds. Green and blue layers have copper minerals. White layers are rich in calcium carbonate. The sediments were deposited over millions of years during the Cretaceous period, approximately 100 million years ago, when this region was a basin collecting sediment from surrounding highlands. As sediments accumulated, they formed horizontal layers. Later, tectonic forces associated with the collision of the Indian subcontinent with Asia uplifted and tilted these layers. The forces were immense, folding and compressing the rock, creating complex patterns. Erosion then carved into the tilted layers, revealing the colors and creating the shapes we see today. Monkey skin rock is a section where the layers are particularly thin and tightly packed, and where erosion has exposed them in a way that creates a textured, irregular surface. The colors alternate in narrow bands, and the erosion has created bumps and ridges that, combined with the color pattern, do resemble the skin of a monkey or perhaps the bark of a tree. The resemblance is subjective, but the name has stuck, and it captures the organic quality of the rock's appearance. Walking through the Zhongye Donxia formations is like walking through a landscape painting. The colors are so vivid and so varied that they seem artificial, as though someone has painted stripes across the hills. The formations change appearance with the light. In early morning or late afternoon, when the sun is low, the colors are most saturated. The reds glow, the yellows brighten, the shadows deepen. At midday, under harsh sun, the colors wash out somewhat, becoming paler. The park has become a major tourist destination in China, with wooden boardwalks and viewing platforms built to allow visitors to experience the landscape without causing erosion or damage. The crowds can be substantial, but the scale of the formations is large enough that there is still a sense of immersion in a surreal, alien landscape. From the painted hills of China, we travel to the American Southwest, to a remote area in northern Arizona known as White Pocket, a landscape of swirling, layered sandstone formations that look like frozen taffy or ripples in cream. White Pocket is part of the Vermilion Cliffs National Monument, a vast area of eroded Navajo sandstone. Navajo sandstone is approximately 190 million years old, formed during the Jurassic period from sand dunes in a vast desert that covered much of the western United States. The sand was deposited by wind, creating cross-bedding, the diagonal layers that are characteristic of dune deposits. Over time, the sand was buried, compressed, and cemented together by minerals precipitating from groundwater, turning it into solid rock. White Pocket's distinctive appearance is the result of differential erosion and chemical alteration. The sandstone contains iron compounds. In some areas, these compounds have oxidized, turning the rock shades of red, orange, and pink. In other areas, the iron has been reduced or removed, leaving the sandstone white or cream-colored. The patterns of color reflect the movement of groundwater through the rock over millions of years, following cracks and porous zones. Erosion by wind and occasional water has carved the sandstone into smooth, flowing shapes. The rock has been worn down along weaker layers and along fractures, creating ridges and valleys, humps and hollows. The surfaces are often smooth and rounded, polished by wind-blown sand acting as a natural sandblaster over millennia. The result is a landscape that looks almost liquid, as though the rock is melting or flowing. Swirls of white stone are bordered by bands of red. Smooth domes rise from the ground. Shallow pockets and basins collect water after the rare rains, creating temporary pools that reflect the sky and the surrounding rock. White Pocket is extremely remote. It is located in a roadless area, accessible only by high-clearance four-wheel drive vehicles, and only to those who know the route. There are no signs, no marked trails. Navigation requires GPS and careful attention. The nearest paved road is many miles away across rough dirt tracks that are easily impassable in bad weather. This remoteness has preserved White Pocket. It remains relatively unknown compared to nearby attractions like the Wave or Coyote Buttes. Those who make the effort to reach it are rewarded with a landscape of extraordinary beauty and strangeness, a place where the rock seems alive, where every surface is sculpted and textured, where the interplay of light and color creates endlessly varied compositions. From White Pocket, we travel south and east to Colorado, to another landscape of colored rock, but this time associated with volcanic activity. These are the painted dunes of Lassen Volcanic National Park, a field of volcanic ash and cinders that has weathered into a palette of red, orange, yellow, purple, and black. The painted dunes formed approximately 300 years ago during an eruption of Cinder Cone, a small volcano in the park. The eruption ejected ash and cinders, fragments of solidified lava and volcanic glass, which fell to the ground around the volcano. The material was hot when it landed, and it fell onto snow and ice that covered the ground. The heat partially melted the snow, and the water percolated through the hot ash, creating a superheated steam environment. In this environment, the iron compounds in the ash oxidized rapidly, creating the vivid red and orange colors. The process is similar to rusting, but accelerated by the heat and the presence of water and oxygen. Different minerals produced different colors. Hematite created reds. Limonite produced yellows and oranges. Manganese oxides contributed purples and blacks. The dunes are not dunes in the traditional sense of wind-blown sand. They are deposits of volcanic material, mounds and slopes of ash and cinders. But the term dunes has stuck, perhaps because of the soft, rounded forms of the deposits, the way they undulate across the landscape. The painted dunes are located at the base of Cinder Cone, which is itself a striking feature, a symmetrical cone of black cinders, rising approximately 750 feet from its base. Climbing Cinder Cone is a popular activity, though it is strenuous. The cinders shift underfoot, and for every 2 steps up, you slide 1 step back. But from the summit, the view is spectacular. You look down into the crater, a perfect bowl shape, and you see the painted dunes spread out below, a canvas of color against the dark volcanic rock. The colors of the painted dunes are most vivid when the ash is dry and when the light is low. Morning and evening light brings out the saturation of the colors. After rain, the ash darkens and the colors mute somewhat. Snow, which covers the dunes in winter, hides the colors entirely until spring melt. The area around Cinder Cone is part of a larger volcanic landscape. Lassen Peak, a large stratovolcano, dominates the region. It last erupted between 1914 and 1917, making it one of the most recent volcanic eruptions in the contiguous United States. The park contains numerous other volcanic features, including fumaroles, hot springs, and mud pots, evidence of the ongoing geothermal activity beneath the surface. From the volcanic colors of Colorado, we complete our journey through stone with a return to deep time, to a place where stone preserves not just geological history, but also the record of human presence thousands of years ago. This is Tassili Energia, a mountain range and plateau in southeastern Algeria, in the Central Sahara, known for its extraordinary collection of prehistoric rock art, and for its eroded sandstone formations that create landscapes of arches, pillars, and canyons. Tassili Energia is a vast area, covering approximately 28,000 square miles. The name means plateau of rivers in the Berber language, referring to the ancient river valleys that once cut through this landscape. Today, the area is arid, but the rock art depicts a very different environment, showing elephants, giraffes, hippos, cattle, and people engaged in hunting, herding, and daily life. This art dates from approximately 12,000 years ago to 2,000 years ago, spanning a period when the Sahara was much wetter, when rivers flowed and grasslands supported abundant wildlife. The rock art is found in caves and on rock overhangs throughout the plateau. It includes thousands of paintings and engravings. The older images are engravings, pecked into the rock surface. Later images are paintings, applied with mineral pigments. The subjects change over time, reflecting the changing environment. Early images show wild animals of the savanna. Later images show domesticated cattle, indicating the arrival of pastoralism. The most recent images show camels and horses, animals adapted to desert conditions, reflecting the desiccation of the Sahara. The sandstone formations of Tassili Energia are dramatic. Erosion has carved the rock into isolated towers, natural arches, and narrow canyons. The formations are made of Cambrian and Ordovician sandstone, approximately 500 million years old. The rock is layered, and erosion has removed softer layers, while leaving harder layers as capstones on pillars and towers. The erosion patterns create forests of stone, areas where hundreds of isolated pillars and towers stand clustered together. Wandering through these stone forests feels like walking through the ruins of an ancient city, columns and walls and arches stretching in all directions. The scale is immense. Some towers are hundreds of feet tall. The canyons between them can be narrow and deep, shaded and cool even in the heat of the day. The Tuareg people, Berber nomads who inhabit the Sahara, have long known Tassili Energia. The area is part of their traditional territory. The rock art sites are known to them, though the meanings of the images have been lost. The people who created this art lived thousands of years ago and left no written records. The Tuareg have their own oral traditions and knowledge of the landscape, but these do not extend back to the time when the Sahara was green. Tassili Energia is a UNESCO World Heritage Site, recognized both for its geological significance and for its cultural and archaeological importance. The area is remote and difficult to access. Travel requires guides, four-wheel drive vehicles, and supplies for extended desert travel. The climate is harsh, with extreme temperatures and scarce water. But for those who make the journey, Tassili Energia offers an experience of deep time, a place where the geological past and the human past are both preserved in stone, where the landscape itself is a gallery and an archive. As we close this segment on stone, time, and ancient Earth, we have traveled from the geometric precision of basalt columns to the mysterious spheres of concretion and human craft. From circular structures visible only from space to waves frozen in granite, from painted hills and dunes to plateaus carved by wind and decorated by ancient hands. Stone, in all its forms, is the substrate of our world, the foundation on which everything else rests. It is slow and patient and enduring. It speaks not in words but in form and color and texture, in the accumulated evidence of millions and billions of years. Let the weight of these stones settle in your imagination, not as burden but as stability, as the solid ground beneath all things. Let the timescales blur and dissolve. What are years, what are millennia, to stone? Let yourself rest on this foundation, knowing that the earth is old and strong, and that its story is written in layers we can read if we know how to look, or we can simply accept as mystery, as beauty, as the silent testimony of deep time. Rest now. The journey continues, but there is no urgency. The stones will wait. They have waited for eons. They will wait through this night, and through countless nights to come. Sleep if you wish. The wonders remain, patient and permanent, marking time in their slow, inexorable way. We turn now from stone to ice, from permanence to a different kind of endurance. Ice is transient on human timescales. It melts in spring, reforms in winter. But on geological timescales, ice is a sculptor as powerful as water or wind. Ice sheets have advanced and retreated across the continents dozens of times over the past few million years, carving valleys, grinding bedrock, leaving behind lakes and moraines and entire rearranged landscapes. Ice preserves. In the coldest places on Earth, in Antarctica and Greenland and the high Arctic, ice accumulates year after year, layer upon layer, trapping air bubbles and dust particles and chemical traces that become a record of past climates. Ice cores drilled from these sheets allow us to reconstruct atmospheric conditions going back hundreds of thousands of years, to measure ancient temperatures and carbon dioxide levels, to understand the rhythm of ice ages and warm periods. But ice also reveals. Where ice melts at the margins of glaciers, where it sublimates in the dry valleys of Antarctica, where it forms and fractures on frozen lakes, it creates phenomena of surprising beauty and strangeness. The cold places of the world are not lifeless or monotonous. They are dynamic, filled with processes that occur nowhere else, with colors and forms that emerge only in the presence of extreme cold. We begin in Antarctica, the coldest, driest, windiest continent on Earth, where ice covers 98% of the land surface to an average depth of more than a mile. In this landscape of white and blue, where color is scarce and life is scarcer, there is a glacier that bleeds. This is Blood Falls, a striking feature where red water flows from the snout of the Taylor Glacier into Lake Bonny in the McMurdo Dry Valleys. The first observers who saw Blood Falls assumed the color came from red algae. This seemed a logical explanation. Algae can survive in extreme environments, and red pigments could conceivably protect them from intense solar radiation. But the truth is stranger and more interesting than algae. The red water flowing from Blood Falls is rich in iron. Deep beneath the Taylor Glacier, approximately 1,300 feet below the ice surface, there is a body of liquid water that has been isolated from the atmosphere for approximately 2 million years. This subglacial lake is a relic of an ancient fjord, trapped when the glacier advanced and sealed it beneath the ice. The water in this lake is extraordinarily salty, several times saltier than seawater. Salt lowers the freezing point of water, which is why this water remains liquid even at temperatures well below 32 degrees Fahrenheit. The water is also rich in iron dissolved from the bedrock beneath the lake. And crucially, the water contains no oxygen. It has been cut off from the atmosphere for 2 million years, and any oxygen initially present has long since been consumed. Microorganisms live in this sealed lake. They are anaerobic bacteria, organisms that do not require oxygen to survive. They metabolize sulfate and ferric iron, extracting energy from chemical reactions rather than from sunlight or organic matter. These bacteria have survived in complete darkness, in extreme cold, in high salinity, isolated from the rest of the biosphere for millions of years. They represent a form of life utterly different from what we normally encounter, an ecosystem based on chemistry rather than photosynthesis. Occasionally, The pressure of the water beneath the glacier becomes sufficient to force a pathway through the ice. The water flows out, seeping through cracks and channels, emerging at the glacier's terminus. When the iron-rich water encounters air for the first time in millions of years, the dissolved ferrous iron oxidizes, rusting on contact with oxygen. The water turns red, the color of rust, of oxidized iron. Blood Falls is not bleeding. It is rusting. The red water flows down the white ice, staining it, creating a vivid streak of color that is visible from a distance. In winter, the flow freezes, creating a red icicle, a frozen cascade. In summer, when temperatures rise slightly, the flow resumes, and the red water spreads across the ice, pooling at the base of the glacier, eventually draining into Lake Bonny. Blood Falls is scientifically significant because it demonstrates that life can survive in conditions we would normally consider uninhabitable. If microorganisms can live beneath a glacier in Antarctica, cut off from sunlight and oxygen, then perhaps life could exist in similar environments elsewhere in the solar system. Jupiter's moon Europa, Saturn's moon Enceladus, both have subsurface oceans beneath thick ice shells. If Blood Falls is any indication, these oceans might not be sterile. We remain in the McMurdo Dry Valleys, the region where Blood Falls is located, to explore this extraordinary landscape more broadly. The McMurdo Dry Valleys are the largest ice-free area in Antarctica, approximately 1,800 square miles of valleys and mountains where the ice sheets have not covered the ground. They are among the driest places on Earth, receiving almost no precipitation, less than 2 inches of water equivalent per year. The valleys are dry because of the surrounding mountains, which block the flow of ice from the East Antarctic ice sheet, and because of katabatic winds, cold dense air that flows down from the high interior of Antarctica, warming slightly as it descends and compressing, becoming even drier. These winds can reach hurricane speeds, and they scour the valleys, preventing snow from accumulating and sublimating any ice that does form. The landscape of the dry valleys is stark and alien. The ground is bare rock and soil, gravel and sand, with no vegetation visible to the naked eye. The rocks are weathered and fractured, carved by wind and by the freeze-thaw cycles that occur despite the cold. The valleys are brown and grey and tan, earth tones against the white of distant glaciers and the blue of the sky. Yet despite the apparent barrenness, life exists. Lichens grow on rocks, tiny crusts and patches of symbiotic fungi and algae that can photosynthesize during brief periods when conditions allow. Nematodes, microscopic worms, live in the soil, freezing solid in winter and reviving in summer when temperatures rise slightly above freezing. These are among the simplest ecosystems on Earth, yet they persist. The valleys contain lakes, but these are not ordinary lakes. They are permanently ice-covered, with ice many feet thick. Beneath the ice, the water remains liquid, kept from freezing by the salinity and by geothermal heat seeping up from below. These lakes are chemically stratified, with layers of different salinity and different communities of microorganisms at different depths. Lake Vanda, one of the larger lakes in the dry valleys, has a remarkable feature. The bottom of the lake, approximately 250 feet below the ice surface, has a temperature of around 77 degrees Fahrenheit, warmer than many tropical oceans. This warmth comes from solar radiation penetrating the ice and being absorbed by the dark lake bottom, combined with the insulating effect of the ice cover preventing heat from escaping. The lake's high salinity prevents convective mixing, so the warm water stays at the bottom while the surface remains near freezing. The McMurdo Dry Valleys are used as an analogue for Mars. The cold, dry conditions, the bare rocky terrain, the permafrost beneath the surface, all resemble conditions on Mars. Scientists study the dry valleys to understand how life might survive in Martian conditions, how to search for biosignatures, how to interpret landscapes shaped by processes similar to those on Mars. Standing in the dry valleys, you are aware of the silence. There is no running water, no rustling vegetation, no animal sounds. The only sound is the wind, constant and sometimes fierce, whistling across the rocky ground. It is a silence born of cold and dryness, an absence that feels complete. From the frozen silence of Antarctica, we travel north to Siberia, to the world's deepest and oldest lake, Lake Baikal. Baikal is a rift lake, formed in a tectonic valley where the Earth's crust is pulling apart. It is over a mile deep, and contains approximately 20% of the world's unfrozen fresh water. It is home to species found nowhere else, including the Baikal seal, the world's only exclusively freshwater seal. In winter, Lake Baikal freezes. The ice can reach thicknesses of 3 to 4 feet, strong enough to support vehicles. The ice is remarkably clear, like glass, allowing you to see down into the water beneath. And suspended in this ice, visible from above, are bubbles. Thousands upon thousands of bubbles, trapped in the ice, stacked in vertical columns, creating patterns that look like jellyfish or underwater explosions frozen in time. These are methane bubbles. Methane is produced by microorganisms in the lake sediments, bacteria that decompose organic matter in the absence of oxygen. The methane gas rises from the sediments, bubbling up through the water column. In summer, these bubbles reach the surface, and the methane escapes into the atmosphere. In winter, when the lake begins to freeze, the bubbles become trapped in the ice as it forms. The ice freezes from the surface downward, layer by layer. As each layer freezes, any bubbles in that layer are locked in place. The result is that bubbles accumulate in vertical stacks, recording the path the methane took as it rose from the lake bottom. The bubbles vary in size, from tiny spheres a millimeter across to larger pockets several inches in diameter. The visual effect is extraordinary. Looking down through the clear ice, you see these white columns of bubbles extending down into the depths. The ice itself is a deep blue in thick sections, and the white bubbles stand out against this blue. The patterns are organic and chaotic, different in every location, a three-dimensional sculpture created by the interaction of gas, water, and cold. Walking on the ice of Lake Baikal in winter is an otherworldly experience. The surface is smooth in places, rough in others where the ice has cracked and refrozen. The cracks are lines of jagged ice, pressure ridges where the expanding ice has pushed upward. Sometimes the ice makes sounds, deep booms and cracks as it shifts and adjusts to temperature changes and to the pressures within it. The sounds echo across the frozen surface, loud and sudden, startling in the silence. The ice is so clear that it can be disorienting. You see the bubbles and the water beneath, and it feels as though you are walking on glass, as though the ice might not be solid. But it is solid, thick, and strong, and the sensation of transparency is simply unusual, not dangerous. The methane trapped in the ice is a small part of a much larger global phenomenon. Methane is stored in vast quantities in lake and ocean sediments, in permafrost, in deposits called methane hydrates where methane is trapped in crystalline structures of water ice. As the climate warms, there is concern that these methane deposits could release their gas, creating a feedback loop that accelerates warming. The bubbles in Lake Baikal are a visible reminder of this invisible gas, this potent greenhouse molecule that cycles between sediments, water, ice, and atmosphere. We travel west to the Canadian Rockies, to another lake where methane bubbles create frozen art. This is Abraham Lake, a reservoir created in 1972 by the Bighorn Dam on the North Saskatchewan River in Alberta, Canada. Abraham Lake is a younger sibling to Baikal, artificial rather than ancient, but it produces the same frozen methane bubble phenomenon, and because it is more accessible than Baikal, it has become a popular destination for photographers and winter tourists. The process is the same as at Baikal. Organic matter in the lake sediments is decomposed by bacteria, producing methane. The methane bubbles up through the water. In winter, the lake freezes, and the bubbles are trapped in the ice. The ice at Abraham Lake is also clear, and the bubbles create the same vertical stacks, the same jellyfish-like patterns. Abraham Lake is surrounded by mountains, part of the Canadian Rockies, and the setting is spectacular. The lake stretches for 20 miles, long and narrow, following the valley of the river. The mountains rise steeply on either side, snow-covered in winter, their peaks sharp against the sky. The frozen lake surface is windswept, often clear of snow, exposing the ice and the bubbles within. The bubbles vary in their distribution. Some areas of the lake have dense concentrations, where every square foot of ice seems to contain hundreds of bubbles. Other areas are relatively clear. The variation depends on where organic matter has accumulated on the lake bottom, and where bacterial activity is most intense. Visiting Abraham Lake in winter requires caution. While the ice is usually thick enough to walk on by midwinter, conditions can vary. Areas near inflows, where warmer water enters the lake, may have thinner ice. Pressure cracks and open water can occur. The wind can be fierce, creating blowing snow and extreme wind chill. But when conditions are right, the experience is magical. You walk across the frozen lake, stopping to peer down at different bubble formations, each one unique, each one a small frozen sculpture. The light matters enormously. On overcast days, the ice appears flat and grey, and the bubbles are less distinct. On sunny days, especially in early morning or late afternoon when the sun is low, the light penetrates the ice at an angle, illuminating the bubbles from within, making them glow. The ice takes on shades of blue and turquoise, and the bubbles stand out brilliantly white. From frozen lakes, we turn to a phenomenon that occurs not in ice but on snow, in a very specific set of conditions. These are snow donuts, also called snow rollers, cylinders of rolled snow that form naturally when wind blows across snow-covered ground. Snow donuts form when there is a layer of loose, wet snow on top of a crust of harder, icy snow. The conditions must be precise. The loose snow must be sticky enough to hold together, but not so wet that it becomes too heavy. The underlying crust must be slippery, icy or glazed with rain. And the wind must be strong enough to move the snow, but not so strong that it blows it apart. When these conditions align, a gust of wind can lift a clump of the loose snow and start it rolling down a slope or across flat ground. As it rolls, it picks up more snow, growing larger. The rolling motion creates a cylinder, and because the initial clump is often hollowed out or loosened, the center of the roll may fall out, creating a donut shape, a hollow cylinder of snow. Snow donuts are rare because the conditions required are so specific. They are most commonly reported in the Great Lakes region of North America, where lake effect snow creates the right kind of wet, heavy snow, and where the variable weather produces the cycles of thaw and refreeze that create the necessary crust layer. When snow donuts form, they can vary in size from a few inches to several feet in diameter. They are fragile, easily destroyed by touch or by continued wind. They typically last only a few hours or a day before they collapse, melt, or are blown apart. This makes them ephemeral wonders, appearing and disappearing with little notice. Fields covered in snow donuts look strange and surreal. The cylinders lie scattered across the snow surface, seemingly placed by hand, too regular to be natural, yet entirely natural. They cast small shadows. They collect in groups, sometimes dozens in one area, formed by the same weather event. From these small, ephemeral ice features, we turn to landscapes defined by ice on a much grander scale. We travel to Baffin Island in the Canadian Arctic, to Oyuitik National Park. The name Oyuitik means the land that never melts in Inuktitut, the language of the Inuit people. The park encompasses nearly 8,000 square miles of mountains, glaciers, and fjords, a landscape shaped entirely by ice. Oyuitik sits on the Cumberland Peninsula of Baffin Island, in a region where the climate is polar, where winter lasts for 9 months and temperatures can drop to -50 degrees Fahrenheit or lower. The park is north of the Arctic Circle, meaning it experiences polar night in winter, when the sun does not rise for weeks, and midnight sun in summer, when the sun does not set. The landscape is dominated by the Penny ice cap, a remnant of the Laurentide ice sheet that covered much of North America during the last ice age. The ice cap covers approximately 2,000 square miles and feeds numerous valley glaciers that flow down through mountain passes toward the sea. These glaciers are rivers of ice, moving slowly, grinding the bedrock beneath them, carving U-shaped valleys. The mountains of Oyuitik are among the most dramatic in the Arctic. Mount Asgard, perhaps the most famous peak in the park, has a flat top and vertical granite walls rising over 3,000 feet. It looks like a massive stone cylinder placed in the landscape, a fortress or a monument. The mountain was featured in the opening scene of a James Bond film, where a climber jumps off the summit with a parachute. The peak is sacred to the Inuit, and climbing it is a significant undertaking. The valleys between the mountains are filled with glacial outwash, gravel, and sand deposited by meltwater streams. In summer, these streams flow cold and fast, milky with rock flour, the fine sediment ground from bedrock by the moving ice. The streams braid across the valley floors, constantly shifting course, cutting new channels. Traveling through Oyuitik requires self-sufficiency. There are no roads, no facilities, no rescue services readily available. Visitors must be prepared for extreme cold, for unpredictable weather, for river crossings, for the possibility of encountering polar bears. The park is remote, accessible only by boat or small aircraft from communities on Baffin Island. The silence in Oyuitik is profound. Away from the rivers, away from the wind, there is almost no sound. The ice makes occasional noises, cracks and groans as it adjusts. Rocks fall from cliffs, clattering down slopes. But these are brief interruptions. The underlying state is silence, the kind of deep quiet that comes from being far from human activity, far from vegetation, in a place where sound has nothing to carry it, nothing to absorb it but rock and ice. We travel south and west to the Yukon Territory in Canada, to the Kluane icefields, part of the largest non-polar ice field in the world. The ice fields cover approximately 8,000 square miles, straddling the border between Canada and Alaska. The ice is thick, in places over a mile deep, and it feeds valley glaciers that flow in all directions. The Kluane icefields are part of a UNESCO World Heritage Site that includes Kluane National Park in Canada and Wrangell St. Elias National Park in Alaska. The region contains some of North America's highest mountains, including Mount Logan, Canada's tallest peak at 19,551 feet. The ice field exists because of the maritime climate. Moist air from the Pacific Ocean is lifted over the coastal mountains, cooling and dropping enormous amounts of snow. The annual snowfall in the accumulation zone of the ice field can exceed 30 feet. This snow compacts over time, turning to firn and then to glacial ice. The ice flows outward from the highest areas, moving down valleys toward lower elevations where it melts. The surface of the ice field is not flat. It is a landscape of ice, with ridges and valleys, crevasses and seracs. Ice falls where the glacier fractures as it flows over steep terrain. Traveling on the ice field is hazardous. Crevasses can be hidden by snow bridges that look solid, but will collapse under weight. The weather can change rapidly, bringing whiteout conditions where sky and ice merge and navigation becomes impossible. Few people visit the Kluane icefields. The access is difficult, requiring flights in small planes that land on the ice or long approaches on foot-up valley glaciers. But for those who do reach the icefields, the experience is one of total immersion in an ice world. The horizon in all directions is white and blue. The sky overhead is often brilliant and clear. The sun reflects off the snow, bright enough to require eye protection to prevent snow blindness. The ice field is not static. It is losing mass, melting faster than snow is accumulating. The glaciers fed by the ice field are retreating, their termini pulling back up the valleys, leaving behind landscapes of bare rock and glacial debris. This retreat is part of a global pattern, a response to warming temperatures, and it is transforming the landscape, revealing terrain that has been covered by ice for thousands of years. From the Kluane icefields, we travel to the largest national park in the world, a place so vast and so remote that it contains areas that have never been visited by humans. This is Northeast Greenland National Park, covering nearly 400,000 square miles, larger than all but 29 countries in the world. The park encompasses the northeastern coast and interior of Greenland, a landscape of ice sheet, mountains, fjords, and tundra. Approximately 80% of the park is covered by the Greenland ice sheet, the second largest ice sheet on Earth after Antarctica. The ice sheet is up to 2 miles thick and contains enough water to raise global sea levels by over 20 feet if it were to melt completely. The park was established in 1974 and expanded to its current size in 1988. It has no permanent human population. The only people present are scientists at a few research stations and occasional military personnel at a weather station on the coast. There are no facilities, no trails, no infrastructure. It is wilderness in the truest sense. The coastal areas of the park, where the ice sheet meets the sea, are regions of active glaciology. Valley glaciers flow from the ice sheet to the coast, calving icebergs into the fjords. These icebergs are massive, table-shaped blocks of ice that can be miles long. They drift in the fjords and out into the Greenland Sea, carried by currents, slowly melting. The ice-free areas of the park, primarily along the coast and on nunataks, isolated mountain peaks that protrude above the ice sheet, support a limited but remarkable ecosystem. Arctic foxes, musk oxen, Arctic hares, and a variety of bird species live here, adapted to the extreme cold and the long dark winters. Polar bears hunt along the sea ice. Walruses and seals haul out on ice floes. The park's remoteness ensures that it remains largely unstudied. Vast areas have never been surveyed on the ground. Satellite imagery provides views from above, but the details of the terrain, the specific glacial features, the smaller-scale ecology remain unknown. It is one of the last truly unexplored regions on Earth. The silence in northeast Greenland National Park is absolute. There is no human noise. No aircraft pass overhead, no boats travel the fjords, no vehicles traverse the ice. The only sounds are natural: the wind, the cracking of ice, the calls of animals. It is a silence of scale, a quiet that comes from vast emptiness. We travel west across the top of the world to Alaska, to the Brooks Range, to another vast wilderness park. This is Gates of the Arctic National Park and Preserve, encompassing over 8 million acres of mountains, rivers, and tundra north of the Arctic Circle. The park has no roads, no trails, no established campsites. It is one of the least visited national parks in the United States, receiving only a few thousand visitors per year compared to millions at parks like Yellowstone or the Grand Canyon. Access is by bush plane, small aircraft that land on gravel bars or lakes, dropping visitors into the wilderness for expeditions that are entirely self-supported. The Brooks Range is the northernmost mountain range in Alaska, a fold of the Earth's crust uplifted during the formation of the North American continent. The mountains are not as high as the Rockies or the Alaska Range, but they are rugged and remote. Glaciers hang in cirques, U-shaped valleys carved by ancient ice stretch for miles, and rivers flow swift and cold, fed by snowmelt. The park's name comes from a phrase used by wilderness advocate Robert Marshall, who explored this region in the 1930s. He wrote of coming to the gates of the Arctic, the entrance to the northernmost mountains, the threshold of a different world. Two peaks, Frigid Crags and Boreal Mountain, frame a valley that serves as a natural gateway, and these became symbolically the gates he described. The landscape of Gates of the Arctic shifts with the seasons. In winter, everything is frozen and snow-covered. Temperatures drop to -50 or -60 degrees. The sun barely rises above the horizon at midday, and for weeks around the winter solstice, it does not rise at all. In spring, the snow begins to melt, rivers break free of ice, and migratory birds arrive. Summer is brief but intense, with 24-hour daylight and an explosion of plant growth. Mosquitoes and other insects emerge in enormous numbers, swarming over the tundra. By early September, fall arrives, the tundra turns red and gold, and the first snows begin. Wildlife in the park includes caribou, which migrate through the region in herds numbering in the tens of thousands, following ancient routes between summer and winter ranges. Grizzly bears hunt ground squirrels and graze on berries. Wolves follow the caribou herds. Dall sheep navigate cliffs and rocky slopes. The ecosystem is intact, functioning as it has for thousands of years, without significant human alteration. Standing in the gates of the Arctic, surrounded by mountains that fade into distance in all directions, you are aware of your smallness, of the scale of the wilderness. There is no cell signal, no contact with the outside world. You are dependent entirely on what you carry and on your ability to navigate, to find water, to stay warm. It is a landscape that demands respect and competence, but it offers in return a sense of immersion in nature that is increasingly rare. We complete our journey through ice and cold in Siberia, in the vast forest that stretches across northern Russia, the largest forested region on Earth. This is the taiga, also called the boreal forest, a biome of coniferous trees adapted to long, cold winters and short summers. The Siberian taiga alone covers approximately 2.3 million square miles, larger than the entire Amazon rainforest. The taiga is defined by cold. Winter temperatures regularly drop to -40 or -50 degrees Fahrenheit. The ground freezes to great depths, creating permafrost in the north. Snow covers the forest for 6 to 8 months of the year. The trees that grow here, primarily larch, spruce, and pine, are adapted to these conditions. Larch is deciduous, unusual for a conifer, dropping its needles in fall to reduce water loss and damage from ice. Spruce and pine are evergreen, but have adapted with flexible branches that shed snow and with resins that prevent freezing. The forest is not uniform. It includes areas of dense growth, where trees stand close together, their canopies interlocking. It includes areas of open woodland, where trees are widely spaced and ground vegetation, lichens and mosses and low shrubs, covers the forest floor. It includes wetlands, bogs and fens where water accumulates and trees grow stunted or not at all. The taiga is home to a suite of cold-adapted animals. Brown bears, wolves, lynx, wolverines, sables, and ermines hunt or forage through the forest. Moose browse on willow and birch. Reindeer migrate through, moving between tundra in summer and forest in winter. Birds, including woodpeckers, owls, and numerous small songbirds, nest in the forest. In winter, most birds migrate south, but some, like the Siberian jay and the three-toed woodpecker, remain, finding food in the frozen forest. The taiga is also defined by silence, though it is a different silence than the ice fields. It is a muffled silence, sound absorbed by snow and by the trees. In winter, when the forest is deep in snow, footsteps are nearly silent. The only sounds are the occasional crack of a tree branch breaking under the weight of ice, the distant howl of a wolf, the soft whisper of snow sliding from branches. In summer, the forest is louder, with bird calls and the hum of insects, the rustle of wind through needles. But even then there is a quality of stillness, of a landscape that is fundamentally quiet. The Siberian taiga is largely uninhabited. Small indigenous groups, including the Evenki and the Nenets, live in the region, traditionally as reindeer herders and hunters. They have knowledge of the forest that spans generations, an intimate understanding of animal behavior, plant uses, navigation in a landscape where everything can look similar, where getting lost can be fatal. But their numbers are small, and vast areas of the taiga see no human presence at all. The taiga is changing. Warmer temperatures are causing permafrost to thaw, which destabilizes trees, creating drunken forests where trees tilt at odd angles. Forest fires, which are natural in the taiga ecosystem, are becoming more frequent and more intense. Insects that were once limited by cold winters are expanding their ranges, infesting and killing trees over large areas. The taiga, like the ice fields and glaciers, is responding to a warming world, and the changes are visible and accelerating. As we close this segment on ice, cold, and polar silence, we have journeyed from bleeding glaciers to frozen lakes filled with bubbles, from ephemeral sculptures of snow to immense ice fields and national parks measured in millions of acres, to forests that define cold itself. The cold places of the world are often seen as empty, as hostile, as places to be endured rather than appreciated. But they are filled with subtle beauty, with processes that occur nowhere else, with silence that allows for a different kind of awareness. Let the cold settle in your imagination, not as discomfort but as clarity, as the sharpness that comes from frozen air, from light reflecting off snow and ice. Let the silence deepen. In the cold places, there is less noise, less distraction, less clutter. What remains is essential, stripped down, reduced to what can survive and endure. Rest in this cold silence. Let it cool your thoughts, quiet your mind. The ice has been here for thousands of years, will be here for thousands more, even as it changes and retreats. For now, in this moment, it is simply here, blue and white and enduring. Sleep if you need to. The cold will not disturb you. The silence will not break. The journey continues, patient and unhurried, through landscapes that ask nothing but that you pause, that you notice, that you let them work their slow magic of peace. Water is the patient sculptor. It moves through landscapes not with the sudden violence of earthquakes or the dramatic spectacle of volcanic eruptions, but with persistence, with the steady application of force over time measured in thousands and millions of years. Water seeps into cracks in limestone, dissolving the rock grain by grain, molecule by molecule, enlarging fissures into passages, passages into chambers, chambers into caverns vast enough to contain entire forests. Water flows over stone, carrying particles of sediment that act as abrasives, grinding away at the rock beneath. A river carves its valley deeper year by year, century by century, the change invisible in any human lifetime, but accumulating into gorges and canyons given enough time. Water freezes in cracks, expanding, wedging the rock apart. Water evaporates, leaving behind dissolved minerals that precipitate into formations of extraordinary delicacy and beauty. We live on a water planet, 70% of the Earth's surface is covered by oceans. Water cycles continuously through atmosphere, land, and sea, falling as rain and snow, flowing in rivers and streams, percolating through soil and rock, emerging in springs and seeps, evaporating back into the air. This endless circulation of water is one of the fundamental processes that makes Earth habitable, that moderates temperature, that supports life, that shapes the surface of our world. In this segment, we turn our attention to places where water's patient work has created wonders, where underground rivers have carved labyrinths through stone, where minerals deposited by water have grown into crystals larger than trees, where water falls and flows and pools in ways that arrest the eye and quiet the mind. We begin in the mountains of central Vietnam, in Phong Nha Bang National Park, where a river disappears into a mountainside and flows through a cave so large that it contains its own weather systems, its own ecosystems, chambers tall enough to fit a 40-story building. This is Sun Dung Cave, the largest cave passage in the world by volume. Sun Dung was known to local people for many years. The entrance was discovered in 1991 by a local man named Ho Con, who was searching for timber and shelter from a storm. He heard the sound of a river and wind roaring from a hole in the limestone cliff, but when he peered inside, he saw only darkness descending into the earth. The entrance was too forbidding, and he left, intending to return, but unable to relocate it for nearly 20 years. In 2009, Ho Con rediscovered the cave and led a British caving expedition to explore it. What they found exceeded expectations. Sun Dung is over 5.5 miles long, with sections that are more than 600 feet high and 400 feet wide. A Boeing 747 could fly through the largest passages without touching the walls or ceiling. The cave was formed by a river, the Rao Thuong River, which flows through the cave during the wet season. Over millions of years, the river dissolved the limestone bedrock, carved by the weak carbonic acid formed when carbon dioxide from the atmosphere dissolves in rainwater. The process is slow, but in the humid climate of central Vietnam, with high rainfall and dense vegetation producing carbon dioxide from decaying organic matter, the water is particularly effective at dissolving limestone. The cave has multiple entrances where the roof has collapsed, creating dolines, open shafts that allow sunlight to penetrate into the cave. These sunlit areas have become underground gardens. Trees grow on the piles of collapsed rock at the base of the dolines, reaching heights of over 100 feet. Vines hang down from the openings above. The forest floor is covered with ferns and moss. Monkeys and birds enter the cave through these openings, and there are even populations of cave-adapted fish and invertebrates living in the underground river. Walking through Sun Dung is an experience of scale that is difficult to comprehend. The passages are so large that the beam of a flashlight does not reach the walls or ceiling. You walk in a sphere of light surrounded by darkness that extends in all directions. The sound of your footsteps is swallowed by the vastness. When the expedition team first entered some sections, they used military-grade laser rangefinders to measure the dimensions, and the devices reached their maximum range without detecting the far wall. The cave contains formations that occur nowhere else. There are cave pearls the size of baseballs, spherical stones formed when water dripping into pools causes calcite to precipitate around a grain of sand, building up in layers as the pearl rolls around in the pool. There are stalagmites over 200 feet tall, among the tallest in the world, formed over millions of years by calcium carbonate precipitating from dripping water. There are flowstones, where sheets of water flowing down cave walls have deposited layers of calcite, creating cascades of stone that look like frozen waterfalls. In some areas, the floor of the cave is covered with ancient fossils, marine creatures from the time when this limestone was forming on an ancient seabed 300 million years ago. In other areas, the floor is a jumble of massive boulders that fell from the ceiling during collapses. In still other places, the floor is smooth sediment deposited by the river during floods. Sun Dung is only accessible to a limited number of visitors per year, and expeditions require experienced guides and multiple days to traverse. The cave remains largely pristine, protected from the damage that often accompanies tourism. It is a reminder that even now, in the 21st century, there are still places on Earth being explored for the first time, chambers being entered by humans for the first time, landscapes hidden beneath the surface waiting to be discovered. From the vast chambers of Sundung, we travel to Mexico, to the Nika mine in Chihuahua, to a very different kind of cave, a chamber filled not with darkness and space, but with crystals, enormous translucent beams of selenite that crisscross the chamber like the fallen columns of a giant's cathedral. This is the Cave of Crystals, discovered in 2000 by miners drilling beneath the Nika mountain. The crystals in the Cave of Crystals are the largest natural crystals ever found. Some are over 30 feet long and weigh more than 50 tons. They are composed of selenite, a transparent form of gypsum, calcium sulfate dihydrate. The crystals are clear or slightly milky, and they formed in an environment that was extraordinarily stable for an extraordinarily long time. The cave sits approximately 1,000 feet below the surface, in limestone that contains lead, zinc, and silver ores. The Nika mine has been extracting these ores for over a century, and the mining has required continuous pumping to remove groundwater that constantly seeps into the mine shafts. The Cave of Crystals was filled with this groundwater until the miners pumped it out, revealing the crystals. The crystals formed in this water over a period of approximately 500,000 years. The process required very specific conditions. The water was heated by magma chambers deep beneath the mountain, maintaining a temperature of around 136 degrees Fahrenheit, just below the point at which selenite dissolves. The water was saturated with calcium sulfate, and the temperature remained stable for millennia. In this environment, crystals grew slowly and continuously. Selenite molecules in the water found the crystal surfaces and attached, adding layer upon layer, building the crystals larger. Because the temperature and chemistry was so stable, the crystals could grow without interruption, and without the formation of defects or multiple crystal nuclei that would create smaller, intergrown crystals. The result is individual crystals of unprecedented size and clarity. Entering the Cave of Crystals is like entering an alien world. The crystals are so large that they dominate the space. You cannot walk through the chamber without climbing over and around them. The surfaces are smooth and cool, and they reflect light in strange ways, creating a disorienting environment where up and down become ambiguous. But entering the cave is also extremely dangerous. After the water was pumped out, the temperature in the cave rose to around 136 degrees Fahrenheit, with nearly 100% humidity. The human body cannot cool itself effectively in these conditions. Evaporative cooling, the mechanism by which sweating regulates body temperature, does not work when the air is fully saturated with water vapor. Without special cooling suits, a person can survive in the cave for only about 10 minutes before risking heatstroke and death. Scientists and photographers who have entered the cave wear ice vests and use breathing apparatus to cool the air they inhale. Even with these precautions, visits are brief. The cave is hostile to human life, and extended exploration is not possible. The Nika mine has stopped pumping water from the lower levels, and the Cave of Crystals has been reflooded. The water protects the crystals from damage and from the changes in temperature and humidity that would cause them to dehydrate and crack. The crystals are once again submerged, preserved in the environment that created them, inaccessible but safe. It is unlikely that humans will enter the cave again for many years, perhaps not in our lifetimes. The crystals will continue to exist in the dark water, growing imperceptibly, adding molecules, patient and enduring. From Mexico, we travel to the Philippines, to the island of Palawan, to another underground river, but one very different from the river in Sundung. This is the Puerto Princesa underground river, which flows for 5 miles through a limestone cave system before emptying into the South China Sea. The Puerto Princesa River is navigable for approximately 2.5 miles from its mouth, and this section has been developed for tourism. Visitors enter the cave by boat, small paddle boats that carry a handful of passengers, guided by boatmen who navigate the dark water with practiced ease. The cave passage is wide and tall near the entrance, with daylight filtering in from the mouth where the river emerges onto a beach backed by limestone cliffs. As the boat moves deeper into the cave, the light fades, and artificial lights become necessary. The walls and ceiling of the cave are covered with limestone formations, stalactites hanging down and stalagmites rising up, some of them joined into columns where the two have met and fused over millennia. The formations have been given names by guides and visitors, shapes that resemble candles, curtains, vegetables, religious figures. This naming is common in show caves, a way of making the abstract forms relatable, a way of creating narrative and memory. The formations are illuminated by the boat's lights as it passes, and shadows shift and change, creating the illusion of movement in the stone. The river itself is calm and slow-moving, dark green or black in the artificial light. The water is fresh near the entrance, but becomes brackish farther in as tidal water from the sea pushes upstream. The transition from fresh to salt water creates a unique environment, a mixing zone where species adapted to both fresh and marine conditions can coexist. The cave is inhabited. Swiftlets nest in the upper reaches, their nests clinging to the walls and ceiling, built from saliva and plant material. Bats roost in enormous numbers, hanging in clusters from the ceiling, filling sections of the cave with their high-pitched calls and the smell of guano. The guano accumulates on the cave floor and in the water, creating a rich nutrient source for cave-adapted invertebrates, including crabs, shrimp, and various insects. The Puerto Princesa Underground River is a UNESCO World Heritage Site, recognized for its biodiversity and its geological significance. The cave system is thought to connect to other cave systems in the limestone karst of Palawan, creating a network of underground passages that has not been fully explored. The protected area around the river includes both the cave and the surrounding forest, a watershed that supplies the water flowing through the cave. We travel west to the Middle East, to Lebanon, to a cave system that has been known and valued for thousands of years. This is Jaita Grotto, a complex of interconnected limestone caves located in the Nahr al-Kalb Valley, just north of Beirut. Jaita Grotto consists of two main cave systems, an upper gallery that is explored on foot, and a lower gallery that contains an underground river navigable by boat. The caves have been inhabited and used by humans since prehistoric times. Stone tools and evidence of human activity, dating back to the Paleolithic period, have been found in the caves. The lower cave was rediscovered in modern times in 1836 by Reverend William Thompson, an American missionary, who entered the cave and traveled upstream on the underground river by boat. Subsequent explorations mapped the cave and revealed its extent. The river flows for over 4 miles within the cave, though only a portion is accessible to tourists. The upper cave was discovered in 1958, accessed through a tunnel that connects it to the lower cave. The upper gallery is dry, its passages and chambers filled with spectacular limestone formations. The scale is impressive. Some chambers are over 300 feet long and 100 feet high. The formations include massive stalactites, some over 25 feet long, as well as stalagmites, columns, draperies, and flowstones in shades of white, cream, red, and brown. The formations at Jaita Grotto are notable for their density and their variety. Every surface seems to be covered with calcite deposits. The ceiling bristles with stalactites of varying sizes. The floor is crowded with stalagmites. Thin curtains of stone hang in folds, translucent when backlit. The effect is overwhelming, a cave that seems almost overfull of decoration, a geological excess. The lighting in Jaita Grotto is carefully designed to highlight the formations without causing damage. Colored lights are avoided in favor of white light that reveals the natural colors of the stone. The pathways are paved and equipped with railings, allowing visitors to walk through the cave safely without touching or damaging the formations. Water continues to play a role in shaping Jaita Grotto. The underground river flows year-round, fed by rainfall and snowmelt in the mountains above. Water seeps through the limestone, dissolving calcium carbonate and carrying it into the cave, where it precipitates onto existing formations, slowly adding to their mass. The formations are still growing, though at rates too slow to be perceptible in human timescales. A stalactite might grow 1/10 of an inch per century, depending on the rate of water flow and the concentration of dissolved minerals. Jaita Grotto has faced challenges. During Lebanon's civil war, the caves were closed and access was restricted. There was concern about damage and looting. After the war, the caves were restored and reopened, and they have become a symbol of Lebanese natural heritage, a source of national pride. From Lebanon, we travel to New Zealand, to the North Island, to a cave system known not for its size or its formations, but for its inhabitants. These are the Waitomo glowworm caves, home to thousands of bioluminescent larvae that create a starry sky underground. The glowworms of Waitomo are not worms at all, but the larval stage of a fungus gnat, Arachnocampa luminosa, a species endemic to New Zealand. The larvae live on the ceilings of caves, each one hanging down a silk thread studded with sticky droplets. The larva produces light from a specialized organ on its tail, a cold bioluminescent light similar to that produced by fireflies, but continuous rather than flashing. The light serves to attract prey. Small flying insects, particularly mayflies and midges, are drawn to the light. When they approach, they become entangled in the sticky threads. The larva then hauls up the thread and consumes the captured insect. It is a form of passive predation, a trap set with light as bait. In the Waitomo caves, the glowworm population is dense. Thousands of larvae cluster on the cave ceilings, and their combined light creates an effect that resembles a night sky filled with stars. The light is blue-green, a soft glow that reflects off the water of the underground stream that flows through the cave. Visitors to Waitomo tour the caves by boat, floating silently down the underground river. The lights on the boat are extinguished, and as your eyes adjust to the darkness, the glowworms appear above, scattered across the ceiling in patterns that shift slightly as larvae move or as new larvae settle. The reflection of the lights in the water doubles the effect, creating the illusion of floating through space. The glowworms are sensitive to noise and vibration. Loud sounds or movements can cause them to stop producing light temporarily, retreating into a protective reflex. For this reason, visitors are asked to remain silent during the boat ride, and the guide navigates by pulling on a rope strung along the cave ceiling rather than using paddles that would disturb the water. The larval stage of the fungus gnat lasts for about 9 months, after which the larva pupates. The adult gnat emerges, lives for only a few days, mates, lays eggs, and dies. The adult cannot feed and does not produce light. Its sole purpose is reproduction. The eggs hatch into larvae, which then begin the cycle again. The Waitomo caves have been a tourist attraction for over a century. Local Maori knew of the caves and explored them using rafts made of flax stems and torches made of bundled flax reeds. In 1887, a Maori chief and an English surveyor made the first documented exploration of the glowworm grotto. Tourism began shortly thereafter, and the caves have been managed as a commercial operation ever since, with significant involvement and ownership by local Maori tribes. From the living lights of Waitomo, we travel to Patagonia, to the border between Chile and Argentina, to a lake where the boundary between water and stone is blurred by color and erosion. These are the Marble Caves, also known as the Marble Cathedral, a network of water-filled caverns carved into a peninsula of marble on the shore of Lago General Carrera, also called Lago Buenos Aires. The caves are not technically marble, but rather metamorphosed limestone, calcium carbonate that has been altered by heat and pressure into a crystalline form. The rock is white and grey with swirling patterns of blue, green, and black, mineral impurities that create bands and veins through the stone. The caves were carved by wave action. Lago General Carrera is the second largest lake in South America, deep and cold, fed by glacial meltwater from the surrounding mountains. For thousands of years, waves have lapped against the Marble Peninsula, eroding the softer sections of rock, enlarging cracks into fissures, fissures into passages, passages into chambers. The process continues, and the caves are still changing, still being carved by the water. The walls of the caves are smooth, polished by the constant motion of water and by the fine sediment suspended in it. The colors are striking. The blue and turquoise tones in the rock are enhanced by the color of the water itself, which is a vivid turquoise, colored by glacial rock flour, fine particles of rock ground by glaciers, and carried into the lake by meltwater streams. The rock flour remains suspended in the water, scattering light and creating the distinctive color. The caves are accessible only by boat, and the water level in the lake varies with the seasons, changing the appearance of the caves. In summer, when meltwater is high, the water level rises and some passages become partially submerged. In winter, the water level drops and more of the cave walls are exposed. The light inside the caves changes throughout the day. In morning and evening, when the sun is low, light enters at an angle, illuminating the walls with warm tones. At midday, the light is cooler and brighter, and the blues and greens are more vivid. Visitors navigate the caves in small boats or kayaks, maneuvering through narrow passages, entering chambers where the ceiling arches overhead and the water reflects the swirling patterns in the stone. The experience is one of color and texture, of stone and water in close relationship, of a landscape that is both solid and fluid, both permanent and changing. From the marble caves, we shift from underground water to surface water, to the cascades and flows that occur where rivers descend, where elevation drops and waterfalls. We travel to Croatia, to Plitvice Lakes National Park, a landscape of terraced lakes connected by waterfalls, a system created by the continuous deposition of travertine, calcium carbonate precipitated from the water. Plitvice Lakes consists of 16 main lakes, arranged in a descending series, each lake separated from the next by natural dams of travertine. The lakes are fed by rivers and streams that flow through the karst landscape of the Dinaric Alps, dissolving limestone as they flow, carrying dissolved calcium carbonate. When the water reaches the lakes, conditions change. The water slows, carbon dioxide is released to the atmosphere, and the calcium carbonate precipitates out of solution, forming travertine. The travertine deposits on mosses, algae, and fallen branches, gradually building up barriers across the flow. These barriers grow higher over time, creating dams that hold back water, forming new lakes. The process is continuous. The waterfalls that cascade over the travertine barriers are depositing more travertine, enlarging and reinforcing the dams. The lakes are slowly filling with sediment, but new travertine barriers are forming downstream, creating new lakes. The system is dynamic, constantly evolving, reshaping itself year by year. The water at Plitvice is remarkably clear and varies in color depending on the depth and the angle of light. Shallow areas are turquoise or pale blue. Deeper sections are dark blue or green. The color comes from the minerals in the water and from the way light interacts with the travertine at the lake bottom. The clarity allows visibility to great depths, and you can see fish swimming, see submerged logs covered in moss, see the texture of the travertine formations underwater. The waterfalls at Plitvice range from small cascades a few inches high to Veliki Slap, the Great Waterfall, which drops 250 feet. The water falls in multiple streams, spreading across the width of the travertine barriers, creating curtains of water that shimmer in the light. The sound is constant, a background of rushing water that pervades the park. The park is heavily forested, and the lakes are set in a landscape of beech and fir, with walking trails that wind along the shores and across the barriers on wooden boardwalks. The boardwalks are built to minimize impact on the fragile travertine formations, allowing visitors to experience the lakes without damaging them. Plitvice Lakes has been a protected area since 1949 and was designated a UNESCO World Heritage Site in 1979. The park faces challenges from tourism pressure and from changes in water chemistry that can affect travertine formation. Conservation efforts focus on managing visitor numbers and protecting the water quality of the rivers feeding the lakes. From the terraced lakes of Croatia, we travel to Iceland, to a waterfall that is less known than some of Iceland's famous falls, but is arguably more beautiful for its color and its setting. This is Brúarfoss, the Bridge Fall, a relatively small waterfall on the Brúara River in southern Iceland. Brúarfoss is not tall, only about 20 feet, and it is not particularly wide. What makes it remarkable is the color of the water. The Brúara River is fed by glacial meltwater, and like many glacial rivers, it carries rock flour, fine sediment that scatters light. But the concentration and the specific minerals in the Brúara create a color that is almost electric, a vivid turquoise blue that seems artificial, like dye has been added to the water. The waterfall drops over a ledge of dark basalt, the contrast between the black rock and the blue water creating a striking visual effect. The water churns white at the base of the fall, then settles back into the brilliant blue as it flows downstream. Upstream and downstream of the main fall are smaller cascades and rapids, the water weaving between rocks and boulders, creating patterns of white foam and blue water. The area around Brúarfoss is relatively undeveloped. For many years, it was accessible via private land, and visitors had to seek permission or risk trespassing. This limited access kept the waterfall less visited than other Icelandic attractions. In recent years, official trails have been established, making access easier, but also bringing more visitors. The best time to see Brúarfoss is in summer, when the glacial melt is highest and the water volume is greatest. In winter, the flow diminishes, and ice forms around the edges of the river and the waterfall, creating sculptures of ice that partially obscure the flow. The blue of the water is still visible through the ice, a frozen version of the summer cascade. From Iceland, we travel to Indonesia, to the island of Java, to a waterfall that is notable for its form rather than its color. This is Tumpak Sowu, which translates to 1,000 waterfalls, though the name is metaphorical rather than literal. The waterfall is a single major cascade surrounded by hundreds of smaller streams that flow over a semicircular cliff, creating a curtain of water that encloses a canyon. Tumpak Sowu is formed where the Glidi River plunges over a volcanic escarpment. The main fall drops approximately 390 feet. The surrounding smaller falls descend the cliff face in thin streams and rivulets, each following a crack or a channel in the rock. The combined effect resembles a giant amphitheater with water as the curtain, a semicircle of falling water enclosing a green, forested space at its base. The gorge at the base of the waterfall is accessible via a steep, slippery trail that descends through vegetation and over rocks. The trail is challenging, and reaching the base requires careful navigation and a tolerance for muddy, wet conditions. But from the base, the view is spectacular. You are surrounded by falling water on 3 sides. The sound is overwhelming, a roar that makes conversation difficult. The air is filled with mist, and rainbows form in the spray when the sun is at the right angle. The rock forming the cliff is volcanic, layers of ash and lava from eruptions of nearby volcanoes, particularly Mount Semeru, Java's tallest and most active volcano. The volcanic soil and the high rainfall support lush vegetation, and the cliff face is covered with ferns, mosses, and vines. The vegetation clings to the rock, finding purchase in cracks and on ledges, creating a vertical garden. Tumpak Sowu has become more well-known in recent years, as social media has spread images of the waterfall. The dramatic form and the surrounding landscape make it a popular destination for photographers. However, the remoteness and the difficulty of the trail have kept visitor numbers manageable compared to more accessible waterfalls. We complete our journey through water, caves, and flow in Morocco, in the Atlas Mountains, at a waterfall that has been known and visited for centuries. These are the Cascades d'Ouzad, the Ouzad Falls, a series of waterfalls on the El Abid River that drop approximately 360 feet in multiple tiers. Ouzad is a Berber word meaning the act of grinding grain, referring to the old mills that once operated near the falls, powered by the water. The falls are located in a region of olive groves and almond trees, a fertile area fed by the river and its tributaries. The falls descend in 3 main tiers, each separated by ledges where water pools briefly before continuing its descent. The water is milky brown during much of the year, colored by sediment eroded from the mountains upstream. During the dry season, the flow diminishes and the water clears somewhat, revealing the red-brown rock beneath. The area around Ouzad Falls is inhabited by Barbary macaques, a species of monkey that is the only macaque found outside Asia. The macaques live in the forests near the falls and are often seen on the trails and near the viewing areas. They are accustomed to human presence and can be bold, sometimes approaching visitors looking for food, though feeding them is discouraged. Trails lead to various viewpoints around the falls, including a path that descends to the base, where the force of the falling water has carved a pool in the rock. Boats offer rides on the pool, allowing visitors to approach the base of the falls and feel the spray. The vegetation around the falls is lush, fed by the constant moisture. Fig trees, oleanders, and ferns grow in profusion, creating a green oasis in the otherwise arid landscape of the Atlas foothills. The falls are most impressive in spring, when snowmelt from the high Atlas swells the river. The volume of water increases dramatically, and the roar of the falls can be heard from a distance. In late summer and fall, the flow decreases, and the falls become quieter, the water descending in thinner streams that catch the light and create rainbows in the afternoon sun. Ouzad Falls has been a destination for centuries, known to local Berber communities and later to travelers and tourists. The area has been developed with guest houses, restaurants, and souvenir shops, but it retains a relatively natural character. The falls themselves remain the focus, a point where water's patient work is made visible, where the El Abid River pauses in its journey to the sea, descending in a spectacular display before continuing onward through valleys and plains toward its eventual meeting with the ocean. As we close this segment on water, caves, and flow, we have journeyed through chambers carved by rivers, through caves filled with crystals and with light, across terraced lakes and past waterfalls of every size and color. Water is the medium through which limestone dissolves, through which minerals move and precipitate, through which landscapes are eroded and reshaped. It is patient and persistent, working continuously, never resting, flowing from high ground to low, seeking equilibrium, carving its path through whatever obstacles it encounters. Let the sound of flowing water fill your mind, not as noise but as rhythm, as the pulse of the hydrological cycle, as the movement that connects sky and earth, mountain and sea. Let it wash through your thoughts, carrying away what is not needed, leaving behind what is essential. Water is cleanser and sculptor, destroyer and creator. It takes no sides, holds no grudges, simply flows, following the laws of gravity and thermodynamics, shaping the world as it goes. Rest now in the sound of water, whether it is the gentle drip of condensation in a cave, the rush of a river through stone passages, or the roar of a waterfall plunging into a pool. The water will continue to flow whether you are awake or asleep. It has flowed for billions of years, and will flow for billions more. For now, let it flow through your awareness, and then let it flow on, carrying you with it into deeper rest, into the quiet pools where sleep gathers and holds. Life is older than mountains. The oldest rocks on Earth are approximately 4 billion years old, but life emerged nearly as quickly, with evidence of microbial activity dating back at least 3.5 billion years. For most of Earth's history, life was microscopic, single-celled organisms living in water, building reefs, cycling nutrients, producing oxygen that would eventually transform the atmosphere and make possible the evolution of more complex forms. The tree of life branches endlessly, species diverging from common ancestors, adapting to new environments, evolving new structures and strategies. Most branches end. Extinction is the fate of most species. More than 99% of all species that have ever lived are now extinct. But occasionally, a lineage persists, surviving mass extinctions, outlasting climate changes, remaining relatively unchanged for millions or even hundreds of millions of years. These are the organisms we call living fossils, a term that is scientifically problematic but captures something essential. They are survivors from ancient times, organisms whose basic body plan and way of life have remained stable while the world around them changed dramatically. They are windows into deep time, reminders that the past is not entirely past, that threads connect us backward through unimaginable stretches of history to the earliest days of life on Earth. In this segment, we turn our attention to these ancient lineages, to organisms and ecosystems that have persisted across geological ages, that have witnessed the rise and fall of mountain ranges, the opening and closing of oceans, the evolution and extinction of countless other species. We begin at the edge of a warm, shallow sea on the western coast of Australia, where structures that look like rocks are actually among the oldest forms of life on Earth. Shark Bay, in Western Australia, is home to one of the few places in the modern world where stromatolites still form. Stromatolites are layered structures built by cyanobacteria, photosynthetic microorganisms that were among the first life forms to produce oxygen. The cyanobacteria form mats on the seafloor or on rocks in shallow water. As they photosynthesize, they secrete sticky substances that trap sediment particles. The sediment accumulates in layers, building up over time, creating mound-shaped or columnar structures. Stromatolites were abundant throughout Earth's oceans for billions of years. The fossil record contains stromatolites dating back 3.5 billion years, making them among the oldest evidence of life. For most of Earth's history, stromatolites were the dominant reef-building organisms, creating vast carbonate platforms in shallow seas. But approximately 500 million years ago, with the evolution of grazing animals, snails and other organisms that could eat the cyanobacterial mats, stromatolites declined. Most were consumed as fast as they formed. Stromatolites persist in Shark Bay because the water is hypersaline, approximately twice the salinity of normal seawater. Few grazing animals can tolerate this salinity, which means the cyanobacterial mats can grow without being eaten. The stromatolites in Hamelin Pool, a region within Shark Bay, are extraordinary. They cover several square miles of shallow seafloor, forming structures up to 3 feet tall, shaped like domes, columns, or broad flat mats. Walking among the stromatolites at low tide is an experience of temporal displacement. These structures look like rocks, grey and lumpy, encrusted with salt. But they are alive, growing imperceptibly, adding microscopic layers year by year. The living surface is a mat of cyanobacteria, green or brown, slimy to the touch. Beneath the surface are the accumulated layers of sediment and mineral, the record of years and decades and centuries of growth. The stromatolites breathe. During the day, when sunlight is available, the cyanobacteria photosynthesize, producing oxygen. The water around the stromatolites becomes supersaturated with oxygen, and bubbles form on the surface of the mats. At night, photosynthesis stops, and the cyanobacteria respire, consuming oxygen and producing carbon dioxide. The stromatolites are ecosystems, miniature worlds where microorganisms interact, where nutrients cycle, where energy from sunlight is captured and stored. Shark Bay's stromatolites are a glimpse into Earth's ancient past, a living demonstration of the processes that created the oxygen in our atmosphere, that laid the foundations for all subsequent life. Standing beside them, you are in the presence of a form of life that has remained essentially unchanged for over 3 billion years, that has survived every mass extinction, every climate change, every geological upheaval, persisting quietly in salty shallows, building their layered monuments to patience and endurance. From the oldest continuously existing life form, we travel to the Indian Ocean, to the volcanic islands of the Comoros, off the coast of East Africa, to the habitat of a fish that was thought to be extinct for 65 million years, until a living specimen was discovered in 1938. This is the coelacanth, a large, slow-moving fish with fleshy, lobed fins that are more similar to the limbs of land animals than to the fins of most fish. Coelacanth are known from fossils dating back approximately 400 million years. They were abundant and diverse during the age of dinosaurs. Fossils have been found on every continent, but the fossil record showed coelacanth disappearing at the end of the Cretaceous period, 65 million years ago, at the same time as the dinosaurs. They were presumed extinct. Then, in December 1938, a fishing trawler operating off the coast of South Africa brought up a strange fish in its nets. The captain showed it to Marjorie Courtney Latimer, curator of a small museum in East London. She recognized it as something unusual and contacted ichthyologist J.L.B. Smith. Smith identified the fish as a coelacanth, a species that was supposed to have been extinct for millions of years. The discovery caused a sensation in the scientific community. A second specimen was not found until 1952, when a coelacanth was caught in the Comoros Islands, about 2,000 miles north of the first discovery. Further investigation revealed that coelacanth were known to local fishermen in the Comoros, who occasionally caught them in deep water. The fish were not valued as food because their flesh is oily and unpalatable. Coelacanth live in deep water, typically between 300 and 1,200 feet, in submarine caves and steep volcanic slopes. They are large fish, up to 6 feet long, and weighing up to 200 pounds. They are slow swimmers, drifting more than actively pursuing prey. Their lobed fins can move independently, allowing them to maneuver in complex ways, almost walking along the seafloor or hovering in the water. The fins are of particular interest because the bone structure within them is similar to the bone structure in the limbs of tetrapods, the land vertebrates. Coelacanth are related to the lineage of fish that gave rise to the first amphibians, the fish that crawled out of the water onto land approximately 370 million years ago. Studying living coelacanth provides insights into this transition, into the anatomy and physiology of the ancestors of all land vertebrates, including humans. Coelacanth are ovoviviparous, meaning the eggs develop and hatch inside the female's body, and she gives birth to live young. The gestation period is thought to be approximately 13 months, and females give birth to only a few offspring at a time, perhaps 5 to 25. The young are born fully formed, capable of swimming immediately. This reproductive strategy, combined with the fish's slow growth and late maturity, makes coelacanth vulnerable to overfishing. The coelacanth population is small, probably numbering only a few hundred individuals in the Comoros. A second species of coelacanth was discovered in 1997 in Indonesia, extending the known range, but both populations are considered endangered. Conservation efforts focus on reducing accidental catches and protecting the deep water habitats where the fish live. Swimming in the deep, dark waters off volcanic islands, the coelacanth continues its existence much as it has for hundreds of millions of years, a relic from an age when fish were just beginning to explore the possibilities of life on land, a survivor that has outlasted countless other lineages, persisting in the depths, largely unchanged, a reminder that the past is not always past. From the depths of the ocean, we travel to the islands of New Zealand, to rocky slopes and coastal forests where the last surviving member of an ancient order of reptiles makes its home. This is the tuatara, a lizard-like reptile that is not a lizard but a member of Rhynchocephalia, an order that was diverse and widespread during the age of dinosaurs, but is now represented by only this one genus, found only in New Zealand. Tuataras look somewhat like iguanas or large lizards, with scaly skin, a crest of spines down the back, and a length of up to 30 inches including the tail. But anatomically, they are distinct from lizards. They have a unique skull structure with two complete arches, a feature found in their ancestors, but lost in modern lizards and snakes. They have a primitive eye structure, with a third eye on top of the head, the parietal eye, which is visible in young tuataras, but becomes covered with scales as they mature. This third eye can detect light and dark, but does not form images. It may help regulate circadian rhythms and seasonal behaviors. Tuataras are cold-blooded and adapted to cool climates. They are most active at temperatures around 60 degrees Fahrenheit, which is unusually cool for reptiles. Most reptiles prefer warmer temperatures. This adaptation to cool climates may be why tuataras survived in New Zealand, which has a temperate climate, while their relatives elsewhere went extinct. The tuatara's metabolism is extraordinarily slow. They grow slowly, taking 10 to 20 years to reach sexual maturity. They can live for over 100 years, possibly as long as 150 years or more. Females reproduce infrequently, perhaps once every 4 years, and the eggs take 12 to 15 months to hatch, the longest incubation period of any reptile. Tuataras were once widespread across New Zealand, but with the arrival of humans and the introduction of rats and other predators, their populations collapsed. They now survive only on about 30 small islands off the coast, islands that are rat-free and where conservation efforts have been implemented. The islands are often seabird colonies, and tuataras share burrows with seabirds, particularly petrels and shearwaters. The burrows provide shelter, and the seabirds provide a food source in the form of eggs and chicks, though tuataras also eat insects, worms, and other small animals. Tuataras are nocturnal, emerging from their burrows at night to hunt. They move slowly, relying more on ambush than on pursuit. Their jaws are lined with 2 rows of teeth on the top and 1 row on the bottom, and the teeth are not separate structures, but projections of the jawbone, another feature that distinguishes them from lizards and snakes. The conservation status of tuataras has improved in recent decades. Breeding programs have been established, and tuataras have been reintroduced to some predator-free mainland sites. But they remain vulnerable, dependent on intensive management to keep predators away and to maintain suitable habitat. They are a reminder of how fragile ancient lineages can be, how easily millions of years of evolutionary history can be erased by environmental changes or the introduction of new predators. From New Zealand, we travel to the Namib Desert, one of the oldest and driest deserts on Earth, to a plant that seems designed by an alien intelligence. So strange is its form and its life strategy. This is Welwitschia mirabilis, a plant that produces only 2 leaves in its entire life, leaves that grow continuously and can become over 20 feet long, tattered and split by wind into ribbons that sprawl across the desert floor. Welwitschia is not related to any other living plant. It is the sole member of its family and its order, a relict lineage that has persisted for over 100 million years. Fossils of similar plants have been found in Brazil and Africa, dating to the Cretaceous period, but all other members of the lineage are extinct. Welwitschia survives in the Namib Desert, along the coast of Namibia and southern Angola, in a hyperarid environment where rainfall is less than 2 inches per year and often less than half an inch. The plant consists of a woody stem, short and wide, often only a foot or two tall but several feet across, that grows partially buried in the sand. From the rim of this stem emerge two leaves, one on each side. The leaves grow from a basal meristem, a zone of continuous growth at the base of the leaf. As new tissue is produced at the base, the older tissue at the tip is abraded by wind and sand, splitting into long ribbons that curl and tangle across the ground. The leaves are leathery and waxy, adapted to retain moisture in the extreme desert environment. They have pores, stomata, that open at night to take in carbon dioxide for photosynthesis and close during the day to prevent water loss. The plant absorbs moisture not just through its roots, but also through the leaves, capturing water from the coastal fog that rolls in from the Atlantic Ocean on many nights. This fog is the primary source of water for Welwitschia and for much of the life in the coastal Namib Desert. Welwitschia is dioecious, meaning there are separate male and female plants. The plants produce cones, reproductive structures that are more similar to pine cones than to flowers, reflecting Welwitschia's classification as a gymnosperm, related to conifers and cycads rather than to flowering plants. The cones are borne on branched stalks that rise from the center of the plant. Pollination is by insects, primarily wasps and bugs that visit the cones for nectar. Welwitschia grows extremely slowly. A plant may be only a few inches across after 10 years. Large specimens, several feet in diameter, are centuries old. The oldest known Welwitschia, based on radiocarbon dating, is estimated to be between 1,000 and 2,000 years old, possibly older. The plants are essentially immortal if conditions remain suitable, continuing to produce new leaf tissue and cones year after year. The distribution of Welwitschia is limited to a narrow strip along the Namib coast, perhaps 100 miles wide and 600 miles long. The plants are scattered, often growing in gravel plains or on rocky outcrops. They are adapted to this specific environment, to the fog and the heat and the scarcity of water, and they cannot survive elsewhere. Attempts to cultivate Welwitschia in other climates have had limited success. The plants grow, but often do not reproduce or develop the same robust form. Standing beside a large Welwitschia, its leaves sprawling in a tangled mass, scorched by sun and shredded by wind, you are in the presence of a survivor from an unimaginably distant past. A plant that has found a way to persist in one of Earth's most inhospitable environments, producing year after year the same two leaves, never replacing them, simply growing them longer. A strategy that seems absurd, and yet has worked for over 100 million years. From Welwitschia, we turn to another group of ancient plants, the cycads, seed plants that superficially resemble palms, but are more closely related to conifers. Cycads were abundant during the Mesozoic era, the age of dinosaurs, and they formed a major component of the flora that dinosaurs browsed. Today, cycads are rare, with only about 300 species surviving, most of them endangered. South Africa is home to some of the world's most diverse cycad populations, and among the most notable is Encephalatos, a genus of cycads that includes some of the rarest plants on Earth. Some species of Encephalatos are extinct in the wild, surviving only in botanical gardens. Others persist in small, isolated populations in rugged terrain where they are protected from poaching. Cycads grow slowly. A plant may take 10 or 20 years to produce a single new leaf. The leaves are large and fern-like, arranged in a crown at the top of a trunk that can be several feet tall in mature plants. The trunk is covered with the bases of old leaves, creating a rough, armored appearance. Cycads are dioecious, with separate male and female plants. The plants produce large cones, some weighing over 100 pounds, the largest cones in the plant kingdom. The cones take months to mature, and pollination is often by specific beetle species that are attracted to the heat and odor produced by the cones. The cones generate heat through cellular respiration, sometimes raising their temperature 20 degrees above the surrounding air, and they release volatile compounds that smell foul to humans, but attractive to the pollinating beetles. The seeds of cycads are toxic, containing compounds that can cause neurological damage in animals that eat them. But some animals have evolved detoxification mechanisms. In South Africa, baboons eat cycad seeds, and there is evidence that early humans may have processed cycad seeds to remove toxins, using them as a food source. Cycads face numerous threats. Habitat loss, climate change, and poaching for the horticultural trade have decimated populations. Some cycad species are worth thousands of dollars on the black market, and plants are illegally removed from the wild despite legal protections. Conservation efforts include habitat protection, cultivation in botanical gardens, and programs to reintroduce cultivated plants into protected wild areas. Walking among cycads in their natural habitat, on rocky slopes or in dry forests, you're walking among living remnants of the Mesozoic, plants that have persisted through the extinction of the dinosaurs, through ice ages and climate shifts, through the rise and spread of flowering plants. They are slow, tough, and enduring, adapted to poor soils and variable rainfall, survivors that ask little of their environment and give back structure and shelter and ancient continuity. From cycads, we turn to another ancient plant lineage, one that was thought to be extinct until living trees were discovered in China in the 1940s. This is the ginkgo, or maidenhair tree, Ginkgo biloba, a species with no close living relatives, the sole survivor of an order of plants that was diverse during the age of dinosaurs. Ginkgo leaves are distinctive, fan-shaped with radiating veins, often with a notch in the center that divides the leaf into two lobes, hence the species name biloba. The leaves turn bright yellow in fall before dropping, creating a carpet of gold beneath the tree. Ginkgos are deciduous, unusual among ancient plant lineages, most of which are evergreen. Ginkgos were long cultivated in China, planted in temple gardens and around monasteries, valued for their beauty and their hardiness. But wild populations were unknown to science. Botanists knew the tree only from cultivation and assumed it was extinct in the wild. Then, in the 1940s, wild ginkgo groves were discovered in remote mountains of eastern China, in the provinces of Zhejiang and Anhui. These groves were small, consisting of a few dozen to a few hundred trees, growing on steep slopes in mixed forests. The discovery confirmed that ginkgo is native to China and that it has persisted in the wild despite centuries of cultivation and despite the assumption that it was extinct. The wild groves are now protected, and efforts are being made to study and preserve them. Ginkgo trees can live for over 1,000 years and can grow to heights of over 100 feet. They are dioecious, with male and female trees. The male trees produce pollen in small cones. The female trees produce seeds enclosed in a fleshy, fruit-like covering that has a distinctive and unpleasant smell when ripe, often compared to rancid butter or vomit. The smell is caused by butyric acid, the same compound that gives rancid butter its odor. The smell attracts animals that eat the seeds and disperse them, though in modern urban environments, where ginkgos are often planted as street trees, female trees are avoided because of the smell. Ginkgo is remarkably resistant to disease, pests, and pollution. The trees can grow in poor soils and tolerate urban conditions that would kill most other trees. They are radiation resistant, and ginkgo trees survived the atomic bombing of Hiroshima, regrowing from the roots after being burned and blasted. This hardiness is part of why ginkgo has survived so long, able to persist in changing environments, able to endure stresses that eliminated other species. From ginkgo, we turn to another tree that was known only from fossils until living specimens were discovered. This is the dawn redwood, Metasequoia glyptostroboides, a deciduous conifer that was thought to be extinct for millions of years until a small population was found in central China in the 1940s. Dawn redwoods are tall trees, reaching heights of over 200 feet, with a straight trunk and a conical crown. The leaves are flat needles arranged in opposite pairs on deciduous branchlets. In fall, the needles turn orange or reddish-brown before dropping, giving the tree its common name, as the warm colors resemble the light of dawn. Fossils of Metasequoia are found across the northern hemisphere, including North America, Europe, and Asia, in rocks dating from the Cretaceous through the Miocene, approximately 100 million to 5 million years ago. The fossils show that dawn redwoods were once widespread and abundant. But by the Pleistocene, approximately 2 million years ago, the fossil record goes silent. The trees were presumed extinct. In 1941, a forester in Sichuan province, China, encountered a large, unfamiliar tree. Specimens were collected, and in 1946, the tree was identified as Metasequoia, a genus known only from fossils. The discovery caused excitement in the botanical and paleontological communities. Living fossil had become a physical reality, not just a metaphor. Further exploration revealed a small wild population of dawn redwoods in a remote valley in Hubei and Sichuan provinces. The population consisted of approximately 1,000 trees scattered across a region of rice paddies and villages. The trees were growing in a cool, humid climate with ample rainfall, conditions similar to those inferred from the fossil record. Seeds from the Chinese dawn redwoods were distributed to botanical gardens and arboreta around the world in the late 1940s. The species proved easy to cultivate, fast-growing, and adaptable to a range of climates. Today, dawn redwoods are commonly planted as ornamental trees, and there are probably more dawn redwoods growing outside China than within the native range. The wild population remains small and vulnerable. Habitat loss and changes in land use threaten the trees. Conservation efforts focus on protecting the remaining wild groves and maintaining genetic diversity. The dawn redwood is a reminder that extinction is not always final, that species can persist in small, isolated refuges, waiting to be rediscovered. From China, we travel to Australia, to a remote canyon in the Wooloomi National Park, northwest of Sydney, where one of the most remarkable botanical discoveries of the 20th century was made. In September 1994, a park ranger named David Noble was exploring a remote canyon, rappelling into areas that had never been surveyed, when he encountered trees unlike any he recognized. He collected samples and brought them to botanists, who identified the trees as a new genus and species, Wollemia nobilis, the Wooloomi pine. The Wooloomi pine is not a true pine, but a member of the Araucariaceae family, related to the monkey puzzle tree and the Norfolk Island pine. Fossil relatives of Wollemia date back approximately 200 million years, and fossils very similar to the living species are found in rocks 90 million years old. The Wooloomi pine was thought to be extinct, known only from fossils, until the living trees were found. The wild population consists of fewer than 100 adult trees and perhaps 200 juveniles, growing in 3 small groves in deep, narrow canyons in the Wooloomi wilderness. The canyons are remote and difficult to access, which is likely why the trees remained undiscovered until the 1990s. The location of the groves is kept secret to protect the trees from disturbance and from the introduction of diseases or pathogens. Wooloomi pines can grow to heights of over 130 feet. The bark is distinctive, dark brown and knobbly, resembling bubbling chocolate. The leaves are arranged in 4 rows on flattened branchlets, giving the foliage a ferny appearance. The trees are monoecious, with both male and female cones on the same tree. The cones are borne at the tips of branches, with female cones at the top of the tree and male cones lower down. The Wooloomi pine reproduces both by seed and by cloning. Some of the trees in the wild groves are genetically identical, having grown from root sprouts of older trees. This cloning ability has helped the species persist in the face of environmental challenges and limited genetic diversity. Conservation efforts have focused on propagating Wooloomi pines and distributing them widely to botanical gardens and private growers. The strategy is to ensure that even if the wild population is lost, the species will survive in cultivation. Thousands of Wooloomi pines have been planted around the world, reducing the extinction risk, but raising questions about whether a species maintained only in cultivation is truly saved. The wild groves remain the focus of intensive protection. Access is restricted. Monitoring is ongoing. The hope is that the Wooloomi pine, having survived for millions of years in isolation, will continue to survive, a living link to the age of dinosaurs, a reminder that the world still holds secrets, that forests still contain undiscovered species. From the ancient Wooloomi pine, we turn to individual trees of extraordinary age. In the White Mountains of California, in a harsh, windswept landscape of rocky slopes and sparse vegetation, grow bristlecone pines, Pinus longiva, the oldest known non-clonal organisms on Earth. The oldest known living bristlecone pine, nicknamed Methuselah, is over 4,800 years old. It was a seedling when the pyramids of Egypt were being built, a young tree when writing was being invented in Mesopotamia. Bristlecone pines grow at high elevations, between 9,000 and 11,000 feet, in conditions where few other trees can survive. The growing season is short, often only a few weeks per year. The soils are poor, often derived from dolomite, a magnesium-rich carbonate rock that few plants tolerate. Water is scarce, Temperatures are extreme, with hot days and freezing nights. In these harsh conditions, bristlecone pines grow incredibly slowly. A tree may add only 1/100th of an inch to its diameter per year. The wood is extremely dense, full of resin, resistant to rot and insect damage. When a tree dies, the wood can persist for thousands of years, standing as a weathered snag or lying on the ground, barely decaying. The oldest bristlecone pines are often partially dead. Sections of the trunk have died back, the bark stripped away by wind and ice, leaving bleached, twisted wood. But a strip of living bark and cambium persists, connecting a few living branches to the roots. The tree continues to grow, albeit slowly, adding new wood to the living strip while the dead sections endure, monuments to the tree's persistence. The bristlecone pines are important for climate science. The annual growth rings in the wood provide a record of climate conditions, with wider rings indicating wetter years and narrower rings indicating drier years. By analyzing living trees and dead wood, scientists have constructed a continuous tree ring chronology extending back over 8,000 years, the longest such record in the world. This chronology is used to calibrate radiocarbon dating and to study past climate variations. The exact location of Methuselah is kept secret to protect the tree from vandalism. Visitors to the ancient bristlecone pine forest in the White Mountains can walk among old trees, some over 3,000 years old, but they do not know which tree is Methuselah. It stands anonymously among its neighbors, ancient and unassuming, asking nothing, simply persisting. We complete our journey through living fossils and ancient life with a very different type of organism. Not a single ancient tree, but a clonal colony, a vast interconnected network of genetically identical trees that may be one of the oldest living organisms on Earth. This is Pando, a quaking aspen colony in the Fish Lake National Forest in Utah. Pando, which means I spread in Latin, consists of approximately 47,000 individual aspen stems, all connected by a single root system. The entire colony covers over 100 acres and weighs an estimated 6,600 tons, making it possibly the heaviest organism on Earth. All the stems are genetically identical, clones produced by root sprouts from the original tree. Aspen commonly reproduce by cloning. When an aspen tree is cut or burned or damaged, the roots send up new shoots. These shoots grow into new trees, but they remain connected to the parent root system. Over time, a single aspen can give rise to a grove of hundreds or thousands of stems, all genetically identical. Pando is extraordinary for its size and its age. While individual aspen stems live only 100 to 150 years, the root system can persist for thousands of years, continuously producing new stems to replace those that die. The age of Pando's root system is uncertain, but estimates based on growth rates and genetic analysis suggest it could be 80,000 years old, possibly older, making it one of the oldest living organisms. The colony occupies a site that has remained relatively stable, not subjected to catastrophic fires or other disturbances that would kill the entire root system. The aspen has persisted, spreading slowly, sending up new stems, replacing old growth with new, maintaining genetic continuity across millennia. But Pando is now in decline. The stems are not regenerating as they should. Overgrazing by deer and elk, which browse the young shoots, prevents new growth. The lack of regeneration means the colony is aging, with fewer young stems and more old dying stems. Without intervention, Pando may collapse, the root system finally succumbing after tens of thousands of years. Conservation efforts are underway. Fencing has been erected to exclude deer and elk from sections of the colony, allowing young shoots to grow. Monitoring is ongoing. The goal is to allow Pando to regenerate, to produce a new generation of stems, to continue its ancient existence into the future. Pando is a reminder that age and size and continuity are not guarantees of survival. Even the oldest, largest, most persistent organisms can be vulnerable to changes in their environment, to the introduction of new pressures, to the failure of the conditions that have sustained them for so long. But Pando also reminds us that life is resilient, that regeneration is possible, that even an organism 80,000 years old can, with help, produce new growth and continue its existence. As we close this segment on living fossils and ancient life, We have journeyed from stromatolites that have persisted for billions of years to trees and plants and animals that have survived hundreds of millions of years. Through mass extinctions and climate changes, through the rise and fall of continents and oceans. These organisms are more than curiosities. They are evidence of life's persistence, of the deep continuity that connects the present to the unimaginably distant past. Let the weight of this time settle in your awareness. Billions of years, millions of years, thousands of years. Time scales that dwarf human civilization, that make our individual lives seem like flickers. And yet these ancient organisms exist alongside us, sharing the present moment, growing and reproducing and persisting, their existence a quiet testament to endurance. Rest now in the knowledge that life is old and tough and varied, that it finds ways to persist even in the harshest conditions, that threads connect backward through time to the very origins of life on this planet. You are part of this continuity, a brief expression of a lineage that extends back billions of years. For now, let the ancient organisms stand watch. They have outlasted everything else. They will outlast this night. Sleep, knowing that the old trees and the ancient microbes continue their slow work, adding another layer, another season, another moment to their long, patient existence. Forests are the lungs of the earth. They breathe in carbon dioxide and breathe out oxygen, cycling gases between atmosphere and biosphere, moderating climate, stabilizing soil, creating the conditions necessary for life as we know it. A forest is not merely a collection of trees. It is an ecosystem, a community of organisms interacting across multiple layers, from the soil microbes and fungi that form networks among the roots, through the understory of ferns and shrubs and young trees, through the middle canopy where birds nest and mammals forage, to the emergent crown where the tallest trees reach toward sunlight. Forests store history. The trees themselves are archives, recording in their rings the climate of each growing season, the wet years and the dry years, the fires and the floods. The forest floor accumulates fallen leaves and branches, the bodies of animals, nutrients cycling back into soil. Ancient forests, those that have persisted for centuries or millennia without major disturbance, develop complexity that young forests cannot match. They contain standing dead trees that provide habitat for cavity-nesting birds and roosting bats. They contain fallen logs in various stages of decay, hosting fungi and insects and small mammals. They contain trees of all ages, creating a structural diversity that supports biodiversity. Most of Earth's ancient forests are gone. They have been logged, burned, converted to agriculture, fragmented into isolated patches. The forests that remain are often protected, recognized as invaluable for their ecological functions, their biodiversity, their carbon storage, their beauty. In this segment, we turn our attention to these remaining forests, to places where trees still grow to extraordinary heights or ages, where ecosystems function much as they have for thousands of years, where you can walk among organisms that have never encountered human disturbance. We begin in Northern California, in the coastal redwood forests, where the tallest tree on Earth stands in an undisclosed location, known only by its nickname, Hyperion. The tree is a coast redwood, Sequoia sempervirens, and it measures 380 feet tall, taller than a 30-story building, taller than the Statue of Liberty, including its pedestal. Coast redwoods are adapted to the fog belt of the California and Oregon coast, a narrow strip where summer fog rolls in from the Pacific Ocean, condensing on the trees and dripping to the ground, providing moisture during the dry season. The fog is essential. It reduces water stress, keeps temperatures moderate, and adds moisture to the forest even when no rain falls. Redwoods can live for over 2,000 years and grow to enormous sizes. The wood is resistant to rot and insects, containing tannins and other compounds that protect against decay. The bark is thick, up to 12 inches, fibrous and fire-resistant, allowing mature trees to survive fires that would kill other species. Hyperion was discovered in 2006 by naturalists Chris Atkins and Michael Taylor, who were systematically searching for tall trees using laser measuring devices. The tree was not in an old-growth grove, but in a relatively young, regenerating forest, an area that had been logged, but where this tree and a few others had been overlooked. The discovery was kept quiet for several years to prevent damage from visitors, and even now, the exact location is not publicized. Standing at the base of Hyperion, or any of the tallest redwoods, is an exercise in perspective. The trunk rises straight up, disappearing into the canopy high overhead. The lower branches are often hundreds of feet above the ground, unreachable without climbing equipment. The diameter of the trunk at the base can be over 20 feet. You cannot see the top of the tree from the ground. The foliage is so high that it is difficult to perceive the tree as a single organism. It seems more like a living tower, a structure connecting earth and sky. The canopy of the tallest redwoods is an ecosystem unto itself. Soil accumulates on large branches where organic matter collects and decomposes. Ferns and huckleberries grow in this canopy soil, rooted hundreds of feet above the ground. Salamanders have been found living in the canopy, never descending to the forest floor, their entire lives spent in the treetops. The canopy is cooler and wetter than the forest floor, bathed in fog, creating conditions that support species found nowhere else. Redwood forests are quiet. The thick canopy absorbs sound. The forest floor is often carpeted with redwood sorrel, a low-growing plant with clover-like leaves, or with ferns that grow in the filtered light. Fallen logs, massive and decaying slowly, lie scattered across the ground, hosting mushrooms and mosses and young trees that germinate on the logs, their roots eventually reaching down to the soil as the log decays beneath them. The redwood forests have been heavily logged. Less than 5% of the original old-growth redwood forest remains. What survives is protected in state and national parks, but the protected groves are islands surrounded by logged land that is now growing back in younger, less diverse forests. The ancient trees that remain are treasures, not just for their size and age, but for the ecosystems they support, the genetic diversity they represent, the carbon they store, the continuity they provide with a time when these forests stretched unbroken for hundreds of miles along the coast. From the redwood forests of California, we travel to Japan, to the island of Yokoshima, where another ancient conifer grows in isolation. This is Jomonsugi, a Japanese cedar, Cryptomeria japonica, estimated to be between 2,000 and 7,000 years old, making it one of the oldest trees in Japan, and possibly the oldest tree in Asia. Jomonsugi grows on the slopes of Yokoshima, a mountainous island off the southern coast of Kyushu. Yokoshima is one of the wettest places in Japan, receiving over 300 inches of rain per year in the mountains. The rain supports lush forests of cedar, fir, and bamboo, with an understory of moss and ferns that covers every surface. Yokoshima cedars are noted for their longevity and their dense, rot-resistant wood. The wood contains high levels of resin, which gives it a distinctive fragrance and makes it durable and valuable. For centuries, the wood was harvested for construction and for religious purposes, used in temples and shrines. But the most ancient and remote trees, like Jomonsugi, were spared because of their inaccessibility. Jomonsugi is named for the Jomon period of Japanese prehistory, spanning from about 14,000 to 300 BCE. The name implies that the tree is at least that old, though determining its exact age is difficult. The tree is hollow, and the oldest wood in the center has decayed, making traditional ring counting impossible. Estimates are based on measurements of growth rates and comparisons with other ancient trees, but the uncertainty is large. The tree is massive, with a trunk circumference of over 52 feet at its base. The bark is deeply furrowed and covered with moss and lichen. The crown is irregular, with dead and broken branches as well as living ones. The tree has survived typhoons, lightning strikes, heavy snow, and centuries of slow growth in nutrient-poor soil. Reaching Jomonsugi requires a strenuous hike of approximately 12 miles round trip, much of it along old logging railways and steep mountain trails. The trail passes through forests at various stages of growth, from younger secondary forests to ancient groves, where trees several hundred years old are common. Near Jomonsugi, a viewing platform has been constructed to allow visitors to see the tree without compacting the soil around its roots or damaging the bark. Yokoshima's forests are sacred in Japanese culture. The island is associated with Shinto beliefs about nature and spirits, and the ancient trees are seen as embodiments of natural power and continuity. The forests inspired Hayao Miyazaki's animated film Princess Mononoke, which depicts a primeval forest inhabited by spirits and ancient creatures. The film captures the sense of age and mystery that pervades Yokoshima's groves, the feeling of being in a place where human time is irrelevant, where the trees measure time in centuries. From Japan, we return to North America, to the Pacific Northwest, to the temperate rainforests of the Olympic Peninsula in Washington state. These forests are not as tall as the redwood forests, but they are among the wettest and most biomass-dense forests on Earth. Places where every surface is covered with moss, where ferns grow shoulder-high, where fallen trees nurse new generations of seedlings in long, straight lines called nurse logs. The Olympic Peninsula receives over 150 inches of rain per year in some areas, and the rain supports forests dominated by Sitka spruce, western hemlock, Douglas fir, and western red cedar. The trees grow tall and thick, and the understory is lush with vegetation. Mosses hang from branches in thick curtains. Ferns cover the ground and grow on tree trunks and fallen logs. Lichens drape from branches like beards. Walking through these forests is an experience of green in all its variations. There are dozens of shades, from the bright yellow-green of new moss growth to the deep blue-green of old hemlock needles, to the pale grey-green of lichens. The light is filtered through multiple layers of canopy, soft and diffuse. The air is cool and humid, smelling of earth and decay and growing things. The forests are productive. The combination of abundant water, moderate temperatures, and a long growing season allows for high rates of photosynthesis and biomass accumulation. The standing biomass, the total weight of living and dead plant material per acre, is among the highest of any forest type, rivaling even tropical rainforests. Fallen logs are enormous, several feet in diameter and dozens of yards long, and they decay slowly over decades or centuries, providing habitat and nutrients all the while. The Olympic rainforests are home to Roosevelt elk, black bears, mountain lions, and a variety of birds including spotted owls and marbled murrelets. The streams are spawning grounds for salmon, which migrate from the ocean up into the mountains to lay eggs and die. The salmon bring marine nutrients into the forest, and their carcasses are eaten by bears and eagles and scavengers, distributing ocean-derived nitrogen and phosphorus into the forest ecosystem, enriching the soil and feeding the trees. The forests of the Olympic Peninsula are protected within Olympic National Park, designated in 1938. Before protection, logging was extensive, and vast areas of old-growth forest were clear-cut. What remains is a fraction of the original extent, but it is enough to preserve the ecosystem, to allow the forests to function, to provide habitat for species that depend on old growth. Standing in the Hoh Rainforest or the Quinault Rainforest, two of the most visited areas of the park, you are enveloped in silence broken only by the drip of water from leaves, the call of a bird, the occasional crack of a branch. The silence is not empty, but full, a silence of living things growing and breathing and cycling nutrients, a silence that comes from being surrounded by so much life that individual sounds are absorbed and integrated into a larger, quieter whole. From the temperate rainforests of North America, we travel to Africa, to the mountains of southwestern Uganda, to a forest that has earned its name through the density of its vegetation. This is Bwindi Impenetrable Forest, a montane and lowland tropical forest that is home to approximately half of the world's remaining mountain gorillas. Bwindi is ancient, having persisted through ice ages when much of Africa was drier and forests retreated to small refuges in the mountains. Bwindi was one of these refuges, and as a result, it has high levels of endemism, species that evolved in isolation here and are found nowhere else. The forest contains over 160 species of trees, over 100 species of ferns, and numerous species of birds, butterflies, and other organisms. The forest is dense and steep. The terrain is rugged, with hills and valleys and fast-flowing streams. The vegetation is multilayered, with a canopy of tall trees, a subcanopy of smaller trees and tree ferns, an understory of shrubs and saplings, and a ground layer of herbs and ferns. Movement through the forest requires cutting trails, and even established trails become overgrown quickly. The name Impenetrable is not an exaggeration. The mountain gorillas of Bwindi live in family groups, each led by a dominant male, a silverback, so named for the patch of silver-grey hair that develops on the back of mature males. The gorillas are herbivorous, eating leaves, stems, bark, and fruit. They move through the forest slowly, foraging, resting, grooming. They build nests each night, simple platforms of bent branches, and leaves where they sleep. Gorilla trekking in Bwindi is carefully managed. Only a limited number of permits are issued each day, and groups are restricted to 8 people, who spend 1 hour with the gorillas after locating them. The restrictions minimize stress on the gorillas and reduce the risk of disease transmission. Human respiratory diseases can be fatal to gorillas, which have limited immunity to common human pathogens. Tracking gorillas involves hiking through the forest, often for several hours, following trackers who locate the gorillas based on their nests from the previous night and on signs of recent feeding. The forest is challenging terrain, steep and slippery, with thick vegetation. But when you find the gorillas, the experience is profound. The animals are enormous, males weighing over 400 pounds, yet they move with surprising gentleness and precision through the vegetation. They largely ignore human observers, continuing their activities, the infants playing, the adults feeding or resting. The gorillas are critically endangered. Poaching, habitat loss, and disease have reduced their numbers to approximately 1,000 individuals. Conservation efforts have stabilized the population and even allowed for slight increases, but the species remains vulnerable. Bwindi is essential to their survival, a protected area where gorillas can live without immediate threat from hunting or habitat destruction. Bwindi is also home to other primates, including chimpanzees, black and white colobus monkeys, and Lewis monkeys. It is a haven for birds, with species like the African green broadbill and the Shelley's crimsonwing found in the forest. The forest is a reservoir of biodiversity, a complex ecosystem that has persisted for tens of thousands of years, adapting to climate changes, surviving disturbances, continuing to function as a living system. From Uganda, we travel south and west to India, to the Western Ghats, a mountain range running parallel to the western coast of the Indian subcontinent. The Western Ghats are older than the Himalayas, a remnant of the supercontinent Gondwana, and they have been a stable landmass for over 150 million years. This stability has allowed for the evolution of unique species and for the persistence of ancient lineages. The Western Ghats are a biodiversity hotspot, one of the most biodiverse regions on Earth. The mountains intercept monsoon rains from the Arabian Sea, creating a gradient from wet tropical forests on the western slopes to drier forests and savannas on the eastern rain shadow side. The forests contain over 5,000 species of flowering plants, nearly 2,000 of which are endemic. There are over 500 species of birds, over 200 species of reptiles, and over 100 species of amphibians, many found only in these mountains. The forests of the Western Ghats are varied, including tropical evergreen forests, tropical deciduous forests, montane forests, and grasslands. The evergreen forests are the most biodiverse, dense, and multilayered, with trees reaching heights of over 150 feet. These forests are home to elephants, tigers, leopards, and the endangered lion-tailed macaque, a primate with a distinctive mane of grey hair around its face. The Western Ghats are also important for their role in water supply. The rivers that originate in the Ghats provide water for millions of people, flowing east across the Deccan Plateau and west to the coast. The forests regulate water flow, absorbing rainfall and releasing it gradually, reducing flooding and maintaining flow during dry seasons. The region faces significant threats from agriculture, logging, and development. Coffee and tea plantations occupy large areas of former forest. Roads and dams fragment the landscape. Invasive species, particularly lantana and various types of wattle, spread through disturbed areas, outcompeting native plants. Conservation efforts focus on protecting remaining forest fragments, creating corridors to connect isolated areas, and promoting sustainable land use practices. Walking through a forest in the Western Ghats, particularly during the monsoon when the vegetation is lush and rain falls daily, you are immersed in life. Leeches drop from leaves and latch onto your boots. Frogs call from every puddle and stream. Birds flit through the understory, difficult to see in the dense vegetation but audible, their calls echoing through the forest. The air is thick with moisture, and mist clings to the hilltops. From India, we cross the Arabian Sea and the Atlantic Ocean to South America, to the Amazon Basin, the largest tropical rainforest on Earth, covering over 2 million square miles, spanning 9 countries, containing approximately 10% of all species on the planet. The Amazon is not a single forest but a mosaic of forest types, from flooded forests that stand in water for part of the year to terra firme forests on higher ground to white sand forests growing on nutrient-poor soils. The Amazon forest is defined by its canopy. The trees create multiple layers, with emergent trees reaching heights of over 200 feet, their crowns exposed to full sunlight. Below the emergence is the main canopy, a dense layer of interlocking crowns at heights of 60 to 100 feet. This canopy is so dense that little light penetrates to the forest floor, which is relatively open and easy to walk through, contrary to popular images of impenetrable jungle. The canopy is where most of the biodiversity resides. It is estimated that over half of all species in the Amazon live in the canopy, many of them never descending to the ground. These include epiphytes, plants like orchids and bromeliads that grow on tree branches, obtaining water from rain and nutrients from decomposing organic matter. They include monkeys, sloths, birds, insects, and amphibians adapted to life in the treetops. Accessing the canopy requires special techniques. Canopy walkways and towers have been constructed in some areas, allowing researchers and visitors to walk or climb into the canopy. Rope techniques allow climbers to ascend into the crowns of emergent trees. These methods reveal a world hidden from the ground, a three-dimensional landscape of branches and vines and leaves, teeming with life. The Amazon River itself is a defining feature of the ecosystem. The river is fed by over 1,000 tributaries, some of them among the largest rivers in the world in their own right. The river transports enormous quantities of sediment from the Andes, nutrients that fertilize the floodplain forests and the estuaries where the river meets the Atlantic. The annual flood pulse, the rise and fall of water levels, structures the ecosystem, determining where species can live, when they reproduce, how they interact. The Amazon is often described as the lungs of the earth, producing 20% of the world's oxygen. This is misleading. The forest produces oxygen through photosynthesis, but it also consumes oxygen through respiration, and the net oxygen production is near zero. What the Amazon does provide is climate regulation. The trees transpire enormous quantities of water, which rises into the atmosphere and forms clouds, creating rainfall not just in the Amazon, but downwind in other parts of South America. The forest stores carbon, approximately 150 to 200 billion tons, equivalent to decades of global carbon emissions. The Amazon is under threat from deforestation, driven by logging, agriculture, ranching, and mining. Large areas have been converted to soy fields and cattle pastures. Roads penetrate deep into the forest, fragmenting it and providing access for further exploitation. Climate change is altering rainfall patterns, and droughts are becoming more frequent and severe. There is concern that the forest could reach a tipping point where it transitions from rainforest to savanna, a transformation that would have catastrophic consequences for global climate and biodiversity. Standing in the Amazon forest, whether on the ground or in the canopy, you are aware of being in the presence of overwhelming complexity. The number of species is incomprehensible. A single tree may host hundreds of insect species. A single acre may contain over 200 species of trees. The interactions, the food webs, the symbioses, the competition and cooperation, all function simultaneously, creating an ecosystem that has persisted for millions of years, adapting and evolving, maintaining itself through countless cycles of growth and decay. From the Amazon, we return to Africa, to the shores of Lake Tanganyika in Tanzania, to the Mahale Mountains, a remote range of forested peaks rising directly from the lake. The Mahale Mountains are home to one of the largest remaining populations of wild chimpanzees, our closest living relatives. The forests of Mahale are a mix of lowland and montane types, with bamboo forests at higher elevations and miombo woodland in drier areas. The chimpanzees range throughout these forests, moving in fluid groups, foraging for fruit, leaves, insects, and occasionally hunting smaller monkeys. The chimpanzees of Mahale are habituated to human presence, the result of decades of research and careful, gradual introduction to observers. Tracking chimpanzees in Mahale involves hiking through steep, dense forest, following guides who know the ranging patterns of the different chimpanzee communities. The terrain is challenging, the heat and humidity oppressive. But when you find the chimpanzees, the reward is extraordinary. You watch as they feed, groom, play, communicate with vocalizations and gestures. You see behaviors that are recognizably intelligent, social, emotional. You are reminded of the narrow evolutionary distance between humans and chimpanzees, separated by only about 6 million years, a blink in evolutionary time. The Mahale Mountains are accessible only by boat, a journey of several hours across Lake Tanganyika from the nearest town. This remoteness has protected the forest and the chimpanzees from many of the threats that affect chimpanzee populations elsewhere. There is no logging, no agriculture, no hunting. The area is protected as Mahale Mountains National Park, and the only human presence is researchers and a small number of tourists. Lake Tanganyika itself is remarkable, the second deepest lake in the world, over 4,000 feet deep, and the longest freshwater lake, stretching over 400 miles. The lake is ancient, approximately 10 million years old, and it contains hundreds of endemic fish species, particularly cichlids, which have evolved into a stunning diversity of forms and colors. From Mahale, we travel northwest to Uganda again, to another mountain range, the Rwenzori Mountains, also known as the Mountains of the Moon. The Rwenzoris are a non-volcanic mountain range, uplifted by tectonic forces, composed of ancient crystalline rocks. They straddle the border between Uganda and the Democratic Republic of Congo, and rise to heights of over 16,000 feet. The Rwenzori Mountains are draped in cloud forest, perpetually wet from moisture lifted by the mountains from the surrounding lowlands. The forests are dense and mossy, similar to the temperate rainforests of the Pacific Northwest, but in a tropical setting. Giant heathers, plants that grow as small shrubs elsewhere, reach heights of over 30 feet in the Rwenzoris, their trunks and branches covered with thick cushions of moss. At higher elevations, the vegetation becomes increasingly strange. Above the cloud forest is the Afro-Alpine zone, a landscape of giant groundsels and giant lobelias, plants that have evolved to tolerate freezing nights and intense solar radiation during the day. The giant groundsels, Dendrosenecio species, look like something from a science fiction film, with thick, columnar trunks topped with rosettes of large leaves. They can grow over 20 feet tall, and they close their leaves around the growing tip at night, protecting it from freezing. The climate in the Afro-Alpine zone is extreme. Temperatures drop below freezing every night, then rise above freezing during the day. This daily freeze-thaw cycle is unusual. Most alpine environments have seasonal freeze-thaw. The plants have adapted with strategies that include thick insulating layers, the ability to supercool water in their tissues without freezing, and antifreeze compounds. The Rwenzoris are difficult to access and to climb. The trails are steep and often muddy, the weather unpredictable, with rain and fog common. Summiting the highest peaks requires technical climbing skills and tolerance for altitude. But for those who make the journey, the landscapes are unlike anywhere else, a combination of familiar temperate forest elements and bizarre tropical adaptations, creating ecosystems that feel alien. From Africa, we travel to South America again, to Chile, to the Andes, to forests dominated by a tree with a distinctive appearance and a history stretching back to the age of dinosaurs. This is the monkey puzzle tree, Araucaria araucana, a conifer with stiff, sharp, triangular leaves that spiral densely around the branches, giving the tree its common name. The leaves are said to be so dense and sharp that even a monkey would be puzzled trying to climb the tree. Araucaria forests, also called Paywen forests, grow in the Andes of central Chile and adjacent Argentina, in areas with volcanic soils and heavy winter snowfall. The trees can reach heights of over 130 feet and live for over 1,000 years. The trunks are straight and columnar, and the branches are arranged in whorls, giving the tree a distinctive, symmetrical appearance. The trees are dioecious, with male and female trees producing separate cones. The female cones are large, up to 8 inches in diameter, and they contain large, edible seeds called pinones. These seeds are an important food source for indigenous Mapuche people, who have harvested and consumed them for centuries. The seeds are nutritious, high in carbohydrates and protein, and they can be roasted, boiled, or ground into flour. Araucaria forests are fire-adapted. The thick bark protects the trees from low-intensity fires, and the forests historically experienced frequent fires that cleared the understory and opened space for regeneration. Fire suppression has altered the forest structure, allowing a buildup of fuel and the growth of shade-tolerant species that compete with Araucaria seedlings. The forests are also threatened by logging and conversion to plantations of faster-growing exotic species. Araucaria wood is valuable, straight-grained and durable, and the trees were heavily logged in the 20th century. Conservation efforts have reduced logging, and the species is now protected in both Chile and Argentina, but the forests are fragmented and many populations are small and isolated. Walking through an Araucaria forest is an experience of geological time. The trees are relics from the Mesozoic, members of a family that was widespread when dinosaurs roamed the earth. Their stiff, armored appearance, their symmetry, their sheer size, all contribute to a sense of age and endurance. The forests are quiet, the understory open, the ground covered with a thick layer of fallen leaves that decay slowly in the cool mountain climate. We complete our journey through primeval forests and hidden biomes on an island in the Indian Ocean, a place that has been isolated for so long that it has evolved its own flora and fauna, much of it found nowhere else. This is Socotra, an island belonging to Yemen, located off the Horn of Africa, approximately 240 miles from the mainland. Socotra's isolation, combined with its arid climate and rugged terrain, has resulted in an extraordinary level of endemism. Approximately 1/3 of the plant species on Socotra are endemic, found nowhere else on Earth. Among the most iconic is the dragon blood tree, Dracaena cinnabari, a tree with a distinctive umbrella-shaped crown and thick, succulent branches. The dragon blood tree is named for its red sap, which oozes from cuts in the bark. The sap was historically valued as a dye and a medicine, traded across the ancient world. The sap hardens into a resin that was used in varnishes, incense, and traditional remedies. The trees grow in the highlands of Socotra, in areas with sparse vegetation and rocky soil. The umbrella shape of the crown is an adaptation to the arid climate. The dense canopy of leaves shades the ground beneath, reducing evaporation and creating a microclimate that allows seedlings to establish. Rain that falls on the canopy drips to the ground at the edges, concentrating moisture in a ring around the tree, where roots can access it. Dragon blood trees grow slowly and can live for hundreds of years, possibly longer. They do not have growth rings, making it difficult to determine their age precisely. The trees are vulnerable to climate change and overgrazing by goats and other livestock introduced to the island. Regeneration is poor in many areas, with few seedlings surviving to maturity. Socotra's forests, which also include species like the cucumber tree, Dendrocysio socotranus, the only tree in the cucumber family, are remnants of a time when the island had more vegetation and a less harsh climate. As the climate has become drier, the forests have retreated to the most favorable areas, leaving behind a landscape that is largely barren but punctuated by these strange, ancient trees. Standing among dragon blood trees on a hillside in Socotra, you are in one of the most unusual landscapes on Earth. The trees look like they belong on another planet, their shapes defying the typical tree form. The sky is often clear and intensely blue, the sun bright and hot. The wind blows constantly, carrying the smell of the sea. It is a landscape of isolation and adaptation, of species that have evolved in separation from the rest of the world, creating forms and strategies that are unique, that exist only here, on this dry island in the middle of the ocean. As we close this segment on primeval forests and hidden biomes, we have journeyed from the tallest trees on Earth to forests draped in moss, from mountain gorillas in impenetrable thickets to dragon blood trees on isolated islands. Forests are systems of astonishing complexity, products of millions of years of evolution and interaction, shaped by climate and soil and fire, and the organisms that live within them. They are not static but dynamic, constantly growing, changing, adapting, yet maintaining a continuity that spans centuries and millennia. Let the forest settle into your imagination, not as a single image, but as a layered, breathing entity, roots extending down into darkness, leaves reaching up into light, everything between cycling nutrients and energy, supporting life at every scale from microbes to megafauna. Let the forest breathe with you, its slow exhalations of oxygen, its patient growth, its quiet endurance. Rest now among the trees. They ask nothing of you. They simply grow, adding another ring, another leaf, another day to their long existence. The forests have stood through storms and droughts and fires, through ice ages and warm periods, through the evolution and extinction of countless species. They will stand through this night, sleep beneath their canopy, real or imagined, knowing that the forests continue their work, silently, patiently, offering shelter and oxygen and beauty to any who come seeking it. Isolation creates uniqueness. When a landscape is separated from others by distance, by barriers of ocean or desert or mountain, the organisms that live there evolve in their own direction, following paths dictated by local conditions rather than by exchange with outside populations. Islands are the most obvious examples, pieces of land surrounded by water, but isolation can occur in other ways. A plateau can be isolated by cliffs. A desert can be isolated by its aridity. A forest can be isolated by the inhospitable terrain that surrounds it. These isolated places become sanctuaries, refuges where species persist that have vanished elsewhere, where ecosystems function without the pressures of human development, where the landscape retains a character that has been lost in more accessible regions. They are often fragile, their isolation having protected them, but also made them vulnerable, their species adapted to narrow conditions, unable to survive if those conditions change. In this segment, we turn our attention to landscapes that are isolated by geography, by climate, by sheer remoteness, places that exist apart from the familiar world, that have developed their own character, their own beauty, their own way of being. We begin in southern China, in the Hunan province, where sandstone pillars rise from mist-shrouded valleys, creating a landscape that seems more imagined than real. Zhangjiajie National Forest Park is part of the Wulingyuan Scenic Area, a region of quartzite sandstone formations that have been eroded into over 3,000 vertical pillars, some rising more than 600 feet from the valley floor. The pillars are narrow and steep-sided, their tops often forested, their cliffs sheer and in places overhanging. They create a landscape of vertical complexity, a forest of stone reaching toward the sky. The sandstone is approximately 300 million years old, deposited in an ancient sea and later uplifted by tectonic forces. Erosion has carved the rock, following joints and fractures, isolating blocks into individual pillars. Water is the primary sculptor, seeping into cracks, freezing and expanding, dissolving minerals, slowly breaking the rock apart. The process continues, and the pillars are still being shaped, still changing, though at rates imperceptible in human time. The valleys between the pillars are forested with subtropical vegetation, humid and often filled with mist. Streams flow through the valleys, tumbling over rocks, creating small waterfalls. The mist is persistent, rising from the valleys in the morning, filling the spaces between pillars, obscuring the tops, creating a sense of depth and mystery. The pillars emerge from the mist like islands from a sea, their forms softened and made ethereal by the moisture in the air. Walking through Zhangjiajie, whether on valley trails or on the elevated walkways that have been constructed among the pillars, is an experience of constant visual surprise. The pillars are so numerous and so varied that each turn reveals a new composition, a new arrangement of vertical forms. Some pillars stand alone, isolated monoliths. Others cluster in groups, their sides nearly touching. Still others lean at angles, supported by neighbors, creating natural arches and bridges. The area has been developed for tourism, with cable cars, glass walkways, and viewpoints constructed to allow access. The development has brought crowds, particularly during holidays, but it has also raised awareness of the landscape's value and has funded conservation efforts. The park is a UNESCO World Heritage Site, recognized for its geological and ecological significance. Zhangjiajie served as inspiration for the floating mountains in the film Avatar, and the park has embraced this association, even renaming one of the pillars Avatar Hallelujah Mountain. The comparison is apartment. The landscape does seem to defy gravity, the pillars too tall and too narrow to be stable, the forests on their tops too isolated to be sustainable. And yet they stand, they endure, they support life, a landscape created by erosion, but sustained by its own geometry, and by the persistent growth of vegetation that binds the soil and slows the processes of decay. From the stone forest of China, we travel to Madagascar, to the western coast, to a landscape of limestone pinnacles, so sharp and so densely packed that they create a terrain that is nearly impassable on foot. This is the Tsingy de Bemaraha, the name derived from the Malagasy word meaning where one cannot walk barefoot. The Tsingy is a karst landscape, formed from limestone that was deposited on an ancient seabed approximately 200 million years ago. The limestone was uplifted, fractured by tectonic forces, and then subjected to millions of years of dissolution by rainwater. Rainwater is naturally slightly acidic, containing dissolved carbon dioxide from the atmosphere. This weak acid dissolves limestone, enlarging cracks and creating channels. In the Tsingy, the dissolution has been extreme. The surface is carved into an array of sharp, vertical blades of limestone, ranging in height from a few feet to over 300 feet. The blades are separated by deep fissures, some only inches wide, others wide enough to walk through, but requiring careful navigation. The edges of the blades are razor sharp, capable of cutting skin or shredding clothing. Beneath the surface, the dissolution has created an extensive cave system, with underground rivers and chambers that drain the landscape. The caves provide habitat for bats, fish adapted to cave life, and various invertebrates. Some of the caves are accessible, but many remain unexplored, hidden beneath the labyrinth of stone above. The Tsingy is divided into two main areas, the Grand Tsingy and the Petit Tsingy. The Grand Tsingy is the more dramatic, with taller and denser formations. Access requires via ferroter equipment, metal cables and ladders bolted to the rock, allowing climbers to traverse the formation safely. The Petit Tsingy is lower and somewhat more accessible, though still challenging terrain. Despite the harshness of the environment, life persists in the Tsingy. Baobab trees grow in the soil pockets between blades, their roots finding cracks in the limestone. Lemurs navigate the formations, leaping between blades with extraordinary agility. Birds nest in the cavities and ledges. The isolation of the Tsingy has resulted in endemic species, organisms found nowhere else, adapted to this specific, difficult landscape. The Tsingy de Bemaraha is a UNESCO World Heritage Site and a national park, protected from development and hunting. But the landscape itself provides a degree of protection. The difficulty of access has prevented human settlement and large-scale exploitation. The Tsingy remains largely wild, a stone forest that is inhospitable yet vibrant, a landscape where geology and biology intersect in unexpected ways. From stone forests, we turn to landscapes defined not by rock, but by sand, and not by permanence but by movement. We travel to northeastern Brazil, to the state of Maranhão, to a region called Lençóis Maranhenses, which translates to bedsheets of Maranhão, named for the appearance of the landscape, white sand dunes that undulate like fabric draped across the land. Lençóis Maranhenses is a desert of sand dunes covering approximately 600 square miles, but it is not a typical desert. The region receives substantial rainfall, approximately 60 inches per year, concentrated in the first half of the year. This rain fills the valleys between the dunes, creating thousands of temporary lagoons that persist for several months before evaporating as the dry season progresses. The lagoons vary in size, from small pools a few yards across to larger lakes covering several acres. The water is remarkably clear, filtered by the sand, and it takes on shades of blue and green, depending on depth and the angle of sunlight. The contrast between the white sand and the blue water is striking, creating a landscape that seems paradoxical, a desert filled with lakes. The sand itself is white because it is composed primarily of quartz, washed down from the interior of Brazil by rivers and deposited along the coast by ocean currents. The sand is then blown inland by wind, forming dunes that can reach heights of over 100 feet. The dunes are mobile, shifting with the wind, changing shape and position over months and years. Life in Lençóis Maranhenses is adapted to the cyclical nature of the lagoons. Fish appear in the lagoons during the rainy season, though it is unclear how they arrive. Some may swim up from rivers during floods. Others may survive as eggs in the damp sand, hatching when water returns. Migratory birds visit the lagoons, feeding on the fish and on aquatic invertebrates. Vegetation is sparse, limited to a few hardy grasses and shrubs that can tolerate the poor soil and the shifting sand. Visiting Lençóis Maranhenses involves walking across the dunes, climbing up the steep faces, and sliding or running down the slip faces on the other side. The sand is hot during the day, and the landscape is disorienting, with no landmarks except the dunes themselves, all similar in form, stretching in every direction. Navigation requires attention or a guide. But the lagoons provide relief, cool water in which you can swim, surrounded by white sand and blue sky, an experience that feels surreal, like swimming in a mirage. The park is protected as a national park, and access is regulated to minimize impact on the fragile ecosystem. The local economy benefits from tourism, with guides and small hotels in nearby towns providing services. The landscape is increasingly known, featured in travel magazines and documentaries, but it retains a sense of remoteness, a feeling of being disconnected from the familiar world. From the white sands of Brazil, we travel to southern Africa, to Namibia, to the Namib Desert, one of the oldest deserts on Earth, and to a region within it called Sossusvlei, a clay pan surrounded by some of the tallest sand dunes in the world. The dunes of Sossusvlei are massive, rising over 1,000 feet from base to crest, their slopes smooth and sculpted by wind into flowing curves. The sand is rich in iron oxide, giving the dunes shades of orange, red, and pink, colors that change with the angle of sunlight, deepening to burnt orange and crimson at sunrise and sunset. Sossusvlei is a clay pan, a flat area where a river, the Tsochub River, once flowed but now reaches only during rare floods. The pan is white, crusted with salt and dried clay. Dead acacia trees stand in the pan, their wood blackened by the sun, their branches bare. The trees died hundreds of years ago when the river's course changed and the groundwater table dropped, leaving them stranded in the dry pan. The wood is so dry and the climate so arid that the trees have not decayed. They stand like sculptures, stark against the white pan and the red dunes. The contrast of colors at Sossusvlei is extraordinary. The white pan, the black trees, the red dunes, the deep blue sky, all combining compositions that seem designed rather than natural. Photographers come from around the world to capture the landscape, particularly at dawn when the light is warm and the shadows long. Climbing the dunes is strenuous. The sand is loose and deep, and for every 2 steps up, you slide 1 step back. But from the crest, the view is expansive. You look out over a sea of dunes, ridge after ridge extending to the horizon, their crests sharp and their slopes smooth. The silence is profound. There is no vegetation to rustle, no water to flow, no animals to call. Only the occasional whisper of wind and the soft sound of sand grains shifting. Despite the apparent lifelessness, the Namib Desert supports a variety of organisms adapted to extreme aridity. Beetles collect moisture from fog that rolls in from the Atlantic Ocean, positioning themselves on dune crests with their bodies tilted so that condensation runs down into their mouths. Sidewinder adders bury themselves in the sand, leaving only their eyes exposed, waiting for lizards or insects to pass. Ostriches and oryx cross the dunes, able to travel long distances without water, obtaining moisture from the plants they eat. Sossusvlei is part of the Namib Norkluft National Park, one of the largest conservation areas in Africa. The park protects the dunes, the gravel plains, the mountains, and the diverse ecosystems they contain. Access is controlled, with gates limiting entry to daylight hours, ensuring that the fragile environment is not degraded by unlimited visitation. From the red dunes of Namibia, we travel west across the Atlantic to South America again, to Bolivia, to the Altiplano, the high plateau of the Andes, where the world's largest salt flat stretches across 4,200 square miles. This is the Sala de Uyuni, a landscape of blinding white salt crust that extends to the horizon in all directions. The Sala de Uyuni is the remnant of a prehistoric lake, Lago Minchin, which dried up thousands of years ago, leaving behind a thick layer of salt. The salt crust is several feet thick in most areas, and beneath it is a brine that contains high concentrations of lithium, one of the largest lithium reserves in the world. The surface of the Sala is almost perfectly flat, one of the flattest places on Earth, with elevation variations of less than 3 feet across the entire expanse. This flatness makes it useful for calibrating satellite altimeters and for other scientific purposes. It also creates unique optical effects. On a clear day, with the white surface reflecting the blue sky, the horizon can disappear, and you lose the ability to judge distance or size. During the rainy season, which runs from December to April, a thin layer of water covers parts of the Sala, transforming it into the world's largest mirror. The water is only inches deep, but it is calm and still, perfectly reflecting the sky and the clouds. The effect is disorienting and beautiful, as though you are walking on the sky, with clouds above and below, the boundary between earth and air erased. The Sala is not lifeless. Flamingos visit, feeding on algae and brine shrimp that live in shallow lagoons at the edges. Islands of rock protrude from the salt, remnants of ancient volcanic cones, and these islands support giant cacti, some over 30 feet tall, relics from a time when the climate was wetter. Crossing the Sala de Uyuni is an experience of scale and emptiness. The landscape is featureless, offering no reference points, no sense of progress. Distances are deceptive. What appears close may be miles away. The light is intense, the sun reflecting off the white salt, requiring eye protection to prevent snow blindness. The Sala is increasingly developed for tourism, with hotels built entirely of salt blocks, tours that take visitors onto the flats in four-wheel drive vehicles, and photo opportunities staged with perspective tricks that play with the lack of depth cues. But the Sala remains fundamentally wild, a landscape shaped by evaporation and salt, by geology and climate, by processes indifferent to human presence. From the salt flats of Bolivia, we travel back to Africa, to northern Tanzania, to a lake that is both beautiful and deadly. This is Lake Natron, an alkaline lake fed by springs rich in sodium carbonate, creating water with a pH of 9 to 10.5, highly caustic and hostile to most life. Lake Natron is shallow, rarely more than 10 feet deep, and its area varies with the seasons, expanding during the rainy season and contracting during the dry season. The water is red or pink in many areas, colored by cyanobacteria and algae that thrive in the alkaline conditions. These microorganisms produce pigments that protect them from intense sunlight and that give the lake its distinctive color. The lake is surrounded by mudflats and salt crusts. The landscape is barren, with sparse vegetation and volcanic formations. Mount Langai, the volcano we encountered in an earlier segment, rises to the south, its slopes dark against the sky, still occasionally erupting nitrocarbonatite lava. Lake Natron is famous for its mummified animals. Birds and bats that crash into the lake's surface, possibly disoriented by the reflective water, are preserved by the alkaline water and encrusted with salt. Their bodies become calcified, turned to stone-like figures, creating eerie sculptures that wash up on the shore. Photographer Nick Brandt documented these calcified animals in a series of images that show them positioned as though alive, standing or perched, frozen in their final moments. Despite the harshness, Lake Natron is a critical breeding ground for lesser flamingos. Approximately 2.5 million flamingos breed at Lake Natron, building nests on salt islands that form during the dry season. The location is ideal for flamingos because the caustic water deters predators. Few animals can tolerate the water, and those that might prey on eggs or chicks cannot reach the nesting islands. The flamingos feed on the cyanobacteria, filtering them from the water with specialized beaks. The pigments in the cyanobacteria give the flamingos their pink color. Without these pigments, flamingos would be white or pale gray. The relationship between the flamingos and the lake is symbiotic, the lake providing food and protection, the flamingos concentrating nutrients and cycling them through the ecosystem. Lake Natron is threatened by development plans, including proposals for a soda ash extraction facility that would alter the lake's chemistry and hydrology. Conservation groups have opposed these plans, arguing that the lake's ecological value, particularly as a flamingo breeding ground, outweighs the economic benefits of extraction. The lake's future remains uncertain, caught between conservation and development pressures. From Lake Natron, we travel west across the continent to South America, to the Atacama Desert in northern Chile, the driest non-polar desert on Earth. Within the Atacama are salt flats, remnants of ancient lakes, where the ground is crusted with salt and the landscape is barren and surreal. The Atacama receives almost no rainfall, with some weather stations recording zero precipitation for years at a time. The aridity is caused by a combination of factors, including the cold Humboldt Current offshore, which cools the air and prevents cloud formation, and the rain shadow of the Andes to the east. The desert has existed in hyperarid conditions for at least 3 million years, possibly much longer. The salt flats of the Atacama, including Sala de Atacama, are similar in formation to Uyuni, but smaller and more fragmented. The flats are surrounded by volcanic peaks, some over 20,000 feet high, snow-capped and stark against the desert sky. The combination of salt, volcano, and desert creates a landscape of extreme contrasts, harsh and beautiful. The Atacama is used as an analogue for Mars. The extreme aridity, the high UV radiation, the soil chemistry, all resemble Martian conditions. Scientists study microorganisms in the Atacama to understand the limits of life and to develop techniques for detecting life on Mars. Some areas of the Atacama are so dry that they appear sterile, with no detectable life in the soil. Despite the aridity, the Atacama blooms. In rare years when rainfall occurs, seeds that have lain dormant in the soil for years or decades germinate simultaneously, covering the desert floor with flowers, primarily purple, pink, and yellow species. The blooms last only a few weeks before the plants set seed and die, returning the landscape to its usual barrenness. But during the bloom, the desert is transformed, a reminder that life persists even in the most extreme conditions, waiting patiently for the rare opportunity to grow and reproduce. From the driest desert, we travel to one of the most remote and inhospitable regions of Iceland, to the Hornstranda Nature Reserve, a peninsula in the far northwest of the island, accessible only by boat and uninhabited year-round. Hornstranda was once home to farming communities, but the harsh climate, the isolation, and the difficulty of making a living in such marginal conditions led to depopulation in the mid-20th century. The last permanent residents left in 1952. The area is now a nature reserve, protected for its wildlife and its rugged beauty. The landscape of Hornstranda is one of steep mountains, deep fjords, and coastal cliffs. The cliffs rise hundreds of feet directly from the sea, providing nesting sites for millions of seabirds, including puffins, guillemots, and razorbills. The birds crowd onto narrow ledges, their calls filling the air, their droppings whitening the rock. Arctic foxes are abundant in Hornstranda, one of the few places in Iceland where they are protected rather than hunted. The foxes prey on seabirds and their eggs, scavenging along the shores and cliffs. They are wary but not terrified of humans, and patient observers can sometimes watch them hunting or playing. The weather in Hornstranda is severe. Storms blow in from the North Atlantic with little warning, bringing high winds, cold rain, and fog. Snow can fall even in summer. The trails are rough and often indistinct, requiring navigation skills and self-sufficiency. There are no roads, no facilities, no rescue services readily available. Hikers who venture into Hornstranda carry all their supplies, camp in tents, and navigate using maps and compasses or GPS. The reward is solitude, landscapes of extraordinary beauty, and wildlife encounters. The reserve is one of the last true wilderness areas in Europe, a place where nature operates without significant human interference. From Iceland, we cross the Atlantic and Pacific to the coast of Western Canada, to an archipelago off the northern coast of British Columbia. These are the islands of Haida Gwaii, formerly known as the Queen Charlotte Islands, a chain of over 150 islands that have been isolated from the mainland for thousands of years. Haida Gwaii was not covered by glaciers during the last ice age, or rather, parts of it remained ice-free, serving as a refuge for plants and animals. This long isolation has resulted in unique subspecies, organisms that evolved separately from their mainland relatives. The islands are home to the Haida people, an indigenous culture with a rich tradition of art, storytelling, and a deep connection to the land and sea. The islands are heavily forested, with Sitka spruce, western red cedar, and western hemlock dominating. Some of the cedars are over 1,000 years old, massive trees with trunks 20 feet in diameter. The Haida used these trees for canoes, longhouses, and totem poles, carving monumental sculptures that remain iconic examples of indigenous art. The forests of Haida Gwaii are temperate rainforests, similar to those on the Olympic Peninsula, but with distinct character shaped by the island's isolation and its maritime climate. The understory is lush with ferns, mosses, and salal. The forest floor is soft, covered with decaying wood and thick moss. The islands are surrounded by nutrient-rich waters, where the Alaska Current meets the California Current, creating upwelling that supports abundant marine life. Salmon, halibut, and herring are plentiful, and whales, orcas, sea lions, and otters are common in the surrounding waters. Haida Gwaii is accessible by ferry or small plane, but the islands retain a sense of remoteness. The population is small, concentrated in a few towns, and large areas are protected as national park reserves or provincial parks. The Haida Nation has significant governance authority over the islands, and conservation is guided by principles that balance ecological protection with cultural use. The islands are sacred to the Haida. Many sites are associated with creation stories, with ancestors, with spirits. The totems, both ancient and modern, stand as markers of cultural continuity, of a people who have lived on these islands for over 10,000 years, adapting to the changing environment, maintaining their traditions even through periods of colonization and cultural disruption. We complete our journey through isolated landscapes on a small island in the Tasman Sea, 600 miles east of Australia. This is Lord Howe Island, a crescent-shaped volcanic remnant surrounded by coral reefs, home to species found nowhere else on Earth. Lord Howe Island is approximately 7 miles long and less than 2 miles wide. It rises from the ocean floor, the peaks of an ancient shield volcano that was active approximately 7 million years ago. The highest point, Mount Gower, rises over 2,800 feet, a steep climb through cloud forest to a summit plateau. The island's isolation and its variety of habitats, from beaches to forests to mountains, have allowed for the evolution of numerous endemic species. The Lord Howe woodhen, a flightless bird, was nearly extinct by the 1970s, reduced to fewer than 30 individuals, but a successful conservation program has increased the population to several hundred. The Lord Howe Island stick insect, one of the rarest insects in the world, was thought to be extinct until 2001, when a small population was discovered on Ball's Pyramid, a steep rock spire 15 miles from Lord Howe. The island is heavily vegetated, with rainforest covering the mountains and palms dominating the lowlands. The Kentia palm, native to Lord Howe, is one of the most popular indoor plants in the world, cultivated for its tolerance of low light and its elegant form. On the island, Kentia palms form dense stands, their fronds arching gracefully overhead. Lord Howe's reefs are the southernmost coral reefs in the world, a mixing zone where tropical and temperate species coexist. The reefs support over 500 species of fish and over 90 species of coral. The water is clear, and the reef is accessible from the shore, allowing snorkeling and diving in conditions that are protected from large-scale tourism. The island has a permanent population of fewer than 400 people, and visitor numbers are capped at 400 at any time to minimize environmental impact. This restriction has preserved the island's character, preventing overdevelopment and maintaining the ecosystems that make Lord Howe unique. Walking on Lord Howe Island, whether along the beaches, through the forests, or climbing the mountains, you are aware of being in a place that is complete in itself, that functions as an integrated whole. The island is small enough to comprehend, to walk across in a day, yet diverse enough to contain multitudes. It is a world in miniature, isolated and self-contained, a sanctuary shaped by distance and by the ocean that surrounds it. As we close this segment on isolated landscapes and natural sanctuaries, we have journeyed from stone forests to salt flats, from alkaline lakes to remote islands, through places defined by their separation from the rest of the world. Isolation creates fragility, but also resilience, vulnerability, but also uniqueness. These landscapes persist because they are difficult to reach, because they offer little in the way of resources that humans value, because their harshness or their distance protects them. Let the sense of isolation settle, not as loneliness but as independence, as the freedom that comes from being apart, from existing without the need for connection or validation from elsewhere. These places are sufficient unto themselves. They do not need us. They function, they endure, they evolve according to their own logic, shaped by forces that operate regardless of human presence. Rest in this isolation, in the knowledge that not everything needs to be accessible, that remoteness has value, that some places are better left alone, visited rarely, respected from a distance. The isolated landscapes will continue whether we see them or not. They have persisted for thousands or millions of years in obscurity. They will persist through this night and through countless nights to come, quiet and separate, complete in their aloneness. Not all wonders announce themselves with grandeur. Some are quiet, revealed only to patient observers, noticed only by those who pause long enough to question what seems ordinary. These are the gentle mysteries, phenomena that occur without fanfare, that leave traces we can observe, but whose mechanisms remained hidden for decades or centuries. Puzzles written in stone and sand and light. Science has explained many of these mysteries, solving riddles that once seemed supernatural or impossible. But the explanations do not diminish the wonder. Knowing how a stone moves across a dry lakebed does not make the tracks it leaves any less extraordinary. Understanding why sand sings does not silence the music. The mysteries persist even after being solved, because the phenomena themselves continue, indifferent to our understanding, following physical laws that were operating long before we arrived to witness them. In this segment, we turn our attention to these subtle wonders, to places where nature performs small miracles that are easy to overlook, where the strange and the beautiful manifest in ways that are gentle rather than dramatic, quiet rather than overwhelming. We begin in one of the hottest and driest places in North America, in Death Valley, California, on a dry lakebed where stones move of their own accord, leaving trails across the cracked mud. Racetrack Playa is a flat, remote dry lakebed in the northern part of Death Valley National Park. The playa is approximately 2.5 miles long and over a mile wide, perfectly flat, covered with a surface of cracked mud tiles that form geometric patterns. Scattered across this surface are rocks, ranging from pebbles to boulders weighing hundreds of pounds. And behind many of these rocks are tracks, long grooves in the mud surface, showing the path the rocks have traveled. The tracks are mysterious because no one ever saw the rocks move. The rocks would be in one position, and months or years later, they would be in a different position, with a fresh track behind them. Some tracks are straight, extending for hundreds of feet. Others are curved or zigzagged. Some rocks moved in parallel, their tracks running side by side. Others moved in opposite directions, despite being close together. For decades, the moving rocks were a scientific puzzle. Theories abounded. Some suggested wind, but the rocks seemed too heavy to be pushed by wind alone. Others proposed ice, magnetic fields, seismic activity, or even pranks by visitors. The mystery persisted because the conditions required for the rocks to move occurred so rarely that no one had witnessed it. The mystery was finally solved in 2014 by a team of scientists who installed time-lapse cameras and GPS trackers on some of the rocks. They observed that the rocks moved during rare winter conditions when the playa floods with a few inches of water. The water freezes overnight into a thin sheet of ice, and then the ice breaks up during the day as it warms. Wind pushes the large, thin sheets of ice, called ice rafts, and the ice sheets push the rocks embedded in them or in contact with them. The rocks glide across the muddy bottom, leaving tracks. The movement is gentle, only a few inches per minute, and it requires a precise combination of conditions: water, freezing temperatures, sunlight to begin melting the ice, and wind. These conditions occur perhaps once every few years, and even then, only certain rocks in certain positions move. Most of the time, the playa is dry, and the rocks sit motionless, their tracks the only evidence of their occasional journeys. Standing on Racetrack Playa, looking at a rock and its track, you are seeing a record of an event you did not witness, evidence of processes that occur in your absence. The playa is silent and still. The rocks do not move today, but they have moved, and they will move again, when conditions align, when ice and wind conspire to set them sliding across the mud. From moving stones, we travel to the forests of northern Minnesota, to Judge C.R. Magny State Park, where the Brule River flows over a series of waterfalls before reaching Lake Superior. At one of these falls, the river splits around a rock outcrop. Half the river drops 50 feet into a pool and continues downstream. The other half flows into a large pothole, a circular opening in the rock, and disappears. This is Devil's Kettle, and the mystery is simple. Where does the water go? The volume of water entering the pothole is substantial, roughly half the flow of the river. It does not emerge at the base of the falls. There is no obvious outlet. The water simply vanishes. For years, people speculated about the water's destination. Some thought it flowed into a deep cavern system, eventually emerging miles away. Others suggested it connected to Lake Superior through underground channels. The mystery was compounded by stories of objects thrown into the kettle, ping-pong balls or dye or logs, that were never seen again. The likely explanation, confirmed by hydrological studies, is less dramatic but satisfying. The water enters the pothole, and flows through a network of fractures and channels in the basalt bedrock. These channels are part of a lava tube system, voids left when molten lava drained away during volcanic eruptions approximately 1 billion years ago. The water travels through these channels and rejoins the main river a short distance downstream, emerging underwater or through multiple small outlets that are difficult to see. The flow measurements support this explanation. The volume of water in the river below the falls is consistent with the combined flow of the visible waterfall and the kettle. The water does not disappear. It simply takes a hidden path, flowing through rock rather than over it. But Devil's Kettle retains its mystery in the sense that the exact path remains unknown. The channels are too narrow and too convoluted to explore directly. The water flows in darkness, through passages carved by lava and enlarged by centuries of erosion, a hidden river within the river, unseen and unseeable. Visiting Devil's Kettle, standing at the observation point and watching half the river vanish into the rock, you are presented with a phenomenon that invites questions, that seems to violate expectations. Rivers flow downhill on the surface. They do not disappear into holes. And yet this one does, and has done so for thousands of years, patiently eroding its hidden channels, carrying water through stone, emerging quietly downstream without announcement. From hidden water, we turn to patterns in the earth, circles that appear in grasslands, and that remained unexplained for decades despite intensive study. We return to Namibia, not to the dunes this time, but to the arid grasslands that stretch inland from the coast, where the ground is marked with millions of circular patches of bare soil, surrounded by rings of taller grass. These are fairy circles, and they occur primarily in Namibia, though similar formations have been identified in Australia. The circles range from about 10 feet to over 60 feet in diameter. They are remarkably regular, spaced evenly across the landscape, creating patterns that are visible from aircraft. The circles persist for decades, the bare patches remaining bare, the surrounding grass growing tall and green during the rainy season. Local folklore attributes the circles to the footprints of gods, or to the breath of an underground dragon, or to the activities of spirits. These explanations reflect the circles' uncanny regularity and their persistence, qualities that suggest intentional creation rather than random natural processes. Scientists proposed numerous theories. Some suggested termites, arguing that the insects create the circles by clearing vegetation from underground nests. Others proposed plant competition, with certain plants releasing toxins that prevent growth in a circular zone around them. Still others suggested that the circles result from patterns of water availability, with water accumulating around the edges of the circles and creating favorable conditions for grass growth while the centers remain too dry. Recent research suggests that multiple factors may be involved, but the most supported explanation involves a combination of water dynamics and plant competition. The circles form because grasses compete for water in the arid environment. When grasses die in a small area, perhaps from drought stress, the bare patch allows rainwater to infiltrate more deeply rather than being absorbed by plant roots. This deeper water is less accessible to new seedlings, preventing recolonization of the bare patch. Meanwhile, the water spreads laterally underground, moving toward the edges of the circle where it supports denser grass growth. The process is self-organizing. The circles create their own patterns through the interaction of water movement and plant growth, a form of spatial patterning similar to Turing patterns, mathematical models of pattern formation in nature. The circles represent a stable configuration, a balance between water availability, plant competition, and environmental conditions. Walking among the fairy circles, you see them stretching across the landscape in all directions, thousands upon thousands of circular patches, each one a small mystery, each one a product of invisible processes occurring beneath the surface. The grass at the edges of each circle is tall and green, while the center is bare, the soil cracked and dry. The pattern repeats endlessly, a rhythm written across the earth, beautiful in its regularity, puzzling in its origin. From patterns in the earth, we turn to sounds from the earth, to beaches and dunes where sand sings when walked upon or when wind blows across it. We travel to Wales, to the Llywelyn Peninsula, to a beach called Whistling Sands or Porth Ower, where the sand produces a distinctive squeaking or whistling sound when you walk on it. Singing sand, also called squeaking sand or barking sand, occurs in a few locations around the world. The phenomenon requires very specific sand properties. The grains must be round and uniform in size, well sorted by wave action or wind. They must be dry. They must be clean, free from dust or salt or organic matter. And they must have the right composition, typically quartz or calcite. When you walk on singing sand, the pressure of your foot causes the sand grains to move and rearrange. As they slide past each other, they vibrate at a specific frequency determined by the size and shape of the grains. The vibrations from millions of grains synchronize, creating an audible sound. The pitch and volume depend on the grain size and the moisture content. Finer sand produces higher-pitched sounds. Larger grains produce lower, rumbling tones. Whistling sands in Wales produces a high-pitched squeak, almost like a dog's toy being compressed. The sound is most pronounced when the sand is very dry and when you walk briskly, scuffing your feet. On humid days or after rain, the sand is silent. The moisture coats the grains and prevents them from vibrating freely. Other singing sands produce different sounds. Some dunes in the Sahara and in the Gobi Desert produce deep, rumbling booms that can be heard for miles, created when large volumes of sand slide down the slip face of the dune during an avalanche. The sound is so loud and so unexpected in the empty desert that it has been described as supernatural, as the singing of spirits or the voice of the desert itself. The mechanism is similar to the Welsh beach, but at a larger scale. The avalanche sets millions of grains in motion simultaneously, and their vibrations synchronize into a resonant frequency that amplifies into a boom. The pitch is typically around 90 Hz, a low frequency that carries well through air and through the ground. Walking on singing sand, listening to the squeak or boom beneath your feet, you are interacting with the sand in a way that reveals its hidden properties. The sound is ephemeral, lasting only as long as the sand is in motion, but it transforms the experience of the landscape, adding an auditory dimension to what is usually a visual or tactile encounter with the earth. From singing sand, we turn to sand that has crystallized into forms that resemble flowers. We return to the Sahara Desert, to regions where groundwater rich in minerals evaporates near the surface, leaving behind formations called desert roses. Desert roses are not plants but minerals, typically gypsum or barite, that have crystallized in a pattern resembling the petals of a rose. They form in sandy soils where groundwater containing dissolved minerals is pulled upward by capillary action and evaporates at the surface. As the water evaporates, the minerals precipitate, forming crystals. Sand grains are incorporated into the growing crystals, giving the formations a rough, sandy texture and a beige or brown color. The crystals grow outward from a central point, forming flat, blade-like structures that overlap and radiate like flower petals. Some desert roses are small, only a few inches across. Others can be over a foot in diameter and weigh several pounds. They are fragile, easily broken, and they accumulate in desert basins where conditions favor their formation. Desert roses are found in many desert regions, but the Sahara produces some of the finest examples. In Tunisia and Algeria, desert roses are collected and sold as souvenirs, though collecting them removes them from the landscape and contributes to the degradation of the formations. The beauty of desert roses lies in their unexpectedness. They are flowers made of stone and sand, crystalline blooms in a landscape where organic flowers are rare and short-lived. They represent the creativity of geological processes, the way minerals can organize themselves into forms that echo the biological world, even though they are entirely inorganic. From mineral flowers, we travel to Iran, to the Mazandaran province, to a series of terraced hot springs that have built travertine formations in shades of red, orange, and yellow. This is Badab-e-Sirte, one of the most colorful travertine terraces in the world. Badab-e-Sirte consists of two springs that emerge from the ground at different elevations. The water is rich in dissolved minerals, particularly iron, calcium carbonate, and various salts. As the water flows over the terraces and evaporates, the minerals precipitate, building up layers of travertine and creating the stepped formations. The colors are extraordinary. The travertine is stained red and orange by iron oxides. Some pools are yellow from sulfur compounds. Others are white or cream from calcium carbonate. The colors shift and intensify with the angle of sunlight, glowing vividly at sunrise and sunset. The terraces are smaller than those at more famous sites like Pamukkale in Turkey or Mammoth Hot Springs in Yellowstone, but they are striking for their color intensity and for their remote location. Badab-e Sirte is not heavily tourist, and the site retains a sense of discovery, of stumbling upon something unexpected in the mountains. The water in the springs is warm, around 100 degrees Fahrenheit, and it has a distinctive smell from the dissolved minerals. The flow is not constant throughout the year, varying with seasonal rainfall and groundwater levels. During dry periods, the terraces dry out, and the minerals form crusts and efflorescence on the surface. Standing at Badab-e Sirte, looking at the colored terraces descending the hillside, you see geology as art, as the slow deposition of minerals creates forms and colors that seem designed for aesthetic effect. The terraces are functional, simply the result of water flowing and minerals precipitating. But the outcome is beautiful, a collaboration between chemistry and gravity that has been occurring for thousands of years. From permanent hot springs, we turn to an ephemeral phenomenon, a trick of light and timing that occurs for only a few evenings each year. We return to Yosemite National Park in California, to a waterfall that, under specific conditions, appears to glow like molten lava. This is Horsedale Fall, and the phenomenon known as the Firefall. Horsedale Fall is a small, seasonal waterfall that flows over the eastern edge of El Capitan, a massive granite cliff in Yosemite Valley. The fall is approximately 1,000 feet tall, but flows only during winter and early spring when snowmelt is sufficient. By late spring and summer, the waterfall dries up completely. In mid to late February, if conditions are right, the setting sun illuminates Horsedale Fall in a way that makes the water glow orange and red, like flowing fire. The effect lasts only a few minutes, requiring clear skies, sufficient water flow, and the sun at exactly the right angle. The sun must be low enough to pass through the valley and strike the waterfall directly, which happens only during a narrow window of dates. The firefall is entirely a lighting effect. There is no fire, no unusual mineral content in the water. It is simply sunlight at a specific wavelength and angle, refracted and reflected by the falling water, creating an appearance of luminosity. But the effect is dramatic, and photographs of the firefall show a ribbon of orange light descending the dark granite cliff, looking like lava flowing over the rock. The phenomenon is named after a different firefall that occurred at Yosemite from the 1870s to 1960s. The earlier firefall was a man-made spectacle where burning embers from a bonfire on Glacier Point were pushed over the cliff at night, creating a cascade of fire. The practice was discontinued in 1968 as inconsistent with national park values, but the name persisted and was applied to the natural light phenomenon at Horsedale Fall. The natural firefall has become a popular event, drawing photographers and visitors who congregate in the valley with tripods and cameras, waiting for the few minutes when the light is perfect. The popularity has created management challenges, with traffic congestion and trampling of vegetation. The Park Service has implemented temporary restrictions during firefall season to protect resources and manage crowds. Seeing the firefall, whether in person or in photographs, is a reminder of how light transforms landscapes, how the same cliff and waterfall can appear ordinary or extraordinary depending on the time of day, the season, the weather. The firefall is not a permanent feature, but a convergence of conditions, a moment when angle and timing and clarity align to create something that seems magical, even though it is entirely explainable. From light on water, we turn to a beach where glass has replaced sand, where decades of human discarded waste have been transformed by the ocean into something beautiful. We return to California, to Fort Bragg, to a beach known simply as Glass Beach. Glass Beach is the result of dumping. From the early 1900s to the 1960s, the area was used as a dump site. Residents threw garbage over the cliffs onto the beach below, including bottles, jars, appliances, and other refuse. The practice was common at the time, before modern waste management and environmental regulations. In the 1960s, the dumping stopped, and cleanup efforts removed most of the large debris. What remained were millions of fragments of broken glass. Over the following decades, the ocean worked on the glass, tumbling the fragments in the waves, grinding them against rocks and sand, smoothing the sharp edges, frosting the surfaces. The result is a beach covered with rounded glass pebbles in every color, green from beer and wine bottles, brown from whiskey and medicine bottles, clear from jars and window glass, blue from cobalt bottles and cosmetics, and rare colors like red, orange, and yellow from specialty glass. The glass pieces range in size from pebbles to larger chunks, and they mix with the natural pebbles and sand on the beach. Glass Beach has become a tourist attraction, visited by people who come to see the colorful glass and to collect pieces as souvenirs, though collecting is officially prohibited within the park boundaries. The glass is slowly disappearing, taken by visitors or further broken down by the ocean, and estimates suggest that within a few decades, the beach will revert to an ordinary pebble beach. The irony of Glass Beach is that it is a place made beautiful by pollution and by time. The glass was waste, carelessly discarded, and the ocean transformed it into something that people now value and visit. It is an example of nature's capacity to process and reclaim human debris, to take what we discard and integrate it into the landscape, though the timescale is measured in decades rather than the years or hours we prefer. Walking on Glass Beach, the glass pebbles clink and rattle under your feet, a sound distinct from ordinary sand or gravel. The colors catch the light, glinting in the sun. The beach is small, and the glass is concentrated in certain areas, creating patches of color against the darker natural rock. It is strange and beautiful and melancholic, a reminder of waste and transformation, of human impact and nature's resilience. From glass on a beach, we return briefly to Singing Sands, this time to a different location and a different context. In Colorado, at Great Sand Dunes National Park, the dunes occasionally sing, producing low rumbling sounds when sand avalanches down the steep slip faces. The phenomenon is similar to the booming dunes of the Sahara, but occurs in a very different environment, in the mountains of Colorado, where the dunes are backed by snow-capped peaks. The painted dunes near the Singing Dunes are colored by volcanic ash and sediments, creating bands of red, orange, and purple in the surrounding landscape. The combination of singing sand and colored dunes creates a multisensory experience, where sight and sound both contribute to the sense of place. The singing occurs unpredictably, dependent on the dryness of the sand, the steepness of the dune, and the volume of sand in motion. Visitors sometimes trigger the sound by running or jumping down the dunes, setting off small avalanches. The sound builds and resonates, a deep thrumming that seems to come from the dune itself, as though the sand is alive and vocalize. We complete our journey through subtle and gentle mysteries in China, in the Gobi Desert near the city of Dunhuang, where a crescent-shaped oasis lake sits at the base of massive sand dunes. This is Crescent Moon Lake, Yuyuan, a body of water that has persisted for thousands of years despite being surrounded by arid desert. Crescent Moon Lake is small, only about 300 feet long, but it is deep, reportedly over 15 feet at its deepest point. The lake is fed by an underground spring, and the water is clear and slightly alkaline. The lake's shape is a perfect crescent, giving it its name and creating a striking visual contrast with the golden dunes that rise over 300 feet above it on three sides. The lake has been a landmark and a resting place for travelers on the ancient Silk Road. The nearby Mogeo Caves, a complex of Buddhist temples and grottos carved into the cliffs, was sustained in part by the water from Crescent Moon Lake. The lake was a miracle in the desert, a source of life and refreshment in an otherwise inhospitable landscape. In recent decades, Crescent Moon Lake began to shrink, the water level dropping dramatically due to agricultural use of groundwater in the region and changes in climate. By the late 1990s, the lake was in danger of disappearing entirely. Conservation efforts, including restrictions on groundwater pumping and artificial replenishment of the aquifer, have stabilized the lake, and the water level has recovered somewhat. The lake is surrounded by pavilions and walkways, developed as a tourist site, but the essential character of the place remains. The water reflects the sky and the surrounding dunes, creating a mirror image that doubles the crescent shape. At sunset, the dunes glow orange and the water turns golden, and the contrast between the solid dunes and the liquid lake, between the transient sand and the persistent water, becomes most apparent. Crescent Moon Lake is a reminder that water persists even in deserts, that springs can flow for millennia, that oases are not mirages but real places where geology and hydrology create conditions for life. The lake is subtle in its wonder, not large or dramatic, but precious for its rarity, for its unlikely persistence, for the way it provides relief and beauty in a landscape of harshness and scarcity. As we close this segment on subtle and gentle natural mysteries, we have journeyed from moving rocks to vanishing water, from circles in grasslands to sand that sings, from mineral roses to a waterfall that glows like fire, from glass beaches to crescent lakes. These phenomena do not demand attention through size or violence. They reveal themselves gradually to those who pause, who question, who allow themselves to be puzzled. The mysteries have explanations, mechanisms that science has uncovered, but the phenomena themselves remain wondrous. Knowing why a rock moves or why sand sings does not reduce the experience of witnessing these things. If anything, understanding deepens appreciation, adding layers of meaning, connecting the visible to the invisible, the effect to the cause. Let these gentle mysteries settle into your thoughts, not as questions demanding answers, but as invitations to notice, to pay attention, to see the world as more complex and more interesting than casual observation reveals. The mysteries are all around, not just in remote deserts or national parks, but in familiar places, in the way light falls, in the way water flows, in the patterns that emerge from simple rules repeated across space and time. Rest now in the knowledge that the world is full of small wonders, that mystery persists even in the age of science, that there is always more to notice if you are willing to look closely, to wait patiently, to let the subtle and gentle phenomena reveal themselves in their own time. The rocks will move again, the sand will sing again, the light will align again, and whether you are there to witness it or not, the mysteries will continue, quiet and persistent, woven into the fabric of the world. We come now to the end of our journey, to places defined not by drama or extremity, but by stillness, by quiet beauty, by the sense of arrival rather than departure. These are landscapes of reflection and calm, places where water mirrors sky, where stone has been worn smooth by millennia of patient erosion, where the world seems to pause and hold its breath. They are destinations in the truest sense, not because they are final, but because they invite you to stop, to rest, to simply be present without the need to move on to the next thing. Stillness is not emptiness. It is fullness made quiet, complexity made calm. A still lake contains as much life as a rushing river, but the life moves slowly, subtly, beneath the mirrored surface. A silent canyon contains as much history as a roaring waterfall, but the history is written in layers of stone rather than announced by sound. These quiet places are repositories of peace, offering respite from the constant motion and noise that characterizes so much of modern existence. We begin our final journey in northern Vietnam, in the Gulf of Tonkin, where thousands of limestone islands and karst formations rise from the emerald green waters. This is Ha Long Bay, which means Descending Dragon Bay, named for the legend that the islands were created by a dragon whose tail carved valleys and crevasses that later filled with water as the creature descended into the sea. Ha Long Bay contains approximately 1,600 islands and islets, most of them uninhabited, composed of limestone that has been sculpted by wind and water into dramatic forms. The islands are small, some only a few hundred feet across, rising vertically from the water to heights of several hundred feet. They are covered with vegetation, trees and vines clinging to the steep slopes, finding purchase in cracks and on ledges. The water between the islands is calm most of the time, sheltered from the open ocean by the outer islands. Traditional wooden boats called junks navigate the bay, their tan sails billowing in the breeze, carrying fishermen and tourists through the maze of islands. The boats move slowly, and the pace of life on the water is unhurried, dictated by tides and wind rather than by schedules. Many of the larger islands contain caves, carved by water when sea levels were lower during ice ages. These caves are vast chambers with stalactites and stalagmites, illuminated now with colored lights for tourists but once dark and mysterious, discovered by fishermen seeking shelter from storms. The caves have names like Surprise Cave and Heavenly Palace Cave, reflecting the wonder of those who first entered them. Ha Long Bay is at its most beautiful in the early morning, when mist rises from the water and softens the outlines of the islands. The islands emerge from the mist like mountains floating in clouds, their reflections wavering in the still water. The scene is quintessentially serene, a landscape that seems designed for contemplation, for quiet observation rather than for active engagement. The bay is a UNESCO World Heritage Site, recognized for its geological value and its natural beauty. It faces challenges from tourism, from pollution, from overfishing. Efforts to manage these pressures are ongoing, balancing the economic benefits of tourism with the need to preserve the ecosystem and the landscape. But despite the pressures, Ha Long Bay retains its essential character, its capacity to induce a sense of calm, to slow time, to create space for reflection. From Vietnam, we travel south and west to Thailand, to another bay filled with limestone karsts rising from tropical waters. This is Phang Ngo Bay, located between the island of Phuket and the mainland, a landscape similar to Ha Long, but with its own distinct character. Phang Ngo Bay is shallower than Ha Long, and at low tide, extensive mudflats are exposed, revealing mangrove forests that fringe the islands and the mainland shore. The mangroves are critical habitat, nurseries for fish and shrimp, roosting sites for birds, buffers against storm surges and erosion. The roots of the mangroves extend into the mud, creating tangled networks that trap sediment and build land. The limestone karsts of Phang Ngo Bay are weathered and undercut at their bases, creating mushroom-shaped islands where the top is wider than the bottom. This undercutting is caused by wave action and by biological erosion, organisms like mollusks and sea urchins that bore into the limestone at the waterline. Over time, the undercutting can cause the upper portions of the karsts to collapse, creating caves and arches. One of the most famous features of Phang Ngo Bay is James Bond Island, a tall, thin karst that appeared in the film The Man with the Golden Gun. The island has become a major tourist attraction, visited by thousands daily during peak season. But the bay contains hundreds of other islands and karsts that are less visited, quieter, accessible only by kayak or long-tail boat. Places where you can paddle through sea caves at high tide and emerge into hidden lagoons called hongs, circular bodies of water surrounded by vertical cliffs, open to the sky but enclosed from the sea. The hongs are magical spaces, secret chambers accessible only through cave passages, illuminated by sunlight filtering down from above, their waters calm and clear. Paddling into a hong feels like discovering a hidden world, a place set apart from the rest of the bay, protected and quiet. Phang Ngo Bay, like Ha Long, is at its best in the early morning or late afternoon when the light is soft and the water is still. The karsts cast reflections that are nearly perfect, doubling the landscape, creating symmetry and balance. The silence is broken only by the dip of paddles, the call of birds, the distant sound of a boat engine. From Southeast Asia, we travel to the Mediterranean, to the island of Sardinia, to the eastern coast, to a stretch of coastline known as the Bonii Coast or the Gulf of Orosei. This is a landscape of limestone cliffs rising directly from the sea, of hidden coves with white sand beaches accessible only by boat, of caves and arches carved by the waves. The Bonii Coast is remote, protected by the difficulty of access. The cliffs are too steep for roads, and the interior is mountainous and sparsely populated. The beaches, including Kola Gullerits, Kola Marialu, and Kola Luna, are small crescents of sand and pebbles backed by cliffs hundreds of feet high. The water is incredibly clear, shading from pale turquoise in the shallows to deep blue in the depths, so transparent that you can see the rocky bottom 30 or 40 feet down. Kola Gullerits is perhaps the most striking, dominated by a tall limestone pinnacle that rises over 400 feet from the beach, a natural monument sculpted by erosion. The pinnacle is a favorite of rock climbers, its smooth limestone offering challenging routes. At the base of the cliffs is a natural arch, an opening carved by the sea, through which you can swim or kayak. The Bonii Coast is quiet because it is difficult to reach. Most visitors arrive by boat from nearby towns, a journey of an hour or more depending on sea conditions. There are no facilities on the beaches, no buildings, no development. You bring what you need and take everything away when you leave. The beaches return to their natural state each evening as the boats depart, empty and pristine under the Mediterranean sun. Swimming in the coves of the Bonii Coast, floating in the clear water with the cliffs rising around you, you are held by the landscape, enclosed by stone and sea, separated from the rest of the world by water and cliff and distance. The experience is one of immersion, of being fully present in a place that demands nothing but attention and gratitude. From Sardinia, we travel east to Greece, to the island of Melos in the Cyclades, to the southwestern coast, to to a series of sea caves and rock formations carved from white volcanic rock. This is Cleftico, which means the hideout, named for pirates who once used the caves as shelter and as a base for raids. Cleftico is accessible only by boat, a collection of towering white rock formations that rise from the sea. Their surface is smooth and sculpted by wind and waves. The rocks are bright white, almost glowing in the sunlight, composed of volcanic tuff and pumice that eroded into fantastic shapes. Arches span between rocks. Caves penetrate deep into the formations, some open to the sky, others dark and mysterious. The water around Cleftico is extraordinarily clear, varying from pale green to deep blue, so transparent that boats appear to float in air rather than water. The seabed is visible, rocky and dotted with seagrass, and fish are easily seen swimming below. Boats anchor in the sheltered areas between the rocks, and visitors swim and snorkel, exploring the caves, diving from the rocks, drifting in the calm water. The scale of the formations is impressive. Some rocks rise over 100 feet, and the arches and caves are large enough to navigate by boat or kayak. Cleftico is most beautiful in the afternoon, when the sun illuminates the white rocks from the west, creating brilliant highlights and deep shadows. The contrast between the white stone, the blue water, and the clear sky is stark and vivid. The scene is almost surreal in its clarity and color saturation, like an overexposed photograph, too bright and too perfect to be real. The quietness of Cleftico comes from its remoteness and from the nature of the space. The rocks enclose and shelter, the water is calm, and the only sounds are natural: the lap of waves against stone, the cry of gulls, the splash of swimmers. It is a place that invites floating and drifting, not purposeful activity, but simple presence in a beautiful place. From Greece, we travel to Japan, to the base of Mount Fuji, to a region of 5 lakes that surround the sacred mountain. These are the Fuji 5 lakes, formed by lava flows from past eruptions that dammed rivers and created basins. The lakes, Kawaguchiko, Saiko, Yamanakoko, Shojiko, and Motosuko, vary in size and character, but all share the view of Mount Fuji rising above them. Mount Fuji is Japan's tallest mountain, and its most iconic symbol, a near-perfect volcanic cone that has inspired artists and poets for centuries. The mountain is sacred in Shinto belief, a place where the physical and spiritual worlds meet. Climbing Fuji is a pilgrimage undertaken by thousands each year during the summer months. The lakes provide the classic foreground for photographs of Fuji. Lake Kawaguchiko, the most accessible and most visited, offers views across the water to the mountain, its symmetrical form reflected in the still surface on calm days. The reflection is particularly striking in early morning before the wind rises and disturbs the water. The area around the lakes is developed, with towns and resorts catering to tourists, but there are quiet corners, places along the shores where you can sit and watch the mountain, where the view is framed by trees or by traditional buildings, where the sense of place, of being in Japan looking at Fuji, is strong and clear. Mount Fuji is often hidden by clouds. The mountain creates its own weather, and clouds gather around the summit, obscuring it from view. Seeing Fuji clearly is considered fortunate, a gift. When the mountain is visible, especially when it is snow-capped and the sky is blue and the reflection is perfect in the lake, the scene embodies a certain ideal of beauty, balance, and harmony, concepts central to Japanese aesthetics. The stillness of the Fuji 5 lakes comes from the mountain itself, which is dormant, silent, unchanging in its form even as seasons pass and light shifts. The mountain anchors the landscape, gives it meaning and focus, and the lakes reflect this permanence, holding the image of the mountain in their depths, offering it back to the sky. From Japan, we travel to one of the most remote inhabited islands on Earth, to Easter Island, Rapa Nui, to the southwestern corner of the island, to a volcanic crater that contains a freshwater lake. This is Reino Kau, one of 3 volcanic craters on the island, the largest and the most visually striking. Reino Kau is approximately 1 mile across and over 1,000 feet deep. The crater is partially breached on the seaward side, where the rim has collapsed, creating a gap through which you can see the ocean far below. The interior of the crater is filled with a lake, and the lake is dotted with small islands of floating vegetation, mats of reeds and sedges that drift across the surface. The crater walls are steep and in places sheer, covered with vegetation where soil has accumulated. The rim of the crater offers sweeping views, on one side looking into the crater and the lake, on the other looking out over the ocean, blue and vast and empty to the horizon. Near the crater is the ceremonial village of Orongo, where the Rapa Nui people held the annual Birdman competition, a ritual that involved descending the cliffs, swimming to a nearby islet, retrieving the first egg of the season from a seabird, and returning. The first person to return with an intact egg became the Birdman for the year, a position of prestige and power. Reino Kau is quiet in the profound way that comes from isolation. Easter Island is over 2,000 miles from the nearest continent, one of the most isolated inhabited places on Earth. The island's remoteness is palpable, felt not just intellectually but viscerally, in the emptiness of the horizon, in the absence of other land, in the wind that blows constantly from the ocean. Standing at the rim of Reino Kau, looking into the crater or out to sea, you are at the edge of the world in a very real sense, on a small island in the middle of the Pacific, surrounded by thousands of miles of water. The stillness is not absence of motion, but presence of vastness, the ocean and sky meeting at a distant curve, the wind and waves continuing their eternal interaction, indifferent to the observer on the crater rim. From the Pacific, we travel back to North America, to Newfoundland, to Gros Morne National Park, to a landscape called the Tablelands, a plateau of exposed mantle rock, stone from deep within the earth brought to the surface by tectonic forces. The tablelands are barren, rust-colored, almost Martian in appearance. The rock is peridotite, formed in the Earth's mantle and thrust up onto the surface when an ancient ocean closed and continents collided. Peridotite is rich in iron and magnesium and toxic to most plants. It weathers to a reddish-brown, and it supports almost no vegetation, creating a landscape of bare rock and sparse gravel. Walking on the tablelands is walking on the mantle, on rock that is normally dozens of miles beneath your feet, on material that forms the bulk of the Earth's interior. The experience is geologically profound, a direct encounter with the deep structure of the planet, with stone that has risen from the depths and now lies exposed under the sky. The tablelands are quiet in the way that barren landscapes are quiet. There are no trees to rustle, no streams to flow, little animal life to make sound. The wind moves across the plateau, unobstructed, and the sound is a constant low whisper. The light is harsh, reflecting off the bare rock, and the colors are muted, shades of rust and ochre and gray. The landscape is strange and beautiful in its strangeness, a place that does not resemble typical Newfoundland or typical anywhere, a place defined by geology rather than by biology, by processes that occur over millions of years rather than over seasons. From Newfoundland, we return to China, to the province of Yunnan, to a region that has been called Shangri-La, a name borrowed from the fictional Himalayan utopia in James Hilton's novel Lost Horizon. The region was officially renamed Shangri-La in 2001 to promote tourism, but the name captures something real about the landscape, a sense of remoteness and beauty, of being set apart. The Shangri-La region includes the Tiger Leaping Gorge, one of the deepest gorges in the world, carved by the Jinsha River through mountains that rise over 16,000 feet. The gorge is a dramatic landscape of vertical cliffs, cascading water, and narrow trails clinging to the rock face. But there are also quieter places, valleys and plateaus where Tibetan villages sit among fields and forests, where monasteries perch on hillsides, where the pace of life is slow and determined by agricultural rhythms. The high altitude, the thin air, the vast sky, all contribute to a sense of stillness. Sounds carry differently in thin air, and distances are deceptive. The landscape is expansive, mountains visible in all directions, and the sense of space, of openness, is profound. The quietness here is cultural as well as natural. Tibetan Buddhism emphasizes meditation, stillness, detachment from desire. The monasteries are places of silence punctuated by chanting and the ringing of bells, by the rhythms of prayer and ritual. The landscape and the culture reinforce each other, creating an environment where stillness is valued, where quiet is not empty, but full of meaning. From China, we travel to Turkmenistan, to a canyon that few outside the region know exists. This is Yangakola Canyon, a vast erosional feature in the western part of the country, near the Caspian Sea. The canyon is carved into soft sedimentary rock, layers of clay and limestone deposited millions of years ago when the area was underwater. The canyon walls are striped with color, bands of white, yellow, pink, and red, created by different minerals in the sediment layers. The colors are most vivid at sunrise and sunset, when the low-angle light enhances the saturation and creates dramatic shadows. The formations are weathered into towers and ridges, with narrow gullies between them, creating a landscape of sculptural complexity. Yangacola Canyon is remote and rarely visited. There are no facilities, no marked trails, no infrastructure. Access requires crossing desert tracks in four-wheel drive vehicles, navigating by GPS or local knowledge. But the remoteness is part of the appeal. You stand at the edge of the canyon in silence, seeing a landscape that is ancient and largely unchanged, that exists whether anyone is there to see it or not. The stillness of Yangacola is the stillness of absence, of a place where human activity is minimal, where the land has been shaped by wind and water over millions of years without significant human interference. It is a landscape of geology and erosion, of time made visible in layers of stone. We complete our journey in Turkey, at a site we have encountered before, but return to now in the context of stillness and endings. This is Pamukkale, the Cotton Castle, the white travertine terraces formed by calcium-rich hot springs. The terraces cascade down a hillside, each pool overflowing into the one below, creating a series of stepped basins filled with warm, clear water. The travertine is brilliant white, and the water is turquoise or pale blue, creating a color contrast that is vivid and unnatural seeming, like a landscape from a dream. Pamukkale has been known and used for thousands of years. The ancient city of Hierapolis was built above the terraces, its inhabitants bathing in the hot springs, believing the water had healing properties. The ruins of Hierapolis still stand, columns and walls and a theatre overlooking the terraces, a reminder that this place has been valued for its beauty and its water since antiquity. The terraces are quiet in the sense that water is quiet when it moves slowly, when it pools and overflows gently rather than rushing or crashing. The sound is a soft trickling, a gentle flow from pool to pool. The thermal water is warm, and bathing in the pools is deeply relaxing, the warmth seeping into muscles, the stillness of the water inviting stillness in the body and mind. Pamukkale has been damaged by tourism and development. For years, hotels were built directly on the terraces, and vehicles drove across them, causing erosion and staining. In the 1990s, UNESCO threatened to remove Pamukkale from the World Heritage List unless protective measures were taken. The hotels were demolished, access was restricted, and efforts were made to restore water flow to terraces that had dried out. Today, Pamukkale is recovering. The terraces are white again, the pools are filled, and the water flows as it has for millennia. Walking on the terraces, your feet in the warm water, the white stones smooth beneath you, you are participating in an ancient ritual, bathing in the same waters that have drawn people for thousands of years, experiencing the same warmth, the same mineral-laden water, the same sense of being cleansed and renewed. Pamukkale is an ending not because it is final, but because it represents completion, the cycle of water rising from the earth, flowing over stone, depositing minerals, creating beauty, then flowing onward. It is a place of transformation, where water becomes stone, where the ephemeral becomes permanent, where the cycle is visible and tangible. As we close this final segment on quiet endings and stillness, we have journeyed from limestone casts rising from tropical seas to volcanic craters holding lakes, from white cliffs and caves to travertine terraces, from sacred mountains reflected in still waters to canyons carved in ancient seabeds. These are places of rest, of reflection, of the kind of quiet that is not absence but presence, not emptiness but fullness made calm. Let the stillness settle completely now. Let it fill the spaces in your mind. Let it quiet the constant motion of thought. Stillness is not stopping but arriving, not ending but completing. In stillness, you are most fully present, most aware, most connected to the moment and to the place you inhabit. And so we come to the end of this long journey through the forgotten wonders of our world. We have traveled from the shimmering auroras of Antarctica to the quiet terraces of Pamukkale, from ancient stromatolites that have breathed for billions of years to trees that have stood for millennia, from caves carved by patient water to deserts where sand sings and stones move of their own accord. We have witnessed fire beneath the earth and ice above it, living fossils and hidden biomes, isolated sanctuaries and gentle mysteries. Each wonder, different as they are from one another, shares a common quality. They exist. They persist. They continue their slow work whether we notice them or not, whether we understand them or not, whether we are present to witness them or absent and unaware. These are not the famous wonders, not the landmarks that draw millions, but they are no less remarkable for their obscurity. They remind us that the earth is vast and varied, that every landscape holds stories written in stone and water and living tissue, that attention and patience reveal complexity, even in the simplest phenomena. As you drift now towards sleep, let these images and stories settle into your subconscious. Let them become part of the landscape of your dreams. Know that tomorrow the stromatolites will still be building their layers, the ancient trees will still be adding their rings, the glaciers will still be carving their valleys, the water will still be flowing and falling and shaping stone. The world's work continues, unhurried and persistent, and you are part of it, connected by the oxygen you breathe that was produced by forests and oceans, by the water you drink that has cycled through clouds and rivers and aquifers for millions of years, by the atoms in your body that were forged in stars and have been recycled through countless forms before becoming briefly you. Rest now in this knowledge, in this connection, in the quiet certainty that the world is older and stranger and more beautiful than any single lifetime can encompass, and that this is exactly as it should be. Sleep well, knowing that the wonders remain, patient and enduring, waiting in their distant places for the next moment of recognition, the next quiet observer, the next opportunity to inspire or in anyone willing to pause long enough to truly see. Good night, and have a great, relaxing sleep.